started, and want to thank all of you for attending this meeting. Obviously, responsible conduct for research is incredibly important, and we're really fortunate to have a great lineup of speakers today, individuals that have a long career record really in the field of responsible conduct of research. And this is one of those things that oftentimes PIs just kind of push aside, and they don't need to know it until they need to know it. And what I mean by that is when I see Melanie smiling, but when they cross over the line, then all of a sudden the poop hits the fan, so to speak, and everybody gets very focused on responsible conduct of research. So I would encourage each and every one of you to be focused on responsible conduct of research 24/7. You never want to find yourself in a situation where you've crossed over a line and now you've got regulatory bodies looking at you very closely. The other thing I would say is that just a good practice with regards to responsible conduct of research, and especially as it relates to human subject protocols and IACUC protocols, and that is to periodically review those protocols with your research group. And there's no harm in that. There's nothing bad that can happen as a result of that. The only thing that can happen are good things that will make sure that everybody who's on the research team is adhering to the appropriate rules and regulations. That really, I mean, if you sit there and think about that, that's one of the primary factors. And of course, most importantly, there are the ethical and the moral considerations that we face when we're involving humans or animals as research subjects. So thank you all for attending. And with that, I think we're ready to go.
Yep, so we're going to hand it over to Jill Kay to give an overview of the institutional and NIH policy on RCR.
Everyone able to see my screen?
Yep.
Yep.
Okay, great. All right, so thank you so much for having me as part of your program this morning. I have the first couple of sections, and we'll do first an overview of the policies and requirements for RCR, and then we'll talk a little bit about misconduct, research misconduct. So first, the big question, why are we here? I love to spend my Saturday with you all, and I'm sure you do as well, but really this is an important topic for all researchers, as Vince mentioned, but we also specifically have some sponsor and institutional requirements for RCR training. The National Science Foundation requires training for any students or postdocs who receive funding from NSF to receive training in RCR. And at UC Irvine, we have an online course, which is available in the UC Learning Center that fulfills this requirement. For NIH, the requirement is a little bit different. It actually applies to individuals on training grants for NIH. And substantial face-to-face interaction is typically required for NIH. We're in an unusual set of circumstances right now, and so NIH has extended some flexibility to allow us to do this, Zoom format online. But normally, they want to have 8 to 10 hours of actual face-to-face contact. And usually that many people fulfill that by taking the MNMG 250 course that Al Golden puts together that meets weekly over the course of a quarter. And so here we are online, but we'll do our best to try to have as much interaction, hopefully, as we can. And I would encourage anyone to, if you have questions along the way, just stop me and we'll try to answer them. There are a number of main topics that are usually covered in RCR courses. Just the basic policies that we're talking about right now, professional responsibilities, research misconduct, human and animal subjects, as Vince mentioned, and being health sciences, predominantly health sciences folks today, these are going to likely come into play for you. Also conflicts of interest in research, data management practices. We want to make sure we handle our data properly, safely, that it's secure. Mentor and trainee responsibilities, collaborative research, authorship and publication practices, and the peer review process. So research integrity really is more than fulfilling a requirement. It's a foundational basis that really your research career will be based on. And this is going to come up not only today at the beginning as a trainee, but really throughout your career as a researcher. You will face ethical questions. You will face questions as a mentor in the future. Really, this is something that will permeate your activities as a researcher throughout your career. The NIH also now requires a section on reproducibility and rigor. And this is an important piece because I don't know if you're all aware, there were some recent publications that showed that we have some issues with reproducibility in some of our kind of important studies. And we want to really ensure that our experiments are robust. And this all comes back to, again, just this basic idea of integrity. We need to be able to trust the results that come out of our scientific community. And I think if we just sort of step back and think about the time we're living in right now, we have many challenges to trust and confidence in science. And so this is going to be, no matter what kind of research you do, really going to be a focus going forward for the foreseeable future. It doesn't matter what great results come out of a study if we can't be really confident in those and have the trust of the public. So today, let's just try to take in all of the different topics. We have a really great series of topics on the schedule today. Just be open-minded and kind of think about how these different topics might impact your own research. You know, put yourself in the shoes of a person facing maybe an ethical question, and try to relate these things back to your own work, and really try to have fun with it. You stretch your mind a little bit and imagine some situations where you might find yourself faced with an important and maybe difficult question. I think also it's really important to think about how communication and discussion with mentors and being able to discuss some kind of tough issues with your colleagues is going to be an important component of navigating some difficult situations. So I'd just like to show you really quick. This is the NIH's page on RCR. There's an enormous amount of information, publications, websites, books that really dive deep into responsible conduct of research topics, ethical situations, how to exercise and flex your ethics decision-making muscles. And so these are really great resources for a deeper dive, you know, much more than we can go into today. We have some more resources on the Office of Research website as well. As I mentioned, the online course at the UC Learning Center, you can get information about it there and some other resources on the OR website. Okay, next we're going to talk a little bit about research misconduct. And I've been working with this process together with the RIOs for about 10 years now. So hopefully we can kind of go through this and understand like the specifics of what is research misconduct. Research misconduct is not just wrongdoing in research. As you all know, we have many rules and regulations that govern the process of research. But this is a very specifically defined policy that lays out specifically fabrication, falsification, and plagiarism as included in research. So this doesn't include, violations of other non-compliance issues with research in human subjects or things like that. This is really focused in on the data and publications for research misconduct. Specifically, authorship disputes are excluded from this. And one of the reasons for that is that the practices in authorship and publication can somewhat vary by discipline. So we like to really focus the handling of those situations in a way that's discipline specific, and typically refer those to the school, the dean's office, to help sort it out when those arise. So why is research misconduct a big deal? As you can imagine, if someone has made up data or falsified data, the ripple effect of that is far and wide. Research is building on itself. And if there's a fundamental piece of knowledge developed and it's published and other researchers base their work upon it, you can see how far afield you can go based on errant data. There are several kind of high profile cases that really kind of show how important it is to have reliable data because of the effects that this has on also the public. So there was a case at Duke where a cancer researcher had developed a treatment, and it was found that there were fabricated data included in this trial. Clinical trials are the basis of approving drugs and treatments for patients. And so think of the waste of trying a treatment that's not effective. The impacts and the consequences are substantial. In the world of vaccines, we have, and this is of course very relatable today, there was a paper on measles, mumps, and rubella vaccine that linked it to autism. And this was retracted after it was found that data were falsified. And we still today find a lot of vaccine skepticism and people who believe that there is this connection between autism and vaccines in general, and are still dealing with the fallout of false information that got put out in this paper. And then lastly, we had, there was a clinical research coordinator that falsified data in 60 grant applications, multiple publications, and a substantial financial impact to Duke University that settled with the government for $112.5 million. So really, this is a very, very serious issue. These are the most, sort of extreme cases, but you can imagine, consequences all across the spectrum. for having falsified or fabricated data. Oops, too far. Here we go. So this is the website for the Office of Research Integrity. ORI is the oversight body that is responsible for looking at research misconduct in cases where PHS, Public Health Service funding is involved. And that's the unit in the federal government where NIH sits. And on this page, you can read about case summaries of findings of research misconduct that they have made at the federal level. And you can take time to peruse this. It's very sobering to see how these kinds of cases can have really widespread effects. So what do we do if we have a concern about research misconduct? We'll start with who's involved. At each institution that receives federal funds, a research integrity officer is appointed that is responsible for assessing research misconduct allegations and overseeing the process of handling inquiries and investigations and the other processes required during the handling of allegations. So that's the official. At UC Irvine, that person is the Vice Chancellor for Research. However, the VCR can delegate that responsibility to an appointed RIO if needed. The complainant is the individual who brings forward the allegation. So sometimes a person observes what they think is maybe another lab member or someone who has tampered with data or made up results, and they bring an allegation forth to the institution so that it can be investigated potentially. We call the person who is actually alleged to have committed research misconduct, that person is called the respondent. And that sometimes it's one person, sometimes it's multiple, and it kind of depends. Overall, the process of handling allegations proceeds in 3 increasingly formal steps. So initially, we start with the assessment. So if a person comes forward and says, I think I've observed something's wrong here, and describes the situation to the research integrity officer, the RIO then considers what the story that they've been told to determine whether or not does this indeed fit the definition of research misconduct, as opposed to some other form of maybe violation or wrongdoing in research. Does it fit this, or does it really need to be handled in another forum, like we mentioned earlier, authorship or noncompliance, et cetera. At this point, the RIO will make a decision as to whether or not the allegation warrants taking it further to the next step. If the definition fits, sequestration of research records and materials might be necessary at this stage. What that means is to gather and secure potential evidence of research misconduct. And this happens very early in that process, because we want to ensure that any potential evidence is secured before it could be maybe destroyed or tampered with further. If an inquiry is necessary, then an actual committee of 3 members is assembled. And the committee typically will interview the complainant to understand exactly what they believe happened. Usually they will interview the respondent as well. Sometimes at this stage, they could interview experts or witnesses. They don't necessarily need to do that, because the goal of the inquiry committee is to make a determination as to whether a formal investigation is warranted. as you might imagine, in research studies, there's a lot of technical details and very, very specific expertise, depending upon what's being studied in that lab. And so the research integrity officer needs to address questions across the entire campus. And so we don't want to rush to launch a formal investigation hastily. We really want to understand what's happening. And sometimes that's not easy to do, in a straightforward way. We have to understand what's the research about, what's being studied, and exactly what is alleged to have occurred. If the inquiry committee determines that further investigation is needed, we don't have a misunderstanding here. We're not looking at, something that can be basically explained in a straightforward way. Then maybe a formal investigation is necessary. At this stage, if NIH funds were involved, then we notify the Office of Research Integrity at that stage. Then we move on to investigation. And at that stage, again, a committee is impaneled. Sometimes it's the same committee as the inquiry stage. Sometimes it makes sense to impanel a fresh committee at that stage. And it really depends upon the situation, and the research integrity officer would make that determination as to whether a fresh set of eyes is really important to have at that stage. At this stage, the committee will do a thorough investigation, review all of the evidence, sometimes interview additional witnesses, additional experts, and make a final determination as to whether research misconduct has been committed. Again, at this stage, if PHS funds or NIH funds are involved, then ORI is notified of the outcome at that stage. In our process here at UC Irvine, if a finding of research misconduct is made, then that is referred to the appropriate disciplinary body, depending on who the person is. So for faculty member, that would go through a process that involves the academic senate. There's a different process for graduate students or undergrads, or a staff member. So that actually goes out in through an entirely different disciplinary process once a finding is made. And as we saw in a couple slides ago, if the Office of Research Integrity makes a finding at the federal level, they also may do so and post that finding publicly. So these are really two separate stages. We may make a finding at an institutional level, and ORI may or may not decide to pursue a finding at the federal level. They're really kind of two separate decisions. So I'll touch really briefly on the public interest in research integrity. As we talked about a few minutes ago, eyes are on science these days. It's really, science and research is fundamental to all of the major challenges that we're facing in the world today. We have the utmost interest in making sure that research is handled properly, and that we can rely on our results. And there's a lot of scrutiny. We have a couple of publications, online publications, Retraction Watch. You can see the website here, and there's a site called PubPeer, both of which are specifically focused on topics of integrity in research. So they have groups that debate research, question results, and there's a certain amount of that's actually quite healthy for science. Healthy debate in science is an important thing, and it's important for scientists to question each other and to try to reproduce those those experiments and make sure that they're really robust and that we can rely on them. But this is, just a sampling of examples of public interest in the integrity of research results that we have. So next, I'd like to turn to a little bit of a kind of an interactive video. And this is a video that the Office of Research Integrity has produced. And it kind of takes us through an example of a lab and the various members of that lab as they encounter, some situations where they have to make some decisions. I would encourage you, when you have, a little bit more time, you can go to this website, and it allows you to take the perspective of the different characters in the story. And you can walk through and kind of click through and make decisions and see, well, what would happen if I decided this way versus a different way? So, so with that, I'm going to switch us over to the video. And as we go, Marguerite has been kind enough to help set this up so we can do some polling, and we can make decisions about how we'd like to see the characters proceed. So I'll start off with just a little bit of an intro here. We have the ability to take the perspective of multiple people, but I'm going to go through and start with the postdocs experience and decision making, and we'll see how much time we have to go. So before I move on, do we have any questions? Anything about research misconduct or the policies? No? Okay, so let's just start with the intro here. Can you see? Okay.
It was a bad day. It started with just one reporter.
Excuse me, Mr. Ross.
Yes.
Paula Williams, Channel 8 News.
Okay.
Mr. Ross, researchers from another university are questioning some of the recent high-profile findings from one of your labs. Do you have any?
No, I'm sorry. I can't. You'll have to direct these questions to our general counsel.
But Mr. Ross.
Sorry, I have a meeting. A scientist from a competing lab decided to go public with suspicions that some very celebrated research from our university had been falsified.
I think we lost the audio. Can anybody hear it?
I can't hear it.
No.
No, I can't.
No. Am I hearing that you can't hear the audio?
Yeah, it cut out like, I think maybe like 1 or 2 minutes into it.
Okay, let me back up here.
It was a bad day. It started with just one reporter.
Excuse me, Mr. Ross.
Yes.
Paula Williams, Channel 8 News.
Okay.
Mr. Ross, researchers from another university are questioning some of the recent high-profile findings from one of your labs. Do you have any?
No, I'm sorry. I can't. You'll have to direct these questions to our general counsel.
But Mr. Ross.
Sorry, I have a meeting. A scientist from a competing lab decided to go public with suspicions that some very celebrated research from our university had been falsified.
Promising research that it was hoped might lead to breakthroughs in the treatment of diabetes might not be all it first appeared to be. Paula Williams has the story.
We don't hear much about the world of test tubes and lab rats until there's a major breakthrough with major public health implications. Add federal dollars and accusations of fraud to the equation, and you have a potentially explosive story.
I was very interested in this paper. My lab's been doing very similar work.
But it blew up pretty quickly.
Preliminary assessment indicates there are grounds for moving forward and looking into all the research with which this individual is involved.
But
You have decided that further investigation is required to determine whether research misconduct has occurred.
It turned out badly.
9 months after allegations of research misconduct, a young scientist here who seemed to have a bright future ahead of him has finally admitted to falsifying his research.
The investigation turned up multiple instances of research misconduct by this individual over the course of a couple of years. Along the way, there were people in the lab who had questions but didn't speak up. There were people who had responsibility for oversight who didn't properly exercise that responsibility. There were people who knew what was right and didn't do the right thing. And
Is it true the McCrary family is withdrawing their commitment to establish a $30 million research endowment for your university?
well, yes, as you know, they made that announcement today. It just turned into the proverbial perfect storm.
After findings of professional misconduct and with the mounting pressure of widespread bad publicity and more unhappy donors threatening to pull their funding, the principal investigator from this troubled lab who had been placed on probation has finally been dismissed.
The PI was let go, his lab was shut down. Postdocs, grad students, lab techs, all scrambling to find a new place to continue their work. Many while dealing with the stigma that comes from a tainted lab. You know what? It didn't really happen. Oh, I mean, it did, but it didn't. Because with this program, unlike real life, you get to go back in time. You can become a grad student, a postdoc, a PI, or a research integrity officer. You get a chance to enter an alternate reality as any of these characters, walk in their shoes, experience their lives, and practice making the choices that will advance the integrity in research. This outcome can be avoided. It's up to you to figure out how.
Okay, so we have a really dramatic situation here, and we need to put ourselves in the shoes of one of the players and decide what to do. You know, it doesn't, as he mentioned, doesn't have to go this way. But because we have, I think, mostly graduate students and maybe postdocs here, let's walk through from the perspective of our postdoc, Hardik Rao, and see how his role plays out in the situation. Okay, so as we get to decision-making points, we're going to have a little bit of interaction, and we need some input for how we should go forward. So we'll do a little poll once we get to that stage. So let's meet Hardik.
This is you. Hey, Hardik. Hardik Rao. You've been in the States for a while now. You came as an undergrad.
Hi, Aaron.
And now, almost 4 years as a postdoc. You think you're a solid scientist, but sometimes...
How's it going? Banging my head against the wall a bit here.
Sometimes you're not so sure. Dr. Aaron Hutchins, your PI. He's a good guy, but like every PI, he's got a lot on his plate.
Have you talked to Greg?
Nope. And he seems to have a favorite postdoc, Greg Anderson.
His paper got accepted.
Great.
Great.
The truth is, your experiments aren't bearing much fruit lately, and you're seeing Anderson pull ahead. And every time he upstages you, you look bad.
You know, he's going to have his own lab while you're still messing around with that Western.
You know he's joking. At least you think he is. But that one still stings.
I've been wondering what a life outside of science might be.
Your work revolves around a protein called caveolin-3, which has been demonstrated in others' work to be important in insulin signaling. You just want that missing piece so you can get your work published, get your own lab, some financial security. You almost feel like your real life is on hold until that happens.
I still think I'm right about this.
You're not seeing the results you and Dr. Hutchins hypothesized.
Must be doing something wrong.
And that your PI expects.
You know, everything points to this protein being integral.
Sometimes you're not sure if he's just thinking out loud, giving you an order, or suggesting that you make the data fit the hypothesis. But you are sure that Dr. Hutchins is hearing about Greg's work every day and wondering when you're going to produce something as impressive. You think that it would probably make him real happy if you could tell him you're on the verge of confirming his hypothesis. Being on a work visa, you feel that it's important to make the PI happy.
This is the meeting that I'm teaching you later. I need to listen in.
Okay, so what do? We have a little bit of a question mark about how the results are coming out, and we have some options of what to do here. So I think decision point 1 question is up. So if you could all decide, how do you think HARDIC should respond? Okay, it looks like we have 71% are saying to seek clarification and say, are you saying I need to find a way to make this data fit the hypothesis? So let's see what happens if we go with that.
So,
Are you saying I should find a way to make the data fit the hypothesis?
Of course not. The data is the data. We can't make it say what we want. We can't do that, right? There's still rules and whatnot.
Yes, whatnot. And I believe I'm doing the experiment correctly.
Of course, yes. When I say you're doing something wrong, I mean, we must be thinking about this the wrong way, not this one particular experiment. I'm sorry, I'd like to talk sometimes. All right, well, we'll talk a little bit about this later. You got other stuff cooking. So,
all right.
Keep plugging.
and you will.
Okay, so, talking it out, having a little bit of a discussion with your PI, gets you back on the same page. It's that communication piece is going to recur as we go through these. So I'm kind of getting used to this. I guess I should have shared the results, before for the poll. So let's move on to the next section.
So you get back to work, and Neha, your wife.
Hello, honey.
Hey, don't forget the ultrasound this afternoon.
Oh.
What?
Nothing. I just
Let me guess, you've got a lot to do in the lab?
Well, yes.
I'm sorry, is this a bad time for me to be pregnant? Is the baby interfering with your research?
I'm sorry. I wouldn't say interfering. It's more like getting in the way of.
Haha. I know you've been there more than 8 hours already. What time did you get up anyway?
I don't know. I couldn't sleep.
See you at 4:30. It'll be nice to see you awake for a change.
I'll see you there.
You need to leave now.
I know.
Wear your helmet.
I will. Sorry.
Where are you going?
Kim, a grad student and a friend in the lab.
Ultrasound. I have to see if my child has the acceptable number of fingers and toes.
Cool. Are you coming back?
Probably. I love it here. Also, I have to do my 8-hour time point. Needs sleep, right?
Leonardo would sleep 20 minutes every 2 hours. He gained what, like 5 extra hours a day that way?
Leonardo. DiCaprio.
Da Vinci.
You'll try it. Did you have a wife?
I don't know.
You hurry out, feeling guilty for abandoning your research.
Okay, relatable, right? Life still is going on. You're not only a lab worker or a postdoc. Everyone struggles. There's a lot to do. You spend a lot of time in the lab, and so let's see what HARDIC does.
So there's your son.
My son. You can tell he's already a genius.
I can't wait to show this to Mom and Dad.
Neha's parents are visiting from India in a few weeks.
Are you going back to the lab?
I probably should.
And she does her best not to show it, but you can tell your wife is disappointed.
Or I could go to the lab, do the 8-hour time point, pick up some food and meet you back home.
No, if you go to the lab, I'll just go home and go to bed early. It's all right.
Really?
Yes.
You know she wouldn't lie. She's disappointed, but she won't hold it against you.
I'm very tired.
Still, you're fed up with being in the lab when you should be done by now. You wonder how much you can modify your experiment without screwing it up. Could you skip that 8-hour time point? Maybe you could get away with just the 4-hour and the 12-hour. No, that wouldn't be right. You hate to lose the time, but right now you think that your marriage might be more fragile than your experiment.
Okay, so a tough decision. You know, a lot of pressures and different forces pulling him in different directions. So we have our next decision. What does he do? Does he scrap the experiment and spend the evening with his wife, or skip the time point? What do we do? Okay, so let's see. This one was fairly even. You know, it's a tough call. We're going with that you can't skip this time point. It's probably the one that matters most. And at the end of the day, you need to have results that actually are meaningful, right? So let's see what happens here.
You think about everyone else probably working in the lab tonight.
I have to get back to work.
Okay,
The sooner I figure this out, the sooner I get a real job for us.
I know.
Hey, I'll see you.
You get back to work.
Okay, so it's really, you know, tough sometimes, and you have to, you know, juggle those things and get through the moment as best you can.
A few days later.
Break room gets worse every day.
Reminds me of my first dorm room. We had ferrets.
Greg.
Ferrets?
Mhm.
Really?
Yep.
Don't they stink?
No worse than me and my roommates.
Even though you're always aware of the competition between you, you can't help it. You like the guy. Everybody does, really.
Hey, didn't there used to be a rug in this room?
I think so. Yeah. We should find out what happened to it. That rug really pulled the room together. How's it going, JD?
Wonderful.
Really? Wonderful.
Yes. And you?
Great.
He's having a son.
Really? Congratulations, my friend.
Thank you.
But why does he know this before I do?
I hardly see you, man. Working too hard.
That's true. So will you gentlemen be at the RCR training this afternoon?
RC what?
Responsible conduct and research. You know that.
Is that this afternoon?
I completely forgot about it.
I don't have time.
You should go though, JD. You probably need it.
That's true. No joke. I have trouble keeping track of all these rules.
It's pretty basic stuff, JD.
You've been a postdoc now for 2 years. You really still have questions about this stuff.
I'm conscientious too.
You're a real Boy Scout, JD.
No, I don't understand these Boy Scouts. A paramilitary organization for the prepubescent boys. What's the point?
Maybe if you had been one, you'd be able to find your rear end with both hands.
Or distinguish it from a hole in the ground.
You and Greg give JD some good-natured ribbing because it's fun and he's a good sport.
You guys are very funny. You're telling me that you know all the rules.
Yes.
You never do any sloppy work.
Not unintentionally.
Well, clearly you're a better scientist than I am. I'm going to the training.
I'm impressed, JD.
You are out of your element, JD.
I'm an impressive fellow. Also, there will be cookies.
Oh, well, the truth comes out.
Well, back to work.
And later.
Data maintenance seminar downstairs. You coming, Hardick?
It's just an hour, maybe a little more. But it might be the difference between seeing your wife tonight or eating a cold dinner alone. Again, you know all that stuff anyway. So, are you going?
So I'm not sure we even need to do this question because all of you all are here at RCR training. You made the right choice, but let's go ahead and do the poll anyway. Sorry, we don't have cookies though. Online, what can I say?
That's one of the bummers about this virtual training is no catering.
Right, right. Okay. So we only have a couple folks who wanted to skip the RCR training, but most of us are going with yes. So here we go.
So today's seminar is on data management. This is Beth Ridgely. She's Associate Vice President of Research Integrity, otherwise known as the Research Integrity Officer. Beth?
So you get the training. Finally.
Thank you for being attentive. Before we wrap, just very quickly, I'd like to explain to you a little bit about what it is that I do besides this type of training as a research integrity officer.
She fills you in on her role in dealing with allegations of research misconduct.
There's just one more thing. Now, a lot of this stuff you all know, but listen to me. Don't give in to the temptation to cut corners with your statistics, with outliers, with your images. Keep your notebooks in good order. Sloppiness can cause you really, really bad problems. Well, if you ever have any questions, my door is always open. And if it's not, you can always knock.
As you leave.
Oh, you still think you know everything?
Yes. Yes, I do.
How many times have we learned the hard way about good notes?
Yeah. I had to post it and had to recreate an experiment.
A while later, you have a little time on your hands and
Keep your notebooks in good order. Sloppiness can cause you really, really bad problems.
you're actually inspired to clean up your act a little. You gather all the napkins and scraps of paper, permanently affixing them to your notebook. You're able to reconstruct after the fact what you should have been keeping up with all along, writing down the dates and times and every step of every experiment in detail, not skipping pages or even leaving spaces in your notebook. You begin the process of transferring it all into the computer, backing up files, making sure it's properly labeled. It takes a little while, but you feel a little more sane when you're finished. It's not ideal. You should have been keeping up with this all along, and you promise yourself that you will from now on. Turns out that RCR training was pretty worthwhile after all.
So hopefully there's some tips or moments here that you can take away back to your own daily lives.
A couple weeks later, Greg has been reporting good results to Hutchins and getting a lot of the PI's attention. You, on the other hand, haven't had a positive experiment in weeks.
Today's the day, Hardik. Today's the day.
But nothing seems to be working out.
Oh, crap.
I added the wrong antibody to this Western.
Wow. Sounds like something I would do.
2 days of my life I'll never get back. All right, let's try that again.
Hey, Hardik, I made some vindaloo. It's in the break room.
Okay.
You better hurry. It's gonna go pretty fast once these jackals get on it.
JD's lamb vindaloo is your favorite, but now you're behind and you really need to stay on track here.
Tough choice. Does he go grab some food or start the experiment over? So it looks like we want to go with take a break and grab some food. So let's go with that.
So you decide to take a break.
Hey, Jagdish, it's good, man. Hey, how come you don't come to our place and cook anymore?
Because you're always busy with your research and your family life, your wife, my son.
Hey, you just make a paternity joke.
Yes, yes, I did.
I like it. Funny.
Thank you.
What's it been like? A month since you've been to our place?
At least, yeah.
Wow.
You know, this lab will become your world if you let it. It's funny, isn't it? We get on a treadmill and we run and run. And we're waiting for our real lives to start. But you know what? This is your real life.
And you think your friend might be onto something there. You feel better when you get back to work.
Sometimes, you know, you need to take a break, you know, reset, get your stomach filled and a little bit of rest. So that can be a good thing.
Later.
Hello?
Hey, Han.
Hey.
Just reminding you, dinner with mom and dad, 6 o'clock.
Oh.
Oh, what's wrong?
Just the 8-hour harvest is supposed to be at 6 o'clock.
Mm-hmm.
You haven't seen Neha's parents much since they've been in the country. You've been working.
How long will it take?
About 90 minutes.
Hardik, I mentioned this last week.
I know. I'm sorry.
You're mentally ticking through your options. You could risk alienating your in-laws and angering your wife by joining them late for dinner after the 8-hour harvest. You could do the cell harvest now, record it as 8 hours, and be on time for dinner. Or you could just scrap the experiment and restart it tomorrow. Or...
Okay, so now we have a few different options. He's kind of weighing out some different possibilities. What do you think he should do? Be late to dinner, go ahead and do the harvest now, start over tomorrow after a nice evening, or do the harvest before 6 and freeze it. Should be a little departure from the protocol. Voted for do the harvest on time and join them late for dinner. So let's see how this plays out.
You take a deep breath and say,
What if I stay, I do the harvest, I join you as soon as I can. If you eat slow, I may join you by dessert, at least.
Oh, that's fine.
Really? That's okay with you?
Yes, I just thought you weren't going to come at all.
No, I'll just be a little late.
Okay, we'll order drinks and appetizers. See you when you get there.
you're pleasantly surprised by your wife's reaction. And you realize it's possible to split the difference in a responsible way. It doesn't always have to be all or nothing.
So this is, a great example of things turning out well by finding a good compromise.
After dinner, Neha's parents come back to your little apartment to visit for a while. It's a good time, just sitting, talking, enjoying some family time. But
So does anyone want anything else?
I'm fine, thank you.
As you go later, just leave them on the counter.
Oh, it's almost 9:30.
Do you have to be somewhere?
Actually,
Really?
I have the 12-hour harvest.
No one else can do that for you?
No. Neha, you know this. I do this all the time.
Yes, but tonight my parents are here and they leave early tomorrow. We seem to always be having the same conversation, Hardik.
I won't be gone long.
Do what you need to do.
Okay, now what?
So should Hardik go back to the lab or start over in the morning? Okay, so it looks like we're going with go back to the lab to do the harvest, which seems like a good balance, right? He was able to spend some time with his in-laws, but he's heading back to the
Your
lab.
in-laws say they'll probably be gone before you return, so you say your goodbyes and get to the lab for the 12-hour harvest. When you get home, Neha's asleep, of course, and you feel like kicking something, but you fall asleep on the couch instead.
What are you doing up?
Couldn't sleep. Woke up thinking about an experiment I should try.
Hardik, you should go back to bed or back to the couch, whatever.
I will. Tonight. Did you know that Leonardo Da Vinci only slept 20 minutes every 2 hours? He gained a third of a day that way.
Yeah, and he spent that time designing flying machines that can't fly.
And a unicorn trap.
How long are we going to do this?
I don't know. Don't you have to go to work?
I mean, this Hardik, this whole thing.
Oh.
Your big important discovery, which come to think of it, is sort of like a unicorn. A mythical beast that no one's ever seen.
I'm not even sure what that means.
It means that we have been in the state of suspended animation for too long. Look at you. You look terrible.
I know. I feel terrible. I didn't want to leave last night.
You know you'll need the credentials you're working toward, even if you decide to return to your home country.
But I keep thinking, what happens if I keep failing? If I don't give Dr. Hutchins what he needs in the lab, it's dog eat dog there. I'm on work visa. You know what happens if I lose this position.
I know. I understand. I have to go to work. I'll see you.
You wish you had stayed on the couch.
So these are very real life pressures, right?
The next day, you're at the lab bright and early.
What's that?
It's paper.
Yeah. Congratulations.
Thanks.
A little later, Dr. Hutchins has a special interest in your experiment this morning.
So this is important work to the lab, and I'm a little worried. From what I'm hearing, we're gonna get scooped.
No pressure or anything. Although it hasn't helped your popularity at home, your research is on track. So,
I've got the 24-hour harvest in about half an hour. I'll let you know what I get.
no problem. A few weeks later,
Hey, Hardik?
Hey, Kim, how's it going?
All right. Can I talk to you?
Sure. You want to go to the break room?
Let's go outside.
this must be serious.
Okay.
And it is serious.
I think Greg's making things up.
Whoa.
Yeah, I know.
You sure?
Pretty sure. I did the westerns that he used in his paper. I didn't read the paper, I mean, until now. I just signed off on it. But now I'm doing the same thing for another set of experiments, and I'm not getting the same results as in his paper. That figure he published isn't right.
What'll you do?
No, that's the reason I wanted to talk to you. What can I do?
Huh. You didn't expect that.
I'm not totally sure. You could go to Dr. Hutchins?
Yeah, except Greg is his golden boy. I'm just a grad student.
True. You could go to someone at the university.
Yeah, I guess. I don't know. I hate the idea of him misusing data I gave him and of someone getting away with it, but I mean, it's Greg. I don't want to get him in trouble. And if he found out it was me, and Dr. Hutchins, things could get really rough for me in the lab. Plus, people might think I'm just trying to get back at him for...
For the,
Not long ago, Greg told some tales about a drunken amorous encounter with Kim.
I know he didn't need that stuff to get out. And some people think I'm mad at him about it, but I'm not.
She still actually got it pretty bad for Greg.
I believe you.
Greg, of all people, how could he? I don't know what I'm going to do. I'm going to think about it. I just need to talk about it.
I understand.
You understand, but you kind of wish she hadn't come to you. You try to steer Kim toward what you know is the right thing.
Well, I'm pretty sure there's a way you can report this and stay anonymous.
Greg's not an idiot. He'll figure out it was me.
Well, who says you have to do it right away? You could finish your PhD, do it after you leave. You probably should say something at some point.
I guess. But by then, I don't know, I'll probably end up not saying anything.
Well, I'm sorry I couldn't be more help.
You were. I just, like I said, it helps to talk to somebody about it.
Okay.
You go back to the lab, and you think about what Kim told you for the rest of the day. And that night, you're still thinking about that conversation with Kim. It's Friday, so Neha's still up. You watch a little TV, and she makes you rub her feet.
You think someone in the lab might be falsifying data?
Hardik, I never see you because you spend your life in that lab. Can we not talk about it when you do happen to be home?
She might not want to talk about it, but you can't stop thinking about it.
So?
So,
So are you going to say anything about?
Yeah, no, I don't think so. Maybe after I graduate, but even then, I mean, I'll be out of here and who cares?
Seems as if her mind's made up. Do you want to try to change it? After all, it's not really your problem, but you've been banging your head against the wall, and Greg may be getting ahead with falsified data.
Okay, so we have a thickened plot here. What does Hardik do at this point? Okay, so offer to go with Kim to report the misconduct. So a lot of times, the junior members of the lab might look to the more senior members for guidance, support, just help in making decisions. So let's see what happens next.
You think about it for a while.
Hey, Kim, let me ask you, what if I went with you to talk to somebody about Greg, the paper?
Why? It's not your work.
I know, but it is my lab. Why should he be getting ahead if he's just making it all up?
Yeah. This could make you pretty unpopular around the lab if you're connected to it. And if people found out, they'll just say you're jealous.
I know.
The next day, you and Kim find the office of the Research Integrity Officer.
Well, I have to say, I've never heard of two people coming to a Rio, but I haven't been in this job that long either. So what brings you here? First of all, I should let you know that there is only a process in place if you tell me you have knowledge of actual research misconduct. If you don't want to start the process, you can just ask me questions or we can speak in hypotheticals. What if someone did X? Do you understand?
Yeah.
Kim's looking to you for help with this one. What do you tell her?
Okay, so should she speak in hypotheticals or just get right to the chase? It's fairly even here, but we're going to go with just tell her what happened. And really both of these can work, and you can start in hypotheticals and move on to specifics as well.
That's what you say. And Kim gives the Research Integrity Officer a detailed account of what she thinks happened, telling her exactly what to look for and where to find it.
All right, here's a brief review of the process at this point. I'll do a preliminary assessment to see if there's enough here to warrant an inquiry. If this does go in an inquiry and then an investigation, you may be asked to testify. But other than that, you don't have any role. Make sense? Yeah. Good. Now, you can always request confidentiality. Only the people who absolutely need to know your identity will know it. But to be honest, at some point, it may become obvious who made the complaint. At that point, if there is any retaliation, if your position in the lab is threatened because of this, we'll take steps to protect you.
Kim starts the process.
So this is a tough thing to come forward and make a complaint. This is sort of the beginning of that process that we were talking about earlier, where an assessment is made, an inquiry is launched, and they proceed, down the path.
You're in the lab a few days later when Dr. Ridgely and her team arrive to sequester data. A couple months later, Greg gives in and admits that he altered images and fabricated data.
He admitted to making stuff up. He's out of the lab. Maybe out of science.
That's good though. You did the right thing.
Okay, so that condensed what is a very, very lengthy process of going through the investigation. But let's see. In real life, it doesn't go nearly as quickly.
And?
Well, we need to start talking about options.
I don't know what that means.
That means enough is enough. I want your son to, recognize his father. And I'm not sure that anything will change once you finish your postdoc. Then it's just the next rung on the ladder. Your own lab, tenure tracks, then what? Endless conferences and whatever, like Dr. Hutchins?
Yeah, I'm not sure what you want me to do here.
I want you to decide what's important.
Or what? Is it some kind of ultimatum here?
Come on, Hardik. No, that's what I'm trying to avoid.
You're starting to reap some unwelcome consequences of all those hours in the lab. You and Neha go through a pretty rough patch, but you make a real effort to reorder your priorities. You do your best to keep your research in the lab. You still work long hours. You take the time and care your experiments need, but you shift priorities and get more disciplined with your time management. You're home more. And when you're home, you try to really be there, and you find a balance that works for everybody. Almost 2 years later, JD's over for dinner. He comes over more often now. And Neha's putting the baby to sleep.
No, I was wondering what happened to him.
Dr. Hutchins still hears about him somehow.
I'm sorry. I have to go every 10 minutes now.
That's okay. Shamu.
I'm sorry. That was an accident.
And you and Neha have a second child on the way.
Who's Shamu?
Nobody.
This is excellent, JD.
Thank you. It's very easy. I can show you how to make it.
I would rather just have you come over to cook.
Hey, you should learn while you can.
Maybe you'd better learn, buddy.
I'm just saying, we're not going to be here forever. Jagdish's not always going to be around to teach you.
Which reminds me, a toast. Your recent article being published in the most prestigious journal.
Finally. You didn't believe it would ever happen, did you?
Yes, I did. Well, no, I really didn't.
Quite a year, you two. Your second baby is on the way. Any minute it would appear. Little JD.
What?
Anyway, what were you saying about Greg?
All right. I was telling her that Dr. Hutchins still hears about Greg. He's teaching in North Dakota now.
Really? What school?
I don't know.
Is it a state school or what?
It's a junior high school.
Oh.
Yeah.
Well, he didn't belong in the lab, right?
Yes, but I can understand how he can go down that road. I'm not saying it's right. The science has to be sacred, but I can see how you can let the pressure get you. Think that it wouldn't hurt anybody to cut this corner, then that corner, then whatever. I can see how that could happen.
And you remember something your friend said not that long ago.
Because you just keep thinking, if I can get over this next hump, then real life can start. But that's wrong. This is the real thing. We're right in the middle of it.
Exactly.
Yes, you're very wise. Now, what was this about little JD?
All in all, you have to admit, life is good.
Okay, so, we kind of walked through a lot of different situations and factors, and, balance is important, and always, just keep in mind that there's somebody to reach out to for bouncing ideas off of, lean on your colleagues, come to, your fellow members of your lab. And if you really have concerns, I think the important thing is that there's somewhere to go to help sort it all out. So, so with that, if there are any questions at this point.
It looks like there was a question in the chat, Jill. Catherine is asking, when we offered to go with Kim, I thought we might be going to the PI. What are your thoughts on going over his head to the integrity officer without following a chain of command and attempting to loop the PI into the process?
You know, that's a good question. There's a lot of more detail in this. And oftentimes, usually, the PI is a really good starting point, actually, because sometimes it's unclear from the video, from what we just saw, what was the evidence that they saw? What was it that Kim actually observed? And maybe there was a potential for misunderstanding. So I think this is a great avenue, is to start with the PI, start as locally as you possibly can before going to the institutional, Rio. Totally reasonable. And I think this actually brings up a really great point, in that there aren't always really obvious, clear, right and wrong answers. It depends upon the situation that you're in. Interactions and relationships are dynamic. They can shift over time. And I think it's also important to understand that we don't always have full visibility everything that's happening in a situation. And so talking it out with each other, being very transparent, sharing data, sharing information within the lab group helps with all of that. It just reduces the possibility for, confusion or misunderstandings as well. So going to the PI would be a great idea. It's a good question.
Perfect. Well, thank you so much, Jill.
Okay, thank you.
We appreciate your time.
I'll do there we go.
Vince, did you want to introduce the next speaker?
Yeah. Let me just make sure I got the schedule right. So our next speaker is Melanie Fabian, one of my favorite UCI individuals. Favorite because she's a great colleague and has just been a fantastic administrator of IACUC. And also, I do need to mention, since it's Saturday and there are football games going on, if my memory serves me right, Melanie is a graduate of the greatest university in the world, known as UCLA. Go Brewers. Anyways, I really had the fortunate opportunity to work with Melanie as the chair of IACUC. I got to see her actions firsthand. Also, of course, having had active animal protocols for many years, she was an incredibly valuable resource. So we're very fortunate to have Melanie. She brings an amazing wealth of information about every aspect of the ethical use of animals as experimental models. So with that, Melanie, go Bruins.
Okay. And then can you see my screen, or am I sharing it yet?
Not yet.
Okay, let me get back here for a minute. Okay. Oh, there it is. Oh. Okay. How about now? Can you see my screen?
Yep.
Okay, good. We're going to talk a little bit about live animal research at UCI, and unfortunately, I don't have any cookies either. So somebody needs to invent a way to have cookies in a Zoom meeting, because it really is lacking. It's a problem. So as Vince said, thank you, Vince, for those kind words. Vince was my chair for, gosh, what, 4 years, I think. Great chair, great guy. I was the administrator from 2001 until 2020 when I retired. I am currently retired, sort of. I am working on a recall basis to help out the team. And it's been fun. I retired right before the world shut down. So it giving me something to do while I was locked in my house for all of 2020. But the rest of the team is Diana Lee. She's the IACUC administrator. I grew her from a kit. She was handpicked by me, and I taught her everything she knows. She also is very excellent with computer stuff, and she brings her another set of skills to the table. Lori Sather is our senior analyst. She's currently out on maternity leave, but she'll be back next month. We miss her greatly. And Madison Friend is the newest member of our team. She's our IACIC analyst, and she does a lot of the face-to-face work with researchers. So you very well may be working with her. She's great. So the basics of the animal research program: we have a USDA registration number. We are registered as a research institution. We have an assurance of compliance with the Public Health Service that we renegotiate every 4 years. It's basically a very detailed explanation or description of our program. I provided a link there to the OLA website. That's the Office of Lab Animal Welfare at NIH. Since we get a lot of money from the National Institutes of Health, we're good friends with OLA. And we are also fully accredited by ALAC. I'll tell you what the acronym stands for later, but they go just by ALAC International now. All of these items are like the information. You may need this information for grant proposals, and it's all on the Office of Research website. So we've got links there. There's usually a copy of the accreditation letter for ALAC. We just had our site visit this past summer, went really well, and we're expecting a new accreditation letter coming probably in early December. They send the good ones out last, so we have to wait. And like I said, our website has lots of information on it, lots of links, all of the information you need, and plus contact information for the team. We don't list our names. Interesting little tidbit. We don't list our names on the website because animal research is controversial, and we try to keep things kind of private. We'll talk a little bit about that later too. So there are lots of regulations. We didn't make this stuff up. There's the Animal Welfare Act and the USDA Animal Welfare Regulations. That comes from the United States Department of Agriculture. There's also Public Health Service Policy. The Guide for the Care and Use of Laboratory Animals, we refer to that as the guide, and that is a booklet. It's about 150 pages of very specific information about how to run a good program. And then ALAC accreditation, we'll talk a little bit more about that. That is based on the guide and another kind of process of accrediting our program. So we'll talk a little bit about the regulations. The Animal Welfare Act was first passed by Congress in 1966, and it was predicated by an article in Life magazine about the really abominable treatment of dogs in labs. So it's a good thing. It's been modified a great deal over the years. In the mid 80s, there was a real explosion of biomedical research. And so the 1985 amendment to the Animal Welfare Act really went into a lot of detail about research and research institutions. It set the requirements for the committee that reviews all of the research involving live animals, set performance standards for animal care and transportation, and it covers all warm-blooded animals. That's kind of a weird point, which we'll talk about. It excludes rats, mice, and birds. So you're probably thinking, hey, why, we do all these mice, rats, and birds. The USDA regulations cover a really broad panel of animal use. They cover circuses, they cover transportation, the rules about how long a dog can be in the hold of an airplane on the tarmac. All of that is covered in the animal welfare regulations. So it's very broad. So they narrow it down, just because if they had to cover all of the rats and all of the mice in research, it would be a really huge task that they just don't have the bandwidth for. But then we come up to the Health Research Extension Act of 1985, same time that the Animal Welfare Regulations and Act were broadened to really cover research. That is the legislative mandate for the Public Health Service. It covers all vertebrate animals. So basically what it does is it takes the Animal Welfare Act from USDA and expands it to cover rats, mice, birds, reptiles, pretty much anything with an internal spine. So fish, we have a lot of fish. NIH funded institutions are required to adhere to the PHS policy. So if we happen to be an institution that didn't take NIH funds, we wouldn't be required to follow it, but we are, so we do. And the Office of Lab Animal Welfare is the division of NIH that covers it. They're a relatively small office and they're very busy, but they are, they're the ones we make reports to. The species at UCI, we have a pretty broad range of animals. We have the vast majority are rodents. We do lots of mouse and rat experiments, mostly mice. I think it's about 95% of our animals are mice. I think we have a few gerbils. We've had squirrels in the past, guinea pigs, rabbits, sheep. The woodchucks are new. We haven't had any, I don't think they're on site yet, but we do have one protocol that covers woodchucks. Apparently woodchucks are a natural model for liver cancer. Who knew? We have some guinea fowl, and they are part of a skeletal muscle study because apparently guinea fowl, walk bipedally. And so they are a good model for that. They're also extremely loud. Oh man, are they loud, screechy. Amphibians, frogs, toads, axolotls, salamanders, that axolotls actually grow their limbs back after their limbs are amputated. So that's kind of an interesting quirk of nature that we look at. Reptiles, we still do have one researcher that's using alligators. So that's, usually the one everybody asks about. And lots of fish, zebrafish, especially because of their capability of being genetically modified. So key elements of the federal regulations, and now I'm just going to kind of conflate the USDA and PHS because we follow PHS rules. So we apply this to all species. The key elements are a need to justify why animals are necessary, why the research demands the use of live animals. Of course, we minimize pain and distress. There's a requirement to consider alternatives and to document that consideration. Education and training of personnel. It's very important that the protocol explain how people are going to be trained for whatever procedures they're going to perform. Provision of appropriate husbandry and care. That's both at a institutional level, what the university supplies in vivariums, and also by the laboratories themselves. And the establishment and identifying of humane endpoints and ensuring that animals are euthanized appropriately at the end of when they're done contributing to science. A key element is the 3 R's. There was a book published actually way back in the 50s that brought this concept to light. It's important that researchers consider any way to replace live animals. Some things, there's computer simulations, there's maybe use of already harvested tissue, things like that could replace the use of live animals. Reduction of the number of use of live animals. The number has to be justified in a protocol, but it also, it can't be too small, because if you don't have enough animals to prove your point or to get statistically relevant data, you're going to waste the animals that you did use. And then refinement refers to minimizing pain and distress, use of analgesics, appropriate endpoints so that you're removing the animals from the study before they get too sick, basically. Consideration of alternatives, as I already mentioned, is very important, and it is it's a big part of the protocol paperwork and the submission, because it has to be documented. When our USDA inspectors come around, they come around once a year or so, they look at our records and they look at, okay, did Dr. XYZ really consider what his alternatives are? And the biggest way people consider alternatives is through literature searches. Oh, and I mentioned ALAC accreditation. It's the Association for the Assessment and Accreditation of Lab Animal Care. It's a private nonprofit organization. They are based on the guide. What we do is we submit a very large, very detailed application, which is a description of our program. Our program description is probably a couple hundred pages with plus appendices that have everything from room air changes, how often the air changes in the rooms, in the housing rooms, blueprints of the rooms so we can see where the rooms are, lots and lots of detail. And they come out once we submit our program description, they review it, and then they come out and they do an inspection, basically a site visit. They call it a site visit. It's a little bit less scary than an inspection. But they go through and they visit rooms and talk to researchers and look at our records. And it's a rather grueling process. We did it this summer back in July, but it went really well, and we're expecting continuing full accreditation. The thing about ALAC is some funding agencies do require it. So when you're submitting grant applications, they may ask for it. And Department of Defense in particular requires all kinds of extra documentation. In addition to the regulations, we have local policies, which are how we implement regulations. Some of these campus-wide general policies are pretty old, but you can look them up in the policy library on the Office of Research website. There's a regulatory noncompliance policy that explains what happens when something goes wrong. Offsite research activities are research that's done, via subcontract, usually at another institution. The general use of vertebrate animals in research and teaching is an oldie, but a goodie. It still applies. And you can find those if you're interested in the policy library. There are also IACUC policies and guidelines, which are on the Animal Care and Use website, the section of the Office of Research. These are guidance for how to write a protocol, how to get it approved, what the committee is looking for, various aids. We do have an online system for submission of protocols. It's a little complicated, but it seems to work okay. And there is a step-by-step guide on how to use that. And we also have support from IT people that can help you if you have trouble with the website. ULAR is the University Lab Animal Resources. They're the people that actually provide care to the animals. They have standard operating procedures that are very helpful for researchers, that really specific care for animals, how to do things, maintain the facilities. It's what guides their staff in caring for the animals. So these are all developed by our veterinary staff, and they're available through the website. You do have to log. You just have to have a UCI Net ID to get into there. So what activities require review? The Public Health Service Policy is very specific about what it looks for. It's any live vertebrate animal used or intended for use in research training, so students, experimentation, or biological testing, or the catch-all for related purposes. Catches a few things in there. So basically, we look at what's being done to the animal. Is it research, systematic collection of data, discovery of new medicines and therapies, scientific experimentation, basic research, development, teaching. We have some undergraduate basic science teaching courses. We also do a lot of physician training up at the medical center in particular, a lot of testing of products and devices. Our gastrointestinal people up there and the urology staff or faculty do a lot of testing of prototypes of equipment. So they give feedback and get free stuff in return. And so it's an important part of development of getting from the bench top to the bedside. So who does all this oversight? It's the Institutional Animal Care and Use Committee, better known as the IACUC. There's a lot of different ways to pronounce that, but that's what it is. This is a campus committee that's charged with oversight of the animal program. The member composition, primarily scientific members that are faculty with hopefully with animal expertise. Most of our scientific members are animal users themselves, and including our former chair. We also have the attending, all three of our attending veterinarian staff are voting members of the IACUC. We are also required by regulation to have a non-scientific member, who in our case, we have a great one. John Sisson is a science librarian at UCI. He brings a lot of know-how about literature searches and consideration of alternatives. He can also, if you reach out to him, he can help you with documenting your consideration of alternatives. We're also required to have an unaffiliated member, somebody that is completely unaffiliated with the university. And we are lucky to have two. We have one and a spare, a regular and a spare one. And they are just community members that bring they kind of represent the views of the community, of general people out there that might have an opinion about research. So and these are all categories that are required under the regulations, specifically called out. So what does the IACUC do? Obviously, they review and approve activities involving animals. That's the protocol review portion. The committee meets once a month and does a very detailed review of all protocols and proposed animal activities. We're also required by regulation to review the animal program and to inspect all facilities every 6 months. We're coming up now on our fall round of facility inspections, so you'll be seeing us tromping in and out of your labs and asking you questions. We're friendly. Don't be afraid of us. We're really friendly. The committee reviews concerns involving animal use, and there is a method via the website that you can file concerns. There's also a phone number that you can call that is where if you want to remain anonymous, but if you see something, sketchy in the vivarium or somebody that doesn't look like they're doing the right thing, there are ways to report it without identifying yourself. We report to regulatory agencies, and we do investigate and deal with noncompliance. Noncompliance in these cases it's not like the research integrity stuff. It's more having to do with doing stuff that wasn't approved in your protocol, or not following the rules of appropriate animal care. The consequences of noncompliance, the IACUC is empowered by the regulations to impose sanctions on researchers. The lowest one we typically do is put a hold on animal orders while things are being investigated. The IACUC can also suspend protocol approval, and they can terminate your ability to use animals in research. Suspensions and terminations must be reported to OLA and to USDA. Most non-compliance, or a lot of non-compliance, does get reported to OLA. They have guidance about the level. We don't report what we don't have to report, but we do report anything that's serious or continuing, something that's been happening over and over. And OLA does want to know if the work involved, if the animal research involved is federally funded, because they take it a little bit more seriously then. And the important thing to remember is that public health service funds, federal funds, cannot be used to support animal activities in the absence of IACUC approval. So first of all, you may have to pay money back. We've had incidences where experiments were done that weren't approved. And in one case in particular that I can remember over the years, it was a long time ago. It was about a year, and there was a procedure that was performed that wasn't approved. The animals were aged in the vivarium, so they were here racking up the husbandry charges, and all of that funding had to be teased out of the budgets and paid for by other funds. They could not use public health service funds. So it can get kind of dicey. Other players in the program are University of Lab Animal Resources. I mentioned them before. That's our veterinarians. There are vets. We have three veterinarians plus a number of animal health technicians, plus the husbandry staff. The husbandry staff, don't minimize them. They're the ones that do the actual work. And I really strongly suggest that if you're doing animal research, find out who's taking care of your animals and, chat with them, get to know them. They're the ones that really see what's going on with the animals every day. So they are a good resource for information. They are the boots on the ground in the program. They really are the ones that make it all happen. They make sure your animals get fed and get changed, and they actually have eyes on your animals every day. Facility maintenance, vivarium access, EULAR controls who can get into the vivariums. You need to be on a protocol and you need to have received appropriate training. But they control the key cards. Transgenic mouse facility is part of EULAR. It's where they make new mice all the time, special models for various diseases. And EULAR also provides hands-on training. Our veterinarians and the animal health technicians can come to your lab or meet you in the vivarium, observe your procedures or teach you how to do new stuff. So they're a really good resource for information. Other players, environmental health and safety, they work with the IACUC for the Lab Animal Occupational Health Program. What this is a required thing that animal programs have to provide health surveillance for researchers. It's a lot of issues. Some of it is exposure to hazardous agents that might be involved with the animals. Think COVID-19 for one. But other things that could make the people sick, zoonotic diseases, but also allergies. Allergies are really, really common among researchers that use rodents. Seems like almost everybody, by the time they've worked with rodents for a while, develops some sort of allergy. So environmental health and safety through the occupational health program can help you minimize the risks. They can help you with personal protective equipment. And the way they do that is through, we have an online surveillance form that you fill out. You can also opt out of it if you don't want to. But it asks questions about your general health and allergies and stuff like that, and then they review it and they'll get in contact with you if there's any concerns. They can also help you establish whatever PPE you need, personal protective equipment, masks, N95 masks if they're required. So that's a good resource. We work very closely with EH&S, and they're not voting members on the IACUC, but we do have a vivarium representative from EH&S that reviews all protocols. And then controlled substances, there is a section of EH&S, that's actually one person, that monitors the approvals for using controlled substances. And basically it's paperwork. You have to have a use authorization and you have to purchase them in a certain way. They go through EH&S for purchasing. So all the information is on the web if you ever need to look it up. So the basics of protocol review. You need to provide a rationale for the use of animals. Every one of those little animal lives needs to be justified. Justification of the species. Is it the right animal for the research? You need to describe the conduct of experiments, avoid or document the consideration of alternatives, and avoid unnecessary duplication, although a certain amount of duplication is needed to make sure that you have reproducibility. The protocol needs to include details about how animals are sedated, anesthetized, analgesics that are used, post-procedural monitoring, lots of detail. And then it also needs to document the training of personnel. This is kind of a quick schematic of the process. Protocols and modifications that require full committee review are submitted through our website, through the online system. They get a pretty rigorous administrative and vet pre-review, and the committee or the administrator assigns reviewers on the committee. We try to assign reviewers according to expertise as much as we can. So it makes it easier and makes it easier for them to understand and for the protocol to get through. The committee members perform a scientific pre-review, and this gives us an opportunity to go back to the researcher and identify any issues that could be fixed before the full committee meeting. So they have an opportunity to make those changes. Once it's time for the meeting, as I mentioned, the committee meets once a month. They discuss the protocols in detail, make recommendations for approval or whether additional changes are made. There are a number of outcomes. Approved is obviously the best one for all of us, less work. We might require some minor revisions that can be dealt with administratively. If there are, if there are a little bit more scientific based issues or procedural issues, it might be tabled to be reviewed by a subcommittee. That is, in that case, the researcher would make the changes and then send the revised protocol back to us. We send it out for subcommittee review. Or in fairly rare conditions, a protocol will have to be completely rewritten and be resubmitted for full committee review. Some things do not need full committee review. There's a lot of guidance that has come down from under PHS policy and from NIH. Modification requests that are less significant that can be handled by go straight to subcommittee. There's a process, we call it designated member review. The modification request is sent out to all committee members, and mostly everything's done by email these days. All members have the ability to call for full committee review if they believe this particular change needs it. If it doesn't, it can go to a subcommittee and be reviewed by the subcommittee. Goes back and forth by email. If there's changes required, we get the changes made. Process ideally takes about 2 weeks. Sometimes it takes a little bit longer depending on reviewers' availability. A few other IACUC things that I'll just touch upon because they're kind of a little bit more detailed, and we just deal with them as they come up. Interinstitutional agreements. If we have a subcontract from say a private company where maybe they don't have a PHS assurance, so they can't do the animal work themselves, they'll subcontract it to us. Interinstitutional agreement is a document that kind of brings them under the umbrella of our assurance. Offsite research is where we subcontract out to other institutions. Custom antibody production agreements, I'll talk about just briefly. We really don't do them that much anymore, not a formal agreement. And also another thing that IACUC does currently is we provide matches, congruence matches between grants and protocols. We work with Sponsored Projects Administration when a new award comes in. We are required by NIH to ensure that the protocol, that the animal work described in the grant is covered by an approved protocol. So currently that matching process is done by me. And if there's any discrepancies, if there's something missing in the protocol, we'll reach out to the PI and make sure that a modification is made. Let's see. Institutional agreements, they're often associated with small business grants from NIH, where the small business is the prime grantee. These come through the BL and Applied Innovation, which is kind of a pet project of the chancellor, to link up small businesses that are on the cutting edge of drug development or any other kind of development, and link them up with university researchers, so that there's kind of this combination, this synergy of private industry and the university. The prime grantee does not have a PHS assurance, and that's why they need this agreement in place, because we're bringing them under our umbrella and performing all their animal work under our assurance. There's this very specific form. We do not submit it until we're asked to by Office of Lab Animal Welfare. So it's typically when they're ready to make the award, they will come out and they will ask for the interinstitutional agreement. It'll go usually to the small business, and they don't always know what to do with it. So they send it to the UCI PI, and they send it to us, and we figured it all out. And so it's basically one of those things where if you get one, just give us a call or drop us an email, and we'll help you walk you through it. Offsite research is where we are contracting out things, like maybe you have a colleague at Yale or something that you want to do research with, but it's our managed funds. The funds are the prime grantee is UCI, and the funds are going to the other institution, usually through a subcontract. We try to make this process as easy as possible. If the other institution has all the right credentials, they're PHS assured and ALEC accredited, we'll just accept their review and approval of the animal work, and we'll record it here so that we can keep track of it and make sure that it stays in an approved status. But we try to make these as administrative and easy as possible. And custom antibodies, where we're supplying an antigen or something to be injected into an animal, and then they collect the antibodies. The only caveat on these is if NIH funds are used to pay for them, we need to make sure that the lab has an OLA assurance. If they don't, then we would ask the researcher to find other funds to pay for it. That's pretty much the only, we do have, I think it still exists on our website somewhere. There's an actual form. I haven't seen one of those forms in years. I don't think we're really using the form, but as long as we can document that the offsite lab has the right credentials, we're good to go. In fact, I had a question just this week. Somebody wants to pay a contract lab to do some actual animal research with an antibody that they've developed in the lab, and they're fully PHS assured. They documented it in the vertebrate animal section of the grant proposal, so there was nothing we needed to do. We just verified it, and they're good to go. I'm going to wind up here talking a little bit about the animal rights movement. On the one hand, you have PETA and my own personal unfavorite Physicians Committee for Responsible Medicine. They are not particularly physicians, and they really don't care about responsible medicine. They are a subdivision of PETA, of the People for the Ethical Treatment of Animals. And on the other side, we also have Foundation for Biomedical Research, which is a wonderful resource for us, and California Biomedical Research Association. These are lobbying groups that support research. Speaking of Research is a organization, you can Google it. It actually started up at UCLA, and it was started by a researcher who had been the victim of sabotage and a lot of anti-research and animal rights activism. So there's a growing movement toward transparency in animal research. Diana Lee, the IACUC administrator, is really working on that as part of our program to be more, to be more outgoing, more forward facing as far as what we do. We want to be proud of what we do because we do good work and we take good care of our animals. So it's, the tide is kind of changing. The animal rights people, though, we're seeing fewer of these kind of staged protests, people dressed up in mouse suits on the street corners yelling with signs. What they're doing to us now is through the Public Records Act, California Public Records Act. As a California supported institution, all of our records are public and they're subject to request by the general public. So I call it death by 1,000 paper cuts. They want copies of everything. So that seems to be their operating mode right now, of just annoying us until what? I don't know. We're not going to quit. The animal rights movement, for the most part, they believe in personhood for animals. They believe animals are exactly the same as human beings. All sentient beings deserve equal moral consideration. Ingrid Newkirk is the founder of PETA. She once was quoted as saying, "A rat is a pig, as a dog is a boy. They're all animals." So my dog and your kid are on the same level. They believe that animal-based research is never justified. They don't really believe in pet ownership. Our dogs and cats should just roam free. Food and fiber production. So they're very, very militant. On the other hand, folks like us, we are animal welfareists. We believe that animals and man are not equal. The animals don't have the same rights as people. I tell that to my dog who wants to mess around on the carpet, but actually we have a responsibility for stewardship. We have an obligation to protect the welfare of animals, to make sure that they are cared for, that they are provided food and shelter. We limit their pain and suffering. And this is really the foundation of contemporary animal welfare regulations, and it's how all good animal programs operate. So are animals useful? We think they are. Animals are biologically similar to humans. They can also be genetically modified to be even more similar to us. Lots and lots of mice have been humanized, so they react to infections and disease processes similarly to how people do. And with the added advantage, like say, for example, the transgenic mice that show Alzheimer's disease, they develop the plaques and tangles, but they develop it in a lifespan of a couple of years. So it's, you can actually see the process, where in a human, it's, it might take 90 years. A lot of animals have very similar organ systems. Pigs are used a lot with in urology, in cardiovascular research. Their hearts are very similar. Their skin is actually very similar to human skin. And like I said, the genetically modified rodents are excellent disease models. They can be modified so that they're immune compromised. And so they're really, really valuable in research. And right here at UCI, we have lots of examples of research involving animals that has been published, has been really important in the advancement of science. Our friend, the coronavirus, early in 2020, I got a call from one of our researchers who was trying to get a modification going to his one of his viral study grants to use the SARS-CoV-2 virus. And so I helped him walk it through it. We got, it was mainly having to do with breeding the mice that are subject to it. And we got it, covered pretty quickly, got it approved. And he was so appreciative. He was like, "Oh, Melanie, thank you so much." And I said, no, don't thank me. Just get to work and get me out of my house. So, it's important that you guys, what you guys are doing to all of us to get us out of the house. And just to kind of sum up here, there's a number of medical and science advances. These are talking points for cocktail parties, if you need them, to bolster our point of view. The animal rights people are very loud, so we need to try to be loud too. Prior to the 1900s, they discovered smallpox vaccines because the milkmaids that were milking the cows would not get as sick when the smallpox would come through the town, and they teased it out and figured out it's because they were being exposed to cowpox, which is a similar virus. They were getting immunity to smallpox, so kind of an accidental thing that benefited us all. Insulin would not be around if not for dogs. Dogs are very important in the study of diabetes. We don't have any dogs at UCI, but we actually use a lot of pigs in insulin studies and diabetic studies. Development of anesthesia. Now, aren't we all really happy about that? That's a really important part of science. Antibiotics, super important. Polio vaccine. Some of us are old enough to remember when they all lined us up and gave us sugar cubes for polio. 70s and 80s and beyond, disease diagnosis, prevention, AIDS research, obviously the vaccines for COVID-19 animals were instrumental in the development of that. Treatment of diseases, reproductive technology. A lot of what we use to create mice, genetic models of mice, are the same technology that's used to treat infertility. Kind of interesting. Premature newborn care, and this is where I get personal with my presentation. These are my little grandsons, Jonah and Ethan. They were born in 2013 at 28 weeks gestation. They were teeny tiny little people, but everything that touched them was straight out of animal research. The prenatal steroids that their mom got before they were born to develop their lungs, that came from research with sheep, because apparently sheep are prone to premature birth, and if they give them steroids before they give birth, the babies do better, the lambs do better. Lung surfactant, the minute they were born, they got lung surfactant. Management of their O2. We had a researcher in the past at UCI that was studying retinopathy of prematurity, which comes from too much oxygen. So they ramp down the oxygen on newborns that are premature. And here the little monsters are today. They're 8 years old. They're perfectly healthy and total monsters. I had them yesterday. They drove me crazy, but I love them to bits. So that's the human side of research from one grateful grandma. So questions? Let's see, I don't think I can see. I'm going to stop sharing. Oh, there's a
Melanie,
chat.
I love the end of your presentation there with the kids. That's fantastic.
Yeah, see, I have to, I shamelessly exploit my grandchildren every time I give one of these presentations.
It looks like
they're what? Are they 10 years old or 8 years old now?
They're eight, third grade.
Yeah.
They fight like they didn't even know each other.
It looks like we have a question from Mitchell. Do you want me to read it to you, Melanie?
I can see it here. It says, a question from my naiveness. If we will be learning a new experimental technique on animals that will likely be a failure the first few times, do we need specific documentation on our protocol on this? Or is it understood that the new techniques won't be successful the first time around? That's a really good question. And most reviewers or most researchers, it kind of depends on what they're doing, but sometimes they'll allow a few extra animals for training. And that's certainly a justifiable reason for having animals. Obviously, you got to learn how to do it. And especially if it's a complicated procedure. You would document that in your protocol. You put a special section in there for, we're going to need however many you think you're going to need to train. And yeah, that's not a problem. Anything else?
I'd just like to add, go ahead.
So, sorry, this is Stuart. I wanted to just say that I just sent Marguerite a link to an article on the importance of animals in developing the COVID vaccines. It's the latest, I think, highly relevant information regarding the contribution of animals of animal research. Marguerite, maybe you could send that out to the class. This is by Matt Bailey, who's the executive director of the Foundation for Biomedical Research, which Melanie mentioned. By the way, I'm on that board of the Foundation for Biomedical Research, and they do a lot of things to really try to protect people who, shall we say, encounter activities of PETA. Melanie, I just had one question, and you mentioned FOI, and I wondered if you might want to comment on something that is, maybe something that a lot of people don't think about, which is taking photographs and movies of animals in research. Do you want to say something about that? Thank you.
Yeah, I'm glad you brought that up. We strongly encourage, obviously researchers, especially the behavioral people, take videos of experiments. We strongly encourage that you record the data and then get rid of those videos, because we are getting requests from these people that are coming through the Public Records Act for videos, for photos. We don't keep any of that as part of the protocol. In fact, if you submit a protocol, sometimes a picture helps to let the reviewers know what's going on. But most of the time, unless it's a really innocuous photo, we'll get rid of it. We won't save it as part of the official record, so that we can honestly say when these requests come in, oops, we don't have any of those. And I know we have had several requests for videos, and I've reached out to the researchers that are involved and say, you don't have any, right? You don't have any videos. And most people, I think, do. They put the undergraduate in front of the video screen and have him record the data that they're getting from it, and then they destroy those videos.
Right. Just to say, if you send it by email or even by message on your phone, that is subject to FOI.
It is, yes. And we found that
all kinds of little things.
I know they're really smart. These people are really smart, and they're trying to kill us with all these paper cuts. It's really annoying. It takes so much time to collect all these documents, and then our Public Records Act office goes through them and redacts everything. But it's tremendously time consuming.
We've got to move forward. Melanie, first of all, thank you so much. Number two, oftentimes in organizations, you'll find that the individual who's responsible for leading that group really sets the example. And Melanie and the group that has worked with her and the entire vet staff are phenomenal individuals. They're fantastic to work with. I just want to say, if you have the IACUC show up at your lab to just do an annual review. Don't be intimidated by it. Everybody on IACUC is all working towards the same mission, which is to allow everybody to do their work and do it effectively. So Melanie, thank you very much for that.
My pleasure.
We're gonna, yep, great job. We're gonna take a 10-minute break and we'll come back at, we'll say 11:20. So we'll be only 10 minutes off. And then at that point, we'll look forward to Mirza Salazar's presentation on collaborative research. So we'll see you guys in about 10 minutes.
Thanks,
Thank you,
Tim.
Melanie. Thank you.
Hi, Marguerite. Can you hear me?
Yes, I can hear you perfect.
Okay. I'm using a different headset. Hey,
And I
Vince,
can
how's it
hear you
going?
perfectly.
Cool. How are your babies, your grandbabies? One, right? And maybe two now?
Two. Yep.
Oh, so happy everything went well. How is
Things are looking
mom?
good.
Yeah,
She's doing fine.
good. Good, good. You guys are still watching the grandchildren during the week?
Yeah, my wife primarily. She's got a new job.
At least she's got a lot of experience. So I'm going to keep this to 40 minutes so you guys can get back on track.
Great.
That sounds great, Maritza.
We got just a few more seconds here before we get going.
Cool.
All right, it's 11:20, so let's get started. We're very fortunate to have Dr. Mirza Salazar joining the program today. Mirza came to UCI, I believe, was it 2016?
Yeah, we're going on 5 years.
Wow, time is flying by.
Mm-hmm.
Just a quick background on Mirza. She got her bachelor's degree at Stanford University, then went to USC, where she got a master's degree, and then to New York University, where she got her doctorate degree. And we first met her back probably, it may have been 2015-ish or so.
Mm-hmm. Mm-hmm.
And she came to give a talk to the Institute for Clinical and Translational Science, and it was on team science, if I'm not mistaken.
Mm-hmm.
And that blew me away because I was sitting there thinking, now this is very cool that there are actually people out there who are trying to understand how to more effectively bring groups of individuals together. The only thing I'm concerned about, Maritza, is going out and looking at the web. I see that you're affiliated with the USC Center for Effective
Organizations. Uh-huh.
So I have to come back to my UCLA
I
roots.
know, Vince. It's a
We're
hard
going to
line.
have to give you a complimentary degree from UCLA or something like that.
Exactly.
Anyway,
Exactly.
we're really fortunate to have Maritza with us. She truly is an expert in collaborative research. I tend to think of it more as team science, and she's recognized as a national authority in team science. So with that, Maritza, the show is yours.
Thank you so much, Vince. All right. So first of all, I want to say thank you for having me. And I have to say that I would love to actually see all of you. I often say that in this university environment where we are so virtual, often we're interacting. And I think if we were all at the same Starbucks, would we even know that we spent the day together? And often the answer is no, because all we see are the little pictures. Moreover, what I'm going to talk about a lot of what I talk about is what makes a productive scientist. And often someone who is quite productive is someone who has a network, someone they can say, hey, I know the pharmacist, I'm able to recruit them to be a part of my study, or, oh, I've got this data, but boy, I don't know anybody in computer science, and they're networking and they're figuring out, who to work with to get the job done. And so I want to suggest to you that this day together is an opportunity to meet your UCI colleagues and learn more about them and build your own network. So if I can ask you to turn on your camera, and I will be asking you to participate at various points in time. So I'm going to focus on conflict and collaboration today, which, Marguerite and Vince said we're going to talk about the responsible conduct of research. And I'm going to give you why I think this is the right topic in a moment. But Vince shared a little bit of my background, and I want to make sure I start with how I can support you today and moving forward into your career. So I am at the business school. I'm in the organization and management area. So my primary student base consists of MBAs or executive MBAs. And nationally, I'm the founding president of what we call Insights, the International Network for the Science of Team Science. The work I do on team science, I help all the seed teams that come through the Vice Chancellor for Research. I'm increasingly helping the seed teams out of the Cancer Center, and then also, all the teams that come through with ICTS funding. And the way that you can get half an hour of consultation time is by clicking that link there. It's a free consultation through the ICTS, at least the first couple. I do have people that I work with on an ongoing basis for a fee, but that's it's always good to start and touch base. Let's say you're on your own and you're struggling with something related to leading a team, forming a team. Perhaps you've hit a bump along the road. You can always check out our website, the Team Scholarship Acceleration Lab, tsal.uci.edu, where you can also find a number of resources to help you and your team do better. So, what is team science, or as it's commonly being referred to now as convergent science? It's the study of what helps people work together, especially when they're studying a shared phenomenon of interest that's quite complex. Now, you can study that phenomenon from a single discipline, but we do see an increase of cross-disciplinary or multidisciplinary engagement around problems. And that's especially the case as we've come to understand biological systems, not separated by organs, but rather more integrated. Problems are manifesting themselves with, basis in the gut and manifestation in other areas of the body, right? For all of these reasons, we're finding that we're interacting across data, samples, populations. And so this complicates teamwork and the process of being effective together as a group. And so this notion of the lone scientist exploring, answering complicated questions by him or herself at the bench, is more and more an obsolete view. Rather, we're talking about a set of people, going from 3 to 5 all the way up to some projects in physics that include, dozens upon dozens of collaborators around the same machine. I could substitute this slide with other advances in science and healthcare, but what I want to advocate is that the way that we've tackled seemingly intractable problems is through coming together in teams. And doing so requires a scientific vision. It requires bringing the right people together. It requires clarifying the problem, challenging assumptions about what goes into solving that problem. And it is very, very labor intensive, and something that a lot of people don't actually endeavor to do until much later on in their career. So if we go back to this question of, well, why is she going to talk to us about conflict and decision-making and conflict that arises? Well, often if you think about it as sort of a fiscal responsibility, each of you on this call has been given some amount of money from NIH to do what you said you would do. And the number of times that teams are funded and fall apart is actually quite incredible. So this data here, over a decade old, but I think still holds, studied 500 NSF funded teams and wanted to see, let's look at their outcomes, knowledge outcomes in terms of their products like papers, publications, patents, technology, and see, what led to those outcomes. And essentially, the more diverse the representation of membership was, and the more universities present in the team, the least likely they were to produce those important knowledge outcomes that they were given money, to create. And to me, when I see this data, I think maybe it's a limit of the scientists and the technical knowledge. Maybe it was a limitation of availability of data, but most likely we're talking about human interaction, social biases, other challenges, power, politics that limit why a team has a hard time working together. And so while there's great strength in bringing together numerous people who bring various frameworks, tools, methodologies, approaches, insights, at the same time, seeing the common phenomenon differently creates these gaps in understanding. And, if I may, I'll even say that, who is engaged in science is fundamentally changing. We have more women. We have more underrepresented minorities. We're now including community partners in what we define as a scientific endeavor. I think, we also have less visible minorities as individuals are coming to the table, perhaps with mental health challenges that are not, again, visible to the eye. Perhaps they are a sexual minority, and that's something that's hidden from the group, but it's part of their identity and shapes the way they think about behavioral interventions or sampling, etc. So we find ourselves with complex problems, and we layer on top of that the challenges that come with bringing together people that are different and, that might make assumptions around differences, and it can create conflict that can actually hold a team back. So conflict, if I can define it for a moment, and hopefully lots of you recognize Calvin Hobbes, but workplace conflict or conflict in the lab is something quite common. And it happens when we bring together people who have different backgrounds, work styles for some common purpose. And this conflict can have a big impact on performance. And I'm going to argue that it's not, we are going to have conflict. It's not, trying to avoid it. It's not hoping it never happens. It is just going to happen. The question is how do we manage it? And are we producing more of the productive sources of conflict than those types of conflict that are quite destructive or dysfunctional? So I'm going to stop here for a second and ask some of you on the call, if you wouldn't mind, you don't have to name names. I really don't want to hear all the juicy details or personal details, but what comes to mind as you're thinking about conflict or misunderstanding in your own labs or in projects, maybe with a mentor you had, anything anyone would be willing to share with the group? If not, I will cold call.
This could be a free team science consultation right now for anyone who wants it.
Let's see. Kim, are you on the call? Are you there at your computer?
Who is it?
Tim Morgan.
Yeah, I'm here.
Hi,
so,
Tim.
Yeah, hi, can you hear me?
I can. Mm-hmm.
Okay. Have we had conflict? Yeah, we've had conflict. It's with, quote, people we don't get along with. They can be kind of abrasive in the way, in our perception. Sometimes they demand more from for what they need. Those sorts of things. It's kind of an interpersonal conflict.
Mm-hmm. Good. So Tim is bringing up a couple of different pieces, right? He's saying, gosh, it's a style with which people When there's conflict, the way in which they interact with Tim, he finds it to be aggressive and abrasive. Those are very strong words, right, for a scientific colleague. The second is to talk about the aggression, right? They demand this, they require that, they, and that can be disruptive to the day, disruptive to the project, and you've got to figure out how to problem solve it. Good. Let me hear from, is it Sibylla? Hi, Sibylla.
Hi. Yes, I think so. In our team, not necessarily my current team, but in the past, sometimes there are mismatched expectations, right? Especially across different levels of seniority or different levels of responsibility or power.
Can you give me one example of misaligned expectations? Are they unspoken? Are they explicitly said?
I think that so it's a little bit between those two. So sometimes I'm thinking of sometimes expectations that are initially unspoken, but then they emerge later as conflict, in the sense of like, why didn't you do X? Or, why did you do Y? So yes, there are sort of like maybe assumed but unspoken.
Excellent. And you particularly see it across levels of seniority where maybe someone senior is assuming that their junior trainee, their postdoc already knows, but in that gray space, they might not know. And then there's conflict, attribution. Oh, they didn't, they're lazy. They're not trained, they're not qualified, whatever might come about, right? Give me a thumbs up if you have it, and it can be a virtual thumbs up, if you have experienced conflict at work, in the lab, in your research endeavors at least once. Some of you are conflict, yeah, right? So this is a very common experience, and it can be frustrating, and it can create all kinds of outcomes, which I'm going to discuss right now. But what I want to say is if we're talking about this equation of we have a great question, we write a beautiful proposal, all the right people are around at the table, and we have 2 years to do our work, and we haven't really clarified our roles. We go, wait a minute, I'm the postdoc, it was my idea, but the senior PIs, they're making way more money on this grant, even though I'm running around like a crazy person. And we barely paid the pharmacist any money and everyone's mad. Well, guess what? This promising project all of a sudden starts to, less people are showing up at a meeting in year 2. Then the authorship comes up and people are annoyed again. And you finish the grant and no one wants to work together again, right? And so to me, this is not responsible research. This means somewhere along the line, we could have managed this better and really said, hey, we're stewards of federal money to make sure that the science gets done with the talented people we have, working on this particular project. I'm going to pause here really quickly. Vince, can I ask for any reactions that you have to the general dialogue or this notion of conflict and the scientific endeavor and responsibility?
Well, I think everything you said, I've experienced. And I've experienced it in, probably the entire spectrum in terms of somebody threatening another individual with bodily harm and, on into much more passive forms of aggression. But I think I haven't seen it all and heard it all, but I've seen a lot and I've heard a lot.
That's right. Yeah. And, before I went to get my PhD, I worked at an employee assistance program, again at USC, Vince, with all of the employees and departments and faculty. And you'd be surprised how much physical violence happens in the workplace, right? It's not like all of a sudden we leave our homes and the ways we saw adults around us manage anger and frustration. It's not like we shed those ways and all of a sudden with a PhD become different people, right? We know more, but our behaviors might not be any different. And so while we don't want to see violence, it's not something that, never happens. So anyhow, yeah, violence does manifest, or anger does manifest in a lot of different ways. So we disagree about a lot of small and big decisions in the workplace, right? So as every year they say, gosh, we have an FTE, right? An opening to hire a full-time faculty, or there's money for a postdoc. And here we go again. Everybody's got their camps and their groups, and they're vying for, no, the department needs to move in this direction. We need someone that can do X, or, the other group is saying, no, we need somebody who can do Y. We have conflicts in our clinical practice as we're trying to figure out scopes of, treatment plans and who should do what, and operational decisions. In our labs and teams, we have conflicts about what should we work on next? Where should priorities go? Who should be author on first author, second author, third author? When I often see conflicts come my way as well, it's these two people can't, I'm having a hard time. They don't want to work together anymore, but we wrote them in the grant to do so. Can be quite challenging. And even on our lunch breaks, right? Especially in these times, we are more polarized than ever. And whether it's talking about vaccines, or talking about politics, or talking about whatever it might be, right? There are just lots of opportunities today for disagreement. And this disagreement, right, like I said, can come from various sources, and it can shape our perceptions and our judgments of our coworkers. And in the process, like those words that Tim said, abrasive, aggressive, Vince is talking about physical movement and loud voices, right? It suggests that this is also an arousing experience in a negative, it can be an arousing experience in a negative way. And the result of that can be some outcomes that are pretty dysfunctional for our productivity. So these sources of conflict, like I said, can be goal incompatibility. And this can be, again, different people in your own department who are saying, no, we need the theoretical scientists, not the experimentalist, or we need the more bench scientists and less clinical people. It can be differences in what people value and believe. We can have our dependencies on one another can shape the way that we work together. We can sometimes engage in a process of interfering with one another's work, asking it to be changed or modified. And you might not always agree with why your advisor or lab PI, you might not always want them to change the way you're doing your work. And that can create conflict. Sometimes there are scarce resources. Only one person can be flown out to that conference to present. And it can create anger about, well, why? How come them and not me? And that here we are again in a disagreement. And then I think one of the primary ways in which we can avoid conflict is to reduce ambiguity. And this is to the point of, I think it was Sibela, I'm not sure I'm saying your name correctly, but we assume, we say, oh, you do a good job on that lab assay, or whatever it might be. And I said, well, what does good job mean to Mike versus what does a good job mean to Jackie versus what does it mean to Sage, right? They're subjective terms, and we assume that everybody interprets good work in the same way. Without being explicit, we leave a lot of space for interpretation and misunderstanding. So here's where we end up going, right? So I'm going to talk about what we call a ladder of inference, and it provides a framework for saying, well, how do we actually make sense of these moments when decisions have to get made? And essentially, we go from seeing some behavior, and let me give you an example. Let's say some of you have a postdoc or somebody who's working for you where they've had the data for a long time. Maybe it's been 2 weeks, 3 weeks, and you're saying, well, send me a write-up. Send me the method section, please. And you're not getting it yet. They haven't sent it. And so in that waiting time, you're thinking to yourself, they're not motivated. I wouldn't have waited 3 weeks to send my advisor this work. You're thinking they're lazy, right? Perhaps you're thinking, oh, maybe they're off working with someone else and this isn't a priority for them. And there are a million different assumptions that lead you to some conclusion, right, about who they are. So by the time you get together to talk about the status of the work, you're now coming with this lens through which you're seeing the person and the situation. And because we are uninformed, we end up, again, arriving at some endings that are maybe not accurate. So when we think about performance management and conflict, this is a great idea to just check in and say, hey, student, I'm, wondering what's going on. Like, do you need, is it ability? Is it challenge with actually figuring out what to do with the data? Are you struggling with the writing process? Let me see if we can, why don't you just send me a couple of sentences and we can get started? I'd like to, or, are you okay, right? Is something else going on in your life where, is your mother sick? Is whatever, are you breaking up with someone? Like what's going on that there might be before you jump to all of the other attributions about who they are. But I'll give this as a micro example of the way in which we see something happen and go through the ladder of inference like a wildfire, making all of these conclusions about who we work with. And this just creates this polarization between individuals in the workplace. Never mind, right, the fact that we can take these inferences and even say, oh gosh, it's because they're female that their math isn't good on their analysis. Oh, I have an African American or Mexican student. Oh, they're lazy. That's it. See, this is why I didn't want to do the DEI thing with my hire. Here we go again, right? There are all kinds of lenses that we can put over our perceptions of why something is or isn't happening, rather than drawing on logic and fact. So one way you can engage more responsibly in the conduct of research is to give people the benefit of the doubt, or at least open a dialogue and say, hey, you know what, our grad students are supposed to be working together. I'm not seeing a lot of progress. Can we talk about what instructions did you give? What can we do to support better? Like engage in constructive dialogue. Because when we have conflict, right, we end up, again, disappointed, angry, frustrated, sad. Some of you might have a hot temper and that only ends up in explosive scenario. Some of you might go quite cold, right? Maybe you grew up in a rather rambunctious home environment and conflict just, you want to walk away from it and you want to just not deal, right? And you go so flat that you're running in the other direction rather than trying to ask those critical questions. So it's always important, in my opinion, to ask yourself, gosh, is this emotion controlling me? What is it exactly that I'm feeling? Is there something that I can learn from this emotion? And if I share how I'm feeling right now, is it functional? Or should I maybe walk away from it for a little while? Now, I want you to think about some of the most prolific and productive PIs. Like I think at UCI, there are several. And very few of them can you imagine being angry, right? Often they're collegial. They listen very well. They pause quite often. They're checking in, whether through email or other sources. And this suggests an amount of emotional intelligence that's coupled with scientific leadership, because the science becomes a human endeavor. You're a manager, right? And so for some of you, you're thinking, gosh, lady, I signed up to be a scientist, and it's the technical that I love. And I want to open your mind up to say the responsible conduct of research, the effective stewardship of federal funds, is to also say, gosh, do I have the skills to bring the most out of people and to manage these difficult moments and emotions as effectively and smoothly as possible? So we have two types of conflict, though, that I want to say, if you can encourage them and create moments for them, it's great for the science, right? One is content, and this is focused on the issue, on the work at hand, saying, gosh, is this the design we want to use? Is this the control sample, the control design relative to the experiment that will really get us to an answer? You want to ask questions that are constructive, challenging, not accepting the status quo, but really challenging the process and the science. And so if you're creating a work environment, and I'm looking at all of you who now have students working for you, where you're saying, you know what, I'm threatened and I need to always be the one that seems like they know everything, then I'll say, gosh, I'm going to guess people around you are afraid to speak up. They're afraid to question. They're afraid to really say, gosh, Dr. Cayozo, what if that's not the reason we're seeing this result? If you're creating a space that is not what we call psychologically safe, you're not going to get those great alternative ideas that push the science forward, right? And you need other people to be involved in the creative process. The second kind of conflict that can be very productive is procedural. As the group is saying, gosh, is this the most effective way we could be running the lab, the experiment? Are there any process improvements? Do we need, some of you might be saying, gosh, are we at a place now where we need a clinical coordinator? Would it help us if we had somebody running this more efficiently because of the number of experiments we're running at the exact same time? As we moved into this virtual space, are you saying, gosh, do we have a live Google document for every meeting that we're having online so we can keep track of our material? These kinds of questioning of how could we meet better? How could we capture our thoughts? How could we run our studies better? This dialogue you want. And you want to be sure, right, if your body language is always like, well, I set the rules, I'm the boss, I'm the one who's the king scientist or queen scientist. No one's going to say, hey, here are my ideas, right? So we want to make sure we're encouraging this kind of conflict. On the other hand, so this kind of conflict leads to better decisions, creates new ideas and alternatives. It strengthens team dynamics and that individuals feel empowered, they feel involved, they feel committed. And often when you think about, your processes, you start saying, well, who is it that does what the best? Who's responsible for this particular component? And you really start to see some nice products. All right, so here is the dysfunctional conflict we want to either ignore or address, right? So the socio-emotional conflict is often aimed at interpersonal relationships. And everyone here, including me, has worked with someone that they just don't like. You never know what it is about someone that just really bugs you, but it happens in our labs all the time. And, for some of you who are more junior, if you're in this situation, it is not your PI. Your PI is not a parent. They're not a referee. You are now adults in the workplace. And the question is how can you deal with this on your own effectively? Or can you ignore it and focus on the work, which is actually the solution that the research backs up. If there's socio-emotional conflict, you're better off just saying, you know what, let's just get the job done. Like while we're here, like let's use what you know and use what I know and get to work. When there is this sort of relationship conflict and tension, it can lead to a great amount of stress and ultimately turnover. I recently had a team, a very high profile team that had two women that were on two sides of a very unfortunate event. And they could not be in the same room together. And the PI is saying, but these are the two best people in this area, probably in the country, and I can't get them to work together in the same room. So the solution we came up with was, well, what can they work on separately? And can someone else weave together their parts, right? So I do want to say, even as a teams person, sometimes the relationship conflict can get so bad that it might be better to create some distance between parties, but still try to link parts A and B together with some other intermediary. The second is status conflict. And this is what I think, I'm not sure I'm saying the name right, but Sivela was referencing again, which is as medicine in general is so hierarchical, right? In the clinic, we can see the high status specialty to the low status. And in research, the same, right? And we have our, apprenticeships that do warrant hierarchy. But I will tell you, the research on creativity and innovation says hierarchy is quite detrimental to the free flow of ideas and new perspectives. So your lowest status person on a lot of your teams is still a PhD or a postdoc with 7 to 9 years of training. And I would be careful, right, of saying, oh gosh, you know, you don't speak to so-and-so unless you email me first or whatever in some spaces. Other times, you know, essentially where I see this come up is what we were talking about prior, which, you know, what are the expectations of someone senior, junior, bottom of the totem pole? And when those expectations aren't clear and we start competing for basically, you know, rewards, credit, it can be really damaging to a team. So you want to try to manage these positional conflicts as much as possible. And again, this is going to sound contradictory because procedural conflicts, like I said, can be functional, can also be really dysfunctional. At the point in which you're spending more time talking about the how could we do this better and trying to change things all the time, it can be counterproductive. So I sort of want to present this curvilinear relationship with fix it if it matters and decide what components maybe are just fine as they are. So when we see this dysfunctional conflict, right, we're going to see when people could be focused on the work, they're instead focused on the thing that, you know, June did that bothered them or that Bobby said that hurt their feelings. And it's like, no, we have science to do. We have important questions to answer, and it can really be distracting. Something else that I often see is that we form these mini coalitions, even in the tiniest of labs, where it's so-and-so is really close to so-and-so, and so-and-so sees somebody else's position, and all of a sudden we have a divisive work group. Not very productive. These kinds of conflicts can create, I think, some stereotypes as, you know, we tend to like people that are like us and dislike people that are not like us. And it can be, again, disruptive. Harassment, bullying, sharing of information, all the things I talked about can be really unresponsible ways to do science. And, you know, I just, again, want to say it's the people problems that I think often inhibit the scientific endeavor. And so what do we do? Again, you want to ask yourself as a person who is charged with resolving conflict, and everybody does this. It's not just the job of the PI and the person, you know, leading the project. You want to ask yourself, you know, what kind of conflict are we talking about? Can you name it? Is it those productive forms, or is it the more dysfunctional forms of conflict? And is it impacting the work at hand? And if it is, how can you refocus everybody on the task, right? Now, if the underlying motivation is of the conflict, again, is to get ahead, to get credit, to get, you know, if it's not for the good of the group, I think it's important too to say, gosh, you know, again, sort of name it and address it if possible. And sometimes the conflict can just be so much that you've got to talk about it. And this is where it can be great to bring in someone like me, an ombudsman. Sometimes the conflict really can get above your pay grade, if you will, and it's useful to bring in somebody else who can support you. Now, I mentioned listening as an important resource for conflict resolution and avoiding conflict. You know, I want you to think about when someone is bringing up a concern, right? And I'm going to guess, you know, Tim mentioned abrasive, aggressive. And under those circumstances, it is the hardest to be a careful and good listener because the impulse is to want to put up your dukes and defend, when really you've got to say, oh, you know, gosh, I'm hearing what you're saying, and you might even rename that for them. I get it. You're running this study and you feel like you're not getting the participants you need. You're not getting the data from us quite as fast as you had hoped. That I can see where that would be really frustrating. And then you say something like, and I'm hoping we can find a solution together because I do like working with you. You bring benefits to the team. So let's see what we can do. Now, sometimes you might not be in a place to have that kind of a conversation, and you might have to say, hey, I'm hearing you. Can I think about this and can we talk about it more tomorrow or Monday or whenever? You might need to delay to get your head around what was shared. But these interpersonal skills of pausing, taking the pulse on where your own emotional response is, listening, and trying to work through will be much more useful than an impulsive response. You know, there can be times when the negative emotions and the fighting are just so out of hand. You know, I had a call with a colleague at another university with a person who's writing a lot of these editorials about COVID and anti-vaccine, and this person is working in this public health group with all these other individuals. And it's crazy, creating all this conflict, all this dynamic, right? And, you know, the question was, how do people don't want to work with this person, but we have 3 grants that we're supposed to turn around, but the teams, they're just falling because of this, you know, this one person. And sometimes, again, it might mean some intervention that is, you know, one-on-one, a coach, because people do have bad times in life. Something's happening personally, something's just right. And at times it's like, okay, you do need help. Maybe you call your EAP. Maybe you do regroup. Maybe you do say, gosh, can we, again, for a while, get the work done less with this person, but still get it done? When do you call your program officer, right? And say, hey, our team has hit a bump. We've got to do something different. All this to say, there are people around here to help, and you know, there's always something you can do. So finally, you know, we want to make sure we're creating those conditions that promote collaboration and hopefully reduce conflict. We want to create this orientation where people feel like they have a place to talk and engage in constructive conflict, that the norms are that people listen to one another, that they're understanding, and that they try to work through conflict with one another. I think it can help to have some decision-making procedures about what, you know, being very clear up front. What does warrant authorship in the lab? Again, that's clarifying those expectations. How much time until somebody in the lab, it's too much time before you respond to an email. Clarify the expectation. If you have a revision due, what is the time, right? Clarify, so that I'm not saying, hey, why, you know, is she mad at me? Why is she not writing me back? When my rule might be 24 hours for an email, but Brooks might be 72, right? We just want to make sure we're on the same page as we're working with our fellow teammates. And again, you want to try to be as fair, transparent, and we can do a whole other lecture on, you know, pay and rewards and equal management, etc. But again, I want to highlight the responsible conduct of research is also managing a space where people can bring their best to work, and when trouble arises, that the group can quickly troubleshoot and get back to work, right? So I think I am exactly at 12, but I don't know if we even, maybe a question or two or a reaction, if you guys would allow me that a minute or two here. And thank you, Stephanie, Pamela, and Naomi, everybody for turning on your camera. It's so nice to see your reactions. Mike, Vaisak, I'm not sure if I'm saying Jackie, all of you, it was great. Mitchell, Sage, I could tell you were not entertained with your body language, but it was still good to see you. Any questions, any comments? And I'm teasing you, Sage, by the way.
Maritza, I thought that was a great talk. A lot of things to consider there. I just had a comment based on my own experience. So I'm working within the UC Cancer Consortium right now. And right now we're trying to get a tissue biobank going between the cancer centers of the UCs. And, you know, what I'm finding that's a major hurdle for us is just trying to overcome logistical hurdles. You know, it's very logistically complex the more universities you get involved. And then at each institution, you know, they have different policies surrounding different parts of the process. So, you know, we're finding that the time and effort and even resources, you know, needed to get a collaborative framework even started between the UCs is, you know, definitely a hurdle for us being productive.
Yeah, and Stephanie, I'm going to recommend that maybe you send an email to Marguerite or Vince, because the CTSAs would be a great intervening mechanism, I think, right, Vince? To think about how those, and we have some of those collaborative agreements in place in other spaces.
No,
But
that would
you're
be-
right.
Yeah.
You are absolutely right, though. We are also operating with different institutional environments that are not always friendly to one another, which is a shame.
That'd be great.
Yeah,
Thank you.
Stephanie, I was just going to mention, I don't know if you have spoken with Hoda Anton Culver, but she developed a pretty large tissue bank related to cancer. You might want to talk to her and just find out if she's got any wisdom she could share with you.
Definitely, that would be great. She was actually on my master's committee, so I've worked with her before. Thanks for that.
And
Good.
Stephanie, if it would help to do a consultation with the various leads, I'd be happy to see if we can't come up with a framework at least moving forward. Tim, thank you for sharing about your experience. Vince, thank you for sharing the good, bad, and the ugly. It was a pleasure to speak with all of you. And I'm going to go back to my first slide here and say, if you're interested in these topics, you can check out our website and you can email me. What we don't want is that any of you would have all your talent, all your training, and be so discouraged by dynamics at work that you start to withdraw and don't bring your best self to work. So at that point, before that point, please reach out and happy to talk with you, okay? Enjoy the rest of your day, and it was a pleasure.
Thank you.
Thank you, Melissa. Thank you.
Thank
Good
you.
job.
Thank you.
You're welcome. Thank you.
So it looks like we're going to take a
All
lunch
right.
break.
Yep. Yeah, let's do it. So we'll come back at 12:30. Is that correct, Marguerite?
Yep, that's correct.
All righty. Look forward to seeing you all back here at 12:30.
See you guys at 12:30. Hi, Dr. Grill. I see that you just joined.
I'm here.
Okay, perfect. We're breaking for lunch.
I heard.
Okay.
Good.
All right. So you have about 30 minutes.
Yeah, 25. Do you want my slides or do you just want me to share my screen?
I would love for you to share your screen, and I would love to have your slides because I'd like to circulate them afterwards.
Okay.
Perfect. Thank you so much.
You bet.
Can you guys see my screen? Bless you.
Gesundheit.
Thank you. Well, let's see. We got just a few more minutes here. Excuse me, I'll be right back.
Sure.
I was like, he just drifted off into space.
Right? Yeah. A quick ride. You can see the screen, right, Josh?
Yep.
Okay, perfect.
Okay, are we ready to go? Let me just say a few words about Dr. Grill. Before I do that, though, just as a lead-in, in listening to Mirza Salazar and Jill Kay, and just sitting there thinking about all the science and the expertise that we're going to hear today. And for me, coming to work every day is like going to science camp every day. And you sit there and think about a topic like team science. That's a cool topic. I wish I could have a second life and maybe I'd go off and do team science for a while. And that leads me into Dr. Grill's talk. For those of you who don't know, Josh, he's a faculty member in the Department of Psychiatry and Human Behavior. He's a professor there. He also leads the UCI Mind program in Alzheimer's disease and is a world-renowned researcher in the field of Alzheimer's disease. And again, coming back to this theme of all the cool science that we learn about, in meeting Josh and getting familiar with him, I learned that he's an expert in topics like recruitment and retention. And you never tend to think about areas like that unless you really are forced to go in that. But that's a really cool area of science and just the logistics of doing human research. And just as a short background to that, many years ago, back in 2015, we were doing a study with NASA, and it was a human bed rest study where individuals were going to be confined to a bed for 60 days. And I was blown away by the recruitment and retention that took place in that program. NASA screened 39,000 individuals to come up with approximately 30 individuals that ended up participating in the program. And you sit there and think about the logistics and the complexity of screening that many people to get down to a cohort of 30 individuals. It's very, very impressive. So with that, Josh, really fortunate to have you here and look forward to hearing your talk.
Thanks, Vince. I guess NASA's research isn't always generalizable, and maybe that study wasn't a main goal. I wanna say hello and thanks for involving me in the workshop, to the organizers. In particular, I know Vince went to great lengths to make sure that none of the best college football teams were playing today, so that there weren't any conflicts for those of us who are into that kind of thing. You know, I want to thank him for the very, very kind introduction as well. So I am an Alzheimer's disease researcher. I kind of consider myself an Alzheimer's disease researcher first and foremost, and a clinical trialist second. And my own research, as you heard, has been really in the areas of trial design and conduct, and how that impacts recruitment, retention, and more recently, ethics in particular. So some of the things I'll talk to you about today are things that I've been doing in my own career, as well as kind of giving brief lectures now and then about. Marguerite kindly offered to share her screen, and I did that in hopes that folks might have their cameras on and I could see your faces, and I could see if you get, you know, that sourpuss face at something I say and know that I'm not doing so well, or any sort of, you know, thank you. You're very kind. You're very kind for turning on your cameras. You know, Zoom teaching is really difficult and not as much fun as teaching in 3 dimensions, but it's definitely better when you can try to see your audience in some capacity. So thanks to those of you who turned on your cameras. And Marguerite, we can go to the next slide. Unless there's a way for me to advance them. Is there a way for me to kind of take hold in advance, or? Okay, it's just kind of going slow. So we can definitely treat this like an hour-long conversation with kind of guided points that I'll bring up. The lecture's not too crazy. I'm basically going to go over some things that I think you should just be aware of if you're not already. Some, I won't call them highlights, because in reality they're lowlights in our history of doing biomedical research. And then I'm going to close with kind of a glorified journal club. There's a paper from some really outstanding folks who at the time were all at the NIH bioethics office, and they wrote a paper together. And I'm going to kind of walk you through the paper that they wrote. So that's my game plan. And if you want to keep your cameras on, interrupt me, put things in the chat, I'll be able to see them. All of that is welcomed. So we can go to the next slide. So I usually begin with just what is research. It's important because in the world of clinical research, it's always an important distinction between clinical research and clinical care. And sometimes that can get muddied, and that can be dangerous. But research is a systematic pursuit of knowledge. So we're trying to better understand something, learn about something, and improve the human condition based on that knowledge. Clinical care is more individual. It's trying to do the best thing you can for your patient at that moment in time. And that is not always, and typically isn't, the case in research. Usually we are all about learning. And sometimes the need of the individual can even come secondary to the goals of gaining knowledge as a field. So it's a really very important distinction. And again, sometimes the lines get a little blurry, and that can lead to challenges. Next slide. By definition, because research is the systematic pursuit of knowledge and not doing what's ever best for the person in front of you at that moment, there are inherent risks that come with research. They may be seemingly benign. I do a lot of interview studies where when I'm consenting people, I say, you're at risk of being very bored with me. If today's talk was a research study, I would have had to give you that same warning. It's true, I just don't have to give it because we're not doing a study. But you know, folks get bored, they get frustrated if we test their memory and they don't do as well as they think they should. But then other times we do studies that involve blood draws, lumbar punctures, or even investigational drugs. And obviously the risks will vary. And you know, that is a key part of any research study. Anytime someone participates in a study, they are in some way incurring some form of risk. And later on, I'll talk more about the balance that must be struck between our goals in the study, the knowledge we're trying to gain, and the risks that people are incurring when they choose to participate in that study with us. Next slide. So I love this phrase, and I think I'll have it at least twice in the slides, from, I think her name was Carol Levine, a legal scholar. born in scandal and reared in protectionism. This is a summary of our history of bioethics as an international research community. Somebody does something bad, people recognize it as bad, and we say we have to do something to make sure that doesn't happen again. And so we write a guideline or a policy, and we make sure that that bad thing can't happen again. And it overwhelmingly, the history of our bioethics is reactive. It's trying to make sure something bad doesn't happen again. Next slide. So I'm going to walk through some of the quote unquote lowlights that I think you should be aware of. You may have heard of yellow fever. There was actually an Italian virologist who was working at the Pasteur Institute early last century, who wanted to discover a cure for yellow fever, understand what was causing it, and decided that in order to do that, he would have to have infected people. So he sort of infected some unwitting individuals. I can't call them volunteers because they didn't volunteer. This drew great rebuke because, of course, it was criminal and was noted as such. But it also kind of demonstrated the sign of the times. There wasn't necessarily guidelines that existed that Santarelli was violating when he unknowingly gave individuals in Paris yellow fever. In fact, the first sort of demonstration of doing this quote unquote the right way is typically cited as being Walter Reed, who was an army, I forget his rank, but he was an army clinician investigator, and he was sent down to Cuba to study yellow fever. And he decided that to do this, he was going to have to do human subjects research, and that he would first engage the local government and the local community about what he aimed to do, that he would then develop a way to tell people what his goals were and what the research would entail, and that he would go so far as to document this on a piece of paper, including that he was going to pay people for being in his study. They were going to get $100 in gold for being in the study, and you'll love this, they would get an extra $100 in gold if they actually got very sick or even died. And actually, his research partner did die in studying yellow fever in Cuba. They ultimately determined that the carrier for the virus was mosquito, and his research partner, to confirm that, let a mosquito bite him, and he contracted the disease and perished. But this was, by most accounts, the first ever example of using informed consent. There was a piece of paper. It outlined what was involved in the study, what people would get out of being in the study, what the risks were, and what they could expect. And that's a pretty big deal. It didn't become the gold standard, however. It didn't become codified internationally or anything like that, but it is kind of the first example. On the next slide is the example that made informed consent truly achieve that gold standard level of expectation. And this is the Nazi doctors. Numerous texts have been written about the Nazi doctors. Just some of the horrific things that they did, primarily but not exclusively to Jewish people, are outlined in this slide. This is ghastly stuff. Much of this was done in the name of warfare, developing better weapons or treatments for war injuries, and of course, mass sterilization. But there were other quote unquote scientific experiments that were done to people in concentration camps. The twins are listed here. Oftentimes the scientific approach included a control, And twins made a great opportunity for having one experimental subject and one control subject to do terrible, terrible things to those individuals. And ultimately, many of the things that were being studied were deadly and would lead to the death of the person in the experiment. But the control would then be killed and examined at autopsy as well. And even if things didn't kill the quote unquote participants in these experiments, they were typically sacrificed so that tissues could be studied and the like. And the sterilization part is among the most disgusting things humans have ever done in the history of humankind. And the numbers are outlandish and crazy, and I'm sure familiar to you. Next slide. After World War II, the Allies conducted numerous trials of the Nazis. And one of those trials was specifically of the Nazi doctors. And the Allied force prosecution, led by the Americans, Britain, and actually Soviet Union, they had sort of a closing argument and submitted to the War Tribunal a panel of 6 key elements that they felt were necessary to encode to prevent this type of horrific thing happening again in the name of science. And the judges actually expanded those 6 essential elements to a total of 10 that would ultimately become known as the Nuremberg Code. And on the next slide, you can see the actual 10 elements of the Nuremberg Code. And I hope many of them will look familiar to you, because many of them are still very much prominent in the ways that we do human subjects research today, represented in the Common Rule, represented in the Belmont Report, and the various other things that I'm sure all of you have done, things like city training, and have been exposed to a lot of this. And you know, it shows they got a lot of this right. It shows that you know, this code would, for the most part, stay kind of intact and serve as a basis for essential principles that need be present for biomedical research to be deemed ethical. And, you know, first and foremost of the code, of the Nuremberg Code, is on the next slide, that informed consent was absolutely essential. And this, you know, still is hearkened by many as the time and place when it became necessary to have informed consent in place in order for a study to be ethical. Not to get ahead of myself, I don't actually think that's true. I think you can have a study be ethical without informed consent, but by and large, it is necessary in most cases. And relatively shortly thereafter, it was recognized that this mandate and a strict interpretation of it did have imperfections. Most notably, who I can't do show of hands, and you guys don't have to click your various logos or little emoticons or whatever, but you know, if we were all in one room like we used to be able to be, and I asked you to show hands if you thought we should try to cure pediatric cancer, I bet most of you would raise your hands in the affirmative. And babies can't give informed consent. People with cognitive impairment, who I happen to study, often also cannot give informed consent, and I'll come back to that later. So the imperfection of the code was that it did leave some populations essentially ineligible to be studied. And so I think the next slide will outline the correction of that issue and begin the evolution of sort of modern research ethics guidelines with the Declaration of Helsinki. And that came in 1964, but it's been updated numerous times. And Marguerite, if we go to the next slide, the Declaration of Helsinki made clear that populations who couldn't give informed consent for themselves could still be studied if a surrogate could provide consent on their behalf. And this was a very important advancement relative to that initial Nuremberg Code, which was really, you know, the first ever sort of international effort toward creating guidelines for researchers to conduct ethical research. Marguerite, if you give 2 clicks. Oh, you're in show mode. Okay, back 1, sorry. So now we have, you know, the Nuremberg Code and the Declaration of Helsinki and this seeming standard by which research should be conducted. But in fact, it wasn't really treated that way. And in North America in particular, unethical research was deemed something that those barbarians in Europe had done, but certainly not something that the sophisticated clinician scientists or scientists of the United States would ever do. That is until what was essentially an expose in the New England Journal of Medicine by Henry Beecher in 1966. And he reviewed the literature and cases known to him of clinical research studies in the United States that were very much in violation of those principles outlined in the Nuremberg Code and the Declaration of Helsinki. And some of these still resonate today. Some of these examples of unethical behavior still resonate today. In particular, here at UCI, we have world-renowned Down syndrome researchers who study Alzheimer's disease in people with Down syndrome. And we are analyzing some data together right now to try to understand whether the age of a person with Down syndrome's family member impacts their willingness to participate in research, because they remember the Willowbrook study in which kids with Down syndrome and other developmental disorders were injected with hepatitis upon entering into a facility, because the facility's study physician said they're all going to get it anyway. And so I'm just going to give it to them as part of, you know, understanding what's going on, knowing that who's got what, and dealing with it. There are other profound examples that Beecher outlined. The Brooklyn Jewish Chronic Disease Hospital was 2 docs who were injecting live cancer cells into older residents in this facility in an effort to try to understand cancer as a infectious agent and how to develop treatments. And the Beecher article went on to outline, you know, numerous examples in which these basic elements in the Nuremberg Code simply weren't achieved, like informed consent. And directly or indirectly, this led, next slide, to the formation of the National Commission for Protection of Human Subjects and the publication of the Belmont Report, which again, you all are familiar with, and it's still quite prominent in our national research infrastructure as codifying 3 essential elements of ethical clinical research: respect for participants, beneficence, and justice. We'll talk a little bit more about these constructs later on, and use some different words to describe them as well. But respect for persons basically means to treat each individual as an autonomous, autonomous being capable of free choice. Beneficence basically means kind of do only good in comparison to non-maleficence, which means do no harm. And justice is really about fairness. And again, we'll come back to that. But of course, you know, codes and guidelines don't necessarily prevent poor choices or behaviors. And just a couple of other famous ones that are still prominent and very much things that I deal with in my own career. First on the next slide is a description of the Tuskegee syphilis study. I do think it's important that we clarify some things. The study is atrocious, but not quite as atrocious as sometimes believed in the community. It's horrific, it's terrible, it's inexcusable, it's unacceptable. These doctors were doing a natural history study. They were federal investigators doing a natural history study of syphilis in poor sharecroppers in Tuskegee, Alabama. What they did that was so terrible was that when penicillin was discovered and made available and could cure these men, they were, I think, exclusively men, but if not overwhelmingly, mostly men, they didn't tell them. They didn't tell them that there was a suitable treatment for their ailment. In fact, they went to great lengths to keep them from finding out because they didn't want to screw up their study. They did not, and it's an important distinction. I'm not defending the investigators in any way. They did not give the men syphilis. And that is what a lot of people in the community, I've worked in the Black community in South LA a lot. That is a common misconception. It's maybe trivial in the grand scheme of things, but it's not quite accurate. What they did was they failed to respect the people who were in their study by telling them the current state of the condition that was under study. And that's a requirement now, that when you enroll someone in a study, you are agreeing that you're going to tell them if things change compared to when they began the study so that they can continue to make informed decisions about whether they want to participate. So noxious, terrible stuff that these investigators did, but also often kind of mistakenly represented. On the next slide, this is an old slide, but I just heard about the Lacks family this week on NPR. This story is not going away. Henrietta Lacks was a poor African-American woman who received care for, I think, ovarian cancer at Johns Hopkins. And her cancer cells were taken from her body without her knowledge or permission, and were the first ever human cells to be kept alive in vitro. And the cells were labeled with the first two letters of her first and last name, Henrietta Lacks, and forevermore known as HeLa cells. And so many of you have probably, if you ever worked in a lab, encountered HeLa cells. This grew into billions and billions and billions of dollars of businesses. Her cells were vital to the development of the polio vaccine. Her cells have been sent into space. I have seen, but don't remember, people's estimates on how many times her cells, if lined up next to each other, could circle the globe. You know, to say the least, this was the stuff of big business. And her family remained extremely poor. Most of them couldn't afford health insurance. And this was all brilliantly documented in a book that's now more than 10 years old by Rebecca Skloot. And it's a great read. It's a great read. It's written for the lay reader, but it's a great read. And it really talks about what it meant to be in this woman's family. It's primarily written from the vantage point of one of her daughters, and then Oprah Winfrey made a movie about it as well. Haven't actually seen the movie, but I mentioned that it's still in the news. It was in the news a few years ago when there was an effort to fully genome sequence HeLa cells, and a conversation was had about the impact it could have on the family's identity or confidentiality, because you know, you could then make some conclusions about their genomes as well. And I think the now nearly ready to retire Francis Collins was actually personally involved in creating a panel that included NIH scientists and family members to review applications to sequence HeLa cells and to not allow that information to go on any sort of public website out of respect for the family. So it was kind of like a good, it seemed like a good outcome. It was like the scientists were trying to do better, but the family still remained, extremely poor and without insurance. And then the story I heard this week on NPR was that Ben Crump, the lawyer for George Floyd, had taken on the family as a client, and they were suing Thermo Fisher for their financial due component of their needs financially to be met by the company that had reaped the benefits of their mother or grandmother's cells. We don't have time to debate that, but it might be fun. And I'll just say, not my area of expertise, and I'm definitely not a lawyer, but I think they've got a tough case, and I don't expect they'll win. But things are different now than they used to be, and it'll be interesting to see. But the precedent that I'm aware of is that they don't have a strong case because they couldn't have taken the cells and become billionaires without the scientists and the technology that made that possible. And there's actually a case from a school that Vince cares a great deal about. It's north of here, one county up. I can't remember the name of it right now, but it's in the same system of University of California's. And it was of a patient who had some tissue removed during surgery, and then the tissue was used to spawn a new company, and a lot of wealth ended up resulting. And that patient sued and said, I deserve some of that money because it was my tissue, and I'm fairly certain that patient lost. Because they couldn't have taken their own tissue and made the money. In any case, moving right along. So the last low light is the case of Jesse Gelsinger on the next slide. Everything I've read about this kid makes me like him more and more. He was a 17-year-old kid who had a non-penetrant genetic condition, disease of the liver that I know nothing about. It made his non-penetrant mutation made his non-fully penetrant or something about his mutation was like a low dose of the gene anomaly, made him capable of surviving the condition that afflicted him, whereas most kids who had the full gene dose of the ailment didn't survive past their first few years of life. I point out that he was 17 because he became aware that there was a clinical trial of a gene therapy for the condition that was looking for people just like him. And as soon as he turned 18, he and his dad got on a plane from Arizona to Philadelphia so that he could enroll in the study at Penn. And he was among, if not the first, participant in this phase 1 gene transfer technology clinical trial. And shortly after receiving the active gene therapy, he developed a very significant, severe immune response to the treatment and died after just a couple of days. It subsequently became clear that though he had qualified for the study at a screening visit, his ammonia levels at baseline were out of range. So the investigator could have chosen not to enroll him, and the investigator's name is James Wilson, and he's in the photograph at the bottom. So he qualified at screen, but he didn't qualify at baseline. And as a trialist, I can say that happens sometimes, and we typically do want to enroll people in studies, but in a phase 1 study with a kid, you could ask whether the physicians should have held off until the ammonia levels came back in range. It subsequently became clear that the consent that he signed was not up to date. Specifically, there was new risk information from some primate models that hadn't been included. And so Gelsinger and his dad may not have been fully aware of the extent of risk that he was taking when he enrolled in the study. And lastly, it became clear that Wilson, the PI and the faculty member at Penn, and I'll just say he's still a faculty member at Penn. In fact, I was recently, well, I guess it wasn't recently, but a couple of years ago, I was invited to attend an event in Philadelphia, and the person inviting me lauded that he would be there, the famous investigator from Penn. He had a conflict of interest. He had financial interest in the company and stood to financially gain if the treatment ultimately made it into clinical practice. And I chair or co-chair 2 ethics committees for national clinical trial networks. And mostly what we do is look for those types of relationships so that we can say those people shouldn't be investigators because they have an inherent conflict. And we need to protect the integrity of the study and the safety of participants. Actually, we don't usually say safety of participants. We say the integrity of the study because we don't usually think things like this could actually happen, but it did. And it was a big deal, obviously. And ultimately, it produced a new regulatory body that reviews every clinical trial of gene transfer technology in this country called the Recombinant Advisory Committee. So if you want to do a gene transfer technology, and that's usually what IRBs make you call it, they won't let you call it gene therapy because it hasn't been demonstrated as being therapeutic, then you have to get approval from the RAC first. I'm a little behind. I'm always a little behind if you couldn't guess. Next slide. But conflict of interest is a big deal. We have local committees that review this. I told you I review it for some national organizations. On the next slide, you can see one example, there are many, of how bias, be it conscious or unconscious bias, can impact the integrity of science. This was a sort of retrospective analysis of across many different areas of clinical trials in very high impact journals, and they kind of categorize studies as being positive or negative, and as the investigators having or not having a conflict. And you can see that conflicts were much more frequent among the positive studies than among the negative studies. It's causation, it's association, not causality, but it's pretty damning, I think. And you know, bias is a real thing, I assure you. Next slide. Okay, so you know, there were all these various events. They often resulted in updated guidelines or policies to try to prevent these things from happening. You know, when I came to UCI, I kind of inherited this lecture, and the lecture I inherited went into great depths about our local and our state guidelines for conducting research. And I admit I have minimized that a great deal in an effort to make the lecture more interesting. But there are numerous local guidelines that we all must adhere to. If you're going to be the PI of a study, it's your responsibility to be aware of the Code of Federal Regulations, the state of California laws, and UCI's policies in order to become an IRB approved investigator. All of these are key. Just a couple of other ones. On the next slide, I kind of outline some historical events in drug development specifically. This too is kind of a history of lowlights. You know, before 1906, there were basically no laws, and there was an example of some child vaccines that did not contain what they were being marketed as selling, and kids died, and so the Food and Drug Act was passed. It had essentially no teeth and stipulated that if you're selling a medicine, you have to, what you're saying you're selling has to be what you're actually selling. Pretty high expectations there, right? And then 1938 Food and Drug Cosmetic Act for the first time said that a company had to prove that something was safe before they could sell it. The low light there was the sulfanilamide disaster, where a company had drug they were selling. People in their market said they wanted a non-pill form, and so they wanted it to be dissolved in some sort of solvent. So the company did. They ended up dissolving it into essentially antifreeze. And it worked well, it looked good, and it was smooth, and so let's go with it. And again, a bunch of people died, and that led to the passing of the 1938 Food and Drug Cosmetic Act. Still not a lot of teeth, but it did say that a provider had to demonstrate the safety of something before it could be sold. And not until 1962 and the Kefauver-Harris Amendment, which was a response to the thalidomide tragedy. And the kids pictured in the bottom right are what could be termed thalidomide babies. This was an antiemetic that was widely sold in Europe for morning sickness and had terrible teratogenicity, birth defects caused by the agent. It actually was never sold in the United States because of that 1938 Food and Drug Cosmetic Act, and one very brave member of the FDA who refused to allow thalidomide to be approved and marketed in the United States. But it was distributed in the name of research and in the anticipation of an approval, and docs were allowed to sort of try it out in some patients. So there were cases of thalidomide babies in the United States, but not nearly as many as there would have been if it had been approved. But this occurrence led to the Kefauver-Harris Amendment, which for the first time gave the FDA true, real authority and instituted what is largely still the case, that in order for a drug to be approved and marketed, it had to be demonstrated as both safe and efficacious. But before that, you didn't have to prove your drug worked. And in I have an undergrad class on clinical trials. I show pictures of things like cocaine drops for toothaches and various other things that used to be sold without any batting of an eye in this country. Okay, maybe let's take 3 or 4 clicks, Marguerite, because I'm way behind now. Yeah. Common rule got updated, mostly good. Some people complained. But let's talk about this journal club. Okay, so what makes human subjects research ethical? Marguerite, I can send you this paper and you can send it to everybody. This is by Zeke Emanuel. If anybody listens to NPR, you've probably heard Zeke Emanuel. He was one of the authors of Obamacare, and during that time was on the radio like weekly. He's now the director of the bioethics program at Penn. He wrote this with Christine Grady, who I've had the great pleasure of working with recently on some stuff. She's definitely the smartest person in her family. And I bring that up only because she happens to be Tony Fauci's spouse. But she's amazing. And just, what a powerhouse family that must be. And the third author was David Wendler, who's produced numerous fantastic empirical studies in the area of bioethics. They were all working together at the NIH Bioethics office. And they basically said, our history of bioethics is this reactive timeline. Something bad happens and we update guidelines to try to make sure it doesn't happen again. How come no one ever sits down and says, what do we really need for a study to be ethical in a proactive, prospective approach? So they sat down and decided to do that. And this paper is what they produced. Next slide. So they came up with these 7 constructs. Social value, that a study must enhance health or knowledge. Scientific validity, that it has to be rigorous. Fair selection of subjects, justice, if you will. Favorable risk-benefit ratio, which is a highly ambiguous construct that we all have to try to convince the IRB of every time we do a study. Independent review, which is that we have to go to the IRB before we do a study. Informed consent, a la the Nuremberg Code. And respect for subjects, a la the Tuskegee. Once someone's in our study, we aren't done. We aren't done being ethical. We still have to treat them appropriately. So I'll try to quickly go through each of these. Next slide. So research is not easy. I promise. If you're new to research, I'll just say it's not easy. It's very difficult. It's hard to get funding to do research. It's hard to get people. Vince just told us that even if you offer to send people to the moon, it's really hard to find people who can be in your research studies. Resources are limited, and people are at risk in some way, shape, or form when they participate in research. And so for a study to be ethical, it has to be meaningful. It has to have value for us as a people, as a society. You can't do it just because you need a thing to do with your time, or even just because you need to show your advancement committee that you're engaging in research. It has to be more than that. It has to be of value for it to be ethical. Next slide. For it to be ethical, it has to be valid. You can't do a study, you can't put people at risk if you're not going to answer a question. So it has to be rigorous. And there are levels of this. It's not just, do you have a control group? It's more than that. I study clinical trials. We have phases of drug development. In earlier phases, we often do smaller studies that should still answer a question. And oftentimes that question is about safety. But if you set out to answer a question and your study, or you as an investigator, aren't able to make it rigorous, it's not ethical. And an example of that is, if you do a study to test your very noxious potential drug as a treatment for Alzheimer's disease, and the primary outcome of the study is memory performance, and you've only got 50 people, I can almost guarantee you're not going to be powered to show an effect, if one exists. And so what you're really doing is putting 50 people in a study, giving them a noxious drug or placebo, hopefully, without the opportunity to know if it actually changes their memory. That's not rigorous science. And there are numerous ways we could come up with examples of things that might lack the rigor to ensure that a question is answered. So to be ethical, a study must be scientifically valid or rigorous. Next slide. When you're enrolling people, you have to enroll them for just reasons, meaning that you cannot design a study or recruit to a study if you're going to enroll based on privilege or vulnerability. Now, this is most easily exemplified in the setting of research in prisons, or probably my favorite example is the notion of pay to participate. In fact, when I first moved to Orange County, I wrote a letter to the editor of the Orange County Register, because they wrote an article about an investigator at Hoag who was, quote unquote, enrolling people with dementia in a clinical trial of a stem cell therapy that was injected directly into the ventricle of the brain at $10,000 an injection. Paying to participate in research is, it's very difficult. It's possible, but very difficult to arrive at a situation where someone paying to participate in research is ethical. And I think for the most part, it's damn near impossible. And so we should pay people to participate in research. They should not pay to be in. And it arrives at an unethical situation where only people who can afford $40,000 a year, which is not most people, can be in that quote unquote clinical trial, which I think is using the term quite loosely. So scientific reasons should dictate who will be enrolled in a clinical trial, and justice dictates that it should be the science and otherwise fairness deciding who enrolls in a study. Next slide. The benefit to risk ratio must be deemed acceptable. And again, this is just inherently ambiguous. And it really is up to the investigator to be able to make a solid argument that in most cases, the benefit is going to be knowledge gained. I mean, I've been doing studies for 15 years where I say there's no guarantee of benefit for people who participate in this study, none whatsoever. And the best case scenario may be that we learn something that'll help everyone with this disease. And therein, you really rely on informed consent and people making autonomous decisions that benefit is adequate for them to take the risks involved in being in the study. But again, you'll have to convince the IRB or some other independent group that ratio is adequate to move forward with doing the study. Next slide. One construct that can often be relevant to this ratio is what we call equipoise, or sometimes referred to as clinical equipoise or research equipoise. This is a state of genuine uncertainty. This is something that I've actually been writing about a bit lately, as we just had a new drug approved in Alzheimer's disease. If we've got 3 or 4 extra hours, I can spend some more time talking about that. But one area where we think about equipoise is the choice of a control group when we're treating people with a disease with an investigational drug. And specifically, is it ethical to randomize people to placebo if there are other treatments that exist? And this really boils down to, there are numerous ethical constructs that play a role here, but one of the key ones is equipoise. When I design a study, am I in equipoise? Is it fair to say that we really don't know which arm of the study is better for people, and therefore we need to, therefore we're justified in randomizing people to one or more arms in that study. Now, this doesn't necessarily mean that you don't think the thing you're testing is promising. It doesn't even mean that you don't think the thing you're testing works. It just means that there's a state of disagreement or lack of thorough understanding within the field. And as we've recently written, you might say that there's that it doesn't violate the standard of care. And we can talk more about that some other time if anybody's interested. Next slide. Very similar to that is this construct from Ben Friedman that I really like, the logic of clinical purpose. Clinical research should be designed and conducted in a manner that helps move the field and the field of practice forward. And you should design a study with a current sort of a knowledge of that current practice and design the study in a way that moves that practice forward. So if you study, I don't know what a good example is. If you study a condition where there's a clear cure, you shouldn't do a trial of a new treatment compared to placebo, because you're denying people the cure. And you're not really advancing the field if there's already a cure. So you have to kind of understand the general standard of care in that practice, and then you need to design studies that will move that standard of care forward. Now, if there's a great treatment that exists for the condition you study, but it has to be taken by injection 5 times a day, can you do a study of an oral drug? Yeah, absolutely. That would be an advance for the field to have a more convenient therapy, or one that has less side effects. But you would have to assess what the proper control group is and the proper design to move the field forward in order for that study to be ethical. Next slide. So you're going to have to submit your study to an independent ethical review board, what in this country is termed an institutional review board, and UK is often referred to as an ethics committee. But somebody who's not involved in the study is going to have to agree with you that your study has been designed in a rigorous way, that the risk-benefit ratio is justified. They're going to take a close look at something we'll talk about in a minute, which is your informed consent, and that you're well qualified to do this study, because that's also a key. And I breezed over the updated common rule, but in the updated common rule, there's actually an important advance that if you're doing a multi-site study, you can have that study reviewed by one IRB instead of all the sites, which is an important advance that was made. But the reason that we need an independent ethical review is that we all have inherent conflicts of interest. We all want to do our study and do it well and publish it in Nature or Science. I don't know. I mean, Vince only publishes there, but I've never published there. But you're going to want to have a whopping success. You're going to want to make your next promotion, get your next grant. That's a conflict that we all face. And so peer review and IRB review are really important things. They tell us about our own biases. They give us feedback on our methods, and they make sure that we're acting in an ethical way. Next slide. So the Nuremberg Code told us that informed consent was essential. The Declaration of Helsinki opened the door to doing consent in unique ways. I already told you, I think that some studies are ethical even without informed consent, depending on how we define it. But for the most part, informed consent is a fundamental piece of conducting ethical research. Again, I don't have a lot of time left, but on the next slide, just a couple key points. This is not a contract, okay? This is you documenting that you went over the study with the participant and that they agreed to enroll. It doesn't mean that they have to do everything that was in the consent form. It will outline everything that will be done in the study, how many blood draws, how many visits, how many MRIs or injections of an anti-oncogenic treatment, et cetera, but they are free to change their mind at any time, and the consent form should say that too. And importantly, it does not make a study ethical. I'm aware of many, many unethical studies where people signed informed consent. You can't do something unethical and then say, but they signed consent. Yes, we said we were going to chop off their right arm, but they agreed to it. So what's the big deal? Doesn't work that way. Next slide. The consent has to satisfy some basic needs. It has to have adequate information for a person to really understand and know what's involved in the study. The person who's signing has to have the capability of understanding that information, and they have to be doing so in a voluntary way, meaning that there's no coercion or undue influence. A couple of other terminologies on the next slide, very relevant to the work that I do. Decision-making capacity, capacity competence, all used kind of interchangeably. When we're enrolling people in studies, we actually always, if they have cognitive disorders, we assess their capacity to give informed consent, meaning that we check to see if they really understand the information, can demonstrate to us that they understand it's voluntary and that they are making a choice. And if they don't have the cognitive capability to understand or to demonstrate those things, then they can't sign consent for themselves. Now, I already told you it's really important that we still be able to do research with those people. On the next slide, in those situations, we can have someone else provide what we call surrogate consent, provide consent on behalf of the individual who lacks capacity to provide it for themselves. This can be done by a legally authorized representative. And here in California, it's actually kind of easier than it is in other places. We've got a hierarchical list of people who can sign consent on behalf of a person who lacks capacity. On the next slide, I have another definition of assent. The person with cognitive problems still has to agree to be in the study. They can't give consent because they don't have the capacity, but they can't say, I don't want to do this. I don't want to come here. Then they're out. You can't enroll that person who says, I don't want to do this, even if they don't have the capacity. A surrogate can't, in most cases, a surrogate cannot overrule the individual who lacks capacity. Next slide. Two important two important definitions, coercion and undue influence. Coercion is one of the most misused terms, even by ethicists in some cases. Coercion means securing compliance through overt threat of harm. We as clinicians, investigators are rarely in a position to threaten people. It could happen. If you're a person's doctor, you could say, I'm not going to be your doctor anymore unless you participate in this study. That's coercion. What's more frequently at issue is the risk of undue influence, which means an inappropriate reward to elicit compliance. And these definitions come from the Belmont report. Now, on the next slide, I outline something. This is typically in the area of monetary compensation for participating in research where undue influence is considered a potential risk. I think it's a rare thing. I wish we had enough money to overpay people to be in our studies. I've never had that luxury in my career. This is a New England Journal paper from a couple years ago. I love the structure. We could think about paying subjects in this three-tiered system. One, every study should strive for participation to be cost neutral, meaning that we reimburse people for the costs they incur to be in our study. If they take the bus, we cover their bus fare. If they have to pay a park outside, we cover their parking. Compensation means that because we acknowledge the incredible contribution people are making to our science, we're going to pay them a just wage. There's a literature on this. Should we pay them what they make in their other job? Should we pay them some sort of universal wage? Minimum wage is a decent place to begin conversations and considerations of compensating someone for being in a study. But we began with Vince telling us that recruitment is very hard. And in particular, recruitment of populations who are consistently underrepresented in research is even harder. And so maybe we have to pay people more than minimum wage if we want them to choose to be in our studies. And that would be an incentive, paying them more than a minimum wage. And I am a full-throated supporter of financial incentives to people for participating in research. And most of the empirical studies that have tried to examine the risk for undue influence find that when we pay people more, they more heavily scrutinize our consent forms, more heavily scrutinize the risks, and are more likely to decline being in a study out of concern that why are you paying me so much? And in fact, studies that have looked at high versus low socioeconomic status populations find that the low socioeconomic status populations are even more scrutinous than the high socioeconomic status. So it's not an issue that's completely understood or doesn't still need study, but most of the evidence that is known to me really suggests that it's pretty difficult to achieve undue influence by paying people to participate in studies. The IRB may still push back on you on it, but I can give you a bunch of papers to cite if that happens and you have the money to pay people to be in your study. So just shoot me an email. Next slide. So I'm almost done. The last construct is respect for individuals. Once someone enrolls in your study, your job is certainly not done. You have to protect their confidentiality. You have to respect that they can change their mind at any time and never reject the voluntary nature of research. You are agreeing to give them updated information if information becomes available. Tuskegee's the best example. We're doing this now. We had a drug approved on June 7th for Alzheimer's disease. We had to update consent forms and let everyone enrolled in studies know that there was a new drug that was approved. You're committing to monitoring their welfare. Again, things that could be whole lectures. We've done a little bit of work around how we tell people the results of studies. And I think they have earned the right to know what we learned because of them. And so you should think about that in advance. And in my field, we've had some large industry-sponsored clinical trials get stopped early, where people learn the results of the study on CNN or MSNBC or Fox News in the morning when they wake up, before we have a chance to tell them, oh, by the way, the study got stopped last night in the dead of night by a DSMB saying that the drug you've been taking isn't safe. So some thoughtful approaches are warranted there. Second to last slide. Seems kind of silly, but I had to put it in. Don't make up your data. This was remarkable in all the wrong ways example in Science a couple years ago about an investigator who was manufacturing entire data sets in Alzheimer's and Parkinson's disease. The investigator, if I remember correctly, ultimately took his own life. But people do some crazy things, and academic science can be high pressure, and we all want to do well. The most important thing is that we conduct good, high integrity science. Anything else is unfair to the people that we've chosen these careers to help. Okay, last slide is just a summary slide. I'm 3 minutes over. I apologize for that. I'm going to blame Vince. I just haven't figured out how yet. So thanks for your attention. Really all I wanted to convince you of was that these are meaningful issues that we all, no matter what kind of research we do, we all face these issues in some manner or another. When people enroll in studies, they're placing trust in us to do what we say we're going to do, which is help people like them somehow or some way. And so take that gift, take that compliment and agreement that those people are making when they enroll in your study as seriously as you possibly can, and do right by them by doing great science with great integrity. Thanks.
Josh, great talk. However, I do believe that there was one lapse in your memory. You said that you had no publications in Nature. I know that not to be true. As a matter of fact, there was one recently related to this Alzheimer's drug that you may have actually been alluding to. So because Alzheimer's is so timely and this FDA issue has become so important, could you spend just a few moments talking about that particular drug and the FDA and the ethics behind what took place?
Yeah, so it's Nature Reviews Neurology. I'm not sure that counts. So we did have a drug approved on June 7th for Alzheimer's disease. It was an accelerated approval, not a full traditional approval, which is very important. It's a monoclonal antibody against the beta amyloid protein that accumulates in the brain of everyone with Alzheimer's disease in plaques. And it has been convincingly shown to lower brain amyloid levels measured with amyloid PET scans. And I should say, I was an investigator on the 1B when I worked at a school north of here, still in the UC system. And then I did bring the phase 3 here to UCI, and we are still following people who are taking this drug now in open label. I also very much went on the record with the company that I didn't like what they were doing. After a phase 1B study was published in the real Nature that showed the lowering of brain amyloid levels, they chose to skip phase 2 and launch parallel, simultaneous, multinational, multi-site phase 3 registration trials. They didn't actually have dose figured out. And they were still following some people in some additional cohorts in the phase 1B, determining that dose ramping could allow the drug to be achieved at higher doses in one particular genetic subset of people with Alzheimer's disease who are at greater risk for adverse events of the drug. Any case, long story long, the phase 3 trials were stopped early for futility. I deem them failed. They shouldn't have been stopped, but that's not my fault. And it's hard to take those data that come subsequent after stopping trials before they're done as gold standard level, let alone registration data. They kept, so, anytime you stop a trial, it's a time-consuming endeavor. So while the data, after a data freeze for the interim analysis, data kept coming in. And then after stopping the trials a few months later, the company announced that they had analyzed all the data and it looked like the drug was working. So they then submitted to the FDA for approval on the basis of one positive trial and one negative trial. And in the negative trial, they said people who got the highest dose for the full amount of time also benefited, but that's a post hoc secondary analysis. There are a lot of controversies about this, but basically an FDA advisory panel near unanimously voted against approval. 11 people voted against, 1 abstained, none voted for approval. The FDA extended their timeline to make a decision about approval, and then ultimately granted, in a very unexpected way, accelerated approval on the basis of a surrogate outcome lowering brain amyloid. That surrogate is not validated in our field. And in fact, many believe, many drugs have actually changed amyloid before without demonstrating a adequately strong link to clinical benefit. So it's a very complex issue. The FDA decision was complex, and that's what our paper is about. They really, they went against their own words. They basically said during the FDA advisory panel that surrogate was not even under consideration, and then ultimately granted approval on the basis of a surrogate. The drug development part is controversial because they skipped phase 2 and they didn't really know dose before going into phase 3. The futility analysis decision is controversial. They combined the data from the 2 trials, and many people are very suspect that it took so long after the futility to arrive at the conclusion that there was a signal in either of the trials, let alone a positive trial. There's some involvement of patient advocacy organizations who have been full-throated in supporting the decision. myself included, many of my colleagues are hesitant to criticize that organization, which is the second or third largest funder of Alzheimer's research in the world. That's been interesting. So it's a long conversation. And again, our article was really, I think this has been bad for the field. It's drawn incredible numbers of headlines. Even now, since June, it's been certainly more than a weekly occurrence to have major headlines around this. There are at least 3 congressional hearings planned on the topic. The drug was priced at $56,000 per year. We don't yet know if it'll be covered by Medicare or private insurers. That's just for the drug. It's infused on a monthly basis. So some of the early estimates suggest it'll be about $100,000 per year. Oh, and by the way, if it works, which is if you take the one positive trial and treat it as gospel, it works very, very little. The effect size is very small. Now, it was being developed as a disease-modifying therapy, and if it is a disease-modifying therapy, the longer you take it and the earlier you start it, the greater the benefit could be. But on the data that we have, and we are scientists, I often have to remind my colleagues, on the data we have, it is a very small effect, no greater than the very cheap generic oral medications that are available now. Now, I do think it definitely does something different than that. I do think it probably works for some people, but we need more data, and the evidentiary standard for drug approval in this country simply has not been met. And then I tell my trainees that I feel robbed because we've had incredible discussions, to be nice about it, because they've been mostly arguments, about these other controversies and not enough about the drug effect, if it's real, and whether it's adequate, clinically meaningful for approval, and charging families this much. So CMS is in a period of gathering comments now, and we'll see if they're going to pay for it. But if families end up incurring this cost, it's going to be tragic. But others are saying if CMS incurs this cost, it's going to be really bad for our national healthcare system, because the estimates are, I don't have them top of my head, but there are 6 million people with Alzheimer's disease in this country today, and $100,000 per person per year adds up pretty quick. I actually forgot a bunch of the things. I just remembered some of the other aspects of the controversy, but maybe that's enough for one day.
Okay, Josh, like I said, fantastic talk and fantastic information. I'm going to send a link to Marguerite for that article that did appear in Nature Review. Very hot area, especially as it relates to the FDA lately, and kind of a lot of vacillation on a number of fronts.
Yeah.
So Josh, many thanks. And we are glad to hear that you did work at UCLA at one time.
That's what it is. That's what it was.
There was one question in the chat, Dr. Grill. For clinical trial testing out treatments for a condition, I've heard of the idea of waiting lists, whereby those that receive placebo are put on a waiting list for the treatment, and after the placebo data collection period is over, those in that group are then given the treatment to ensure that they.
Yeah, got it. So we don't typically call that a waiting list, although there are studies with waiting list controls. I've been working on one like that recently, but it's not of a drug intervention. For drug interventions, we typically refer to that as just a double-blind placebo-controlled trial with an open label extension. And this generally is done with industry as a sponsor, because they have the drug and the manufacturing to provide it, and they are gathering long-term safety data that will be helpful for their submission to the FDA for approval. So if the trial is 12 or 18 months long, they want to have some data from people who've been on the drug for 36 months, for example. So once people finish the double-blind portion, they can then be enrolled in a new study called an open label extension. Only people who are enrolled in the double-blind are eligible for that study. And it's called open label because there's no placebo arm. So everyone gets drug active drug from that point moving forward. And actually, you know, in the Biogen story, one of our folks just passed away who was enrolled 8 years ago in the Biogen study and kept taking the drug for many, many years on open label extension. So sometimes people can be followed closer to a decade in some of these studies, depending on a number of variables, most of which are out of our control as investigators, namely whether the company is still developing the drug.
Perfect. Thank you so much.
Okay, I'm around and feel free to circulate my email if people want anything else.
Thank you, Josh.
Enjoy the day.
Well,
All right, fantastic information. So now we're on to the next talk, which is on conflict of interest and undue foreign influence. This is by Nadia Wong. Nadia is the research compliance, or she is the research compliance officer and outreach manager. She's in the Office of Research. She addressed this topic, I think it was probably 2 years ago, maybe 3 years ago now. It's hard to recall with COVID getting in the way of all this stuff. But Nadia, we're really looking forward to this. And these compliance issues are really important. They're really, really important. I don't joke about this. You just want to try to stay away from these as best as you possibly can. So Nadia, with that, take it away.
thank you. Let me try to get set up. Can everyone see the slides? Okay,
Yep.
thank you. Hi, so thank you for that introduction and thank you for having me. Today, I'm going to be talking about undue foreign influence and conflict of interest. One of the main things is I'm going to give a lot of information with a lot of details. Don't worry about it. What I want you to get from this presentation is the understanding that there are these policies, these regulations in place that affect your relationship outside of UCI. And so if you find yourself in one of these situations, to be aware that these policies exist and also know that there are disclosure requirements, but also more importantly, resources like myself that you can contact to get all these details. So it might look intense because there's a lot of text, but I wanted to provide all the information as a resource, knowing that someday it might be maybe next year or the year after that, hopefully you'll remember, oh yeah, there was something about foreign, I should look that up. So just as my disclaimer. So we'll talk about undue foreign influence, a little background. That's definitely a newer compliance area. The federal government's focus in that area. And then we'll go to conflict of interest in research, talk about the policies, disclosure requirements, the purpose, the process. And then for those graduate students we had and students in general, there are some other policies that exist that I want to go over briefly that relate to conflict of interest. And like I said, in my opinion, as a compliance officer, ensuring compliance really is developing this awareness, which is why we have this training, why we have these different resources, and then also making sure you disclose properly. And then at any point, if anyone has any questions, please feel free to speak up. So we'll start with undue foreign influence, and this does apply to the entire campus. And before I even start with that, in working with the undue foreign influence work group, we have decided, and we really want to make sure it's clear that even though there are concerns about our researchers' relationships with international partners, that UCI remains committed to supporting and encouraging the international community, and that we really still are trying to balance the federal regulations and their concerns with the importance of maintaining our inclusive and welcoming culture. So what is undue foreign influence? It's also sometimes just called foreign influence, but basically these are the terms coming from the federal government related to their concerns over the foreign governments and other entities' influence in our work, our research, in academia, and that it could potentially negatively impact our country's economic competitiveness. So really thinking more about IP rights and then also our national security, depending on what type of technology and research is being looked at. What the federal government
its main concerns is peer review violations. So in terms of there's confidential information shared with the peer reviewers that they might be inappropriately sharing it or taking that information. Also failure to disclose substantial foreign resources. And so you'll see that in terms of what some of the changes they've made into the requirements of the applications. Failure to disclose significant foreign financial conflicts of interest. So like I said, you can already see disclosures popping up a couple times that's something they're looking at. As I mentioned, diversion of proprietary or pre-publication information is something they're concerned about in terms of the loss of intellectual property because it's being funded by the federal government. And so the fact that, it could be being used inappropriately to benefit the foreign governments is their concern. And then also compliance with our standard regulatory requirements like export control. So in general, for undue foreign influence, like I mentioned, developing your awareness is important. So part of it is kind of doing a self-assessment and thinking about what type of research you do and that might be of interest to other foreign entities and governments. So it might be the field you're in, the access to the different resources, equipment, things like that, that might make you a target. The other thing is to try to actively prevent yourself from being a target and be very careful about how quickly we share information with other people, whether or not we really are verifying and making sure we understand who these individuals are that are reaching out to us, especially if it's unsolicited. And then also if you're traveling abroad, which hopefully we'll be able to do more soon in the future, there is international travel. So our IT security group actually created a whole website. And so I've included the link with steps you can take to try to make sure that any data you're bringing over is protected and kept secure. And then the other general best practice is you have to share your concerns and questions with someone as soon as possible. So a lot of this is developing that awareness in that sense, so that if you see a red flag, you know to say something. And so who do you contact, right? So it's complicated because undue foreign influence, as described in all the different areas they're concerned about, it really does go beyond just one office. And so depending on what the concern or red flag is, then you would contact the appropriate office. However, since there's all these other people and all these different offices, sometimes you don't know where to start with me. Okay, so if you have a question and you just don't know, you remembered vaguely, I talked for a little bit and you don't know what's going on, you can check with me. And if I don't know, I at least am in tune with this network, I will help you find, together we'll figure out where we need to go. So as I mentioned, awareness and disclosure. So disclosure is what we're seeing is the federal government is releasing over the last couple of years, a number of guidances, memos, and updates to their policies, to their procedures. And it really seems to relate with them, their investigations that have discovered problems with researchers' disclosure. And usually it's that it's incomplete or it's inaccurate or it's inconsistent. And they understand how many different disclosure requirements are placed on researchers. And what they're doing is they're using that information and basically cross-checking it. And that's a large part of the investigations that we've seen. And when I'm talking about all the different disclosure requirements, these are just the general ones that apply. So depending on what your role is, you would have different disclosure requirements. So for UCI employees, if there is any invention, then you would have to submit a record of invention to our tech transfer, which is research technology translation group at Beal Applied Innovation. For UCI faculty, they also have to disclose their outside professional activities in UC OATS, and that's an annual thing that's done based on the fiscal year. And there's also some prior approval requirements, which I'll go into a little bit later. But once again, that only applies to UCI faculty. Researchers in general, we have 3 different categories. So researchers are required to submit disclosures based on conflict of interest policies. Right now, the agencies we have that have their own policies would be Public Health Service. So that includes National Institutes of Health and then also National Science Foundation. So those are the 2 federal agencies. But as a public university, and we'll talk about this a little bit later too, there are a number of other, two other policies that we have at UCI. And so this is all about your outside financial interests, and it gets triggered based on your research projects and your research portfolio. So it is project-based. So if one of your proposals gets awarded and it follows one of these compliance COI policies, then it potentially could have a disclosure requirement. And then, like I mentioned, the federal agency, there are two main areas they're looking at, which is biographical sketches and then other support or current and pending support. And the tricky thing about these two areas is each of the federal agencies is really looking into these areas and updating and modifying what they want disclosed. And it is happening for these types of changes fairly frequently. And so it's something that anytime you have, you're submitting a proposal or you're submitting the annual progress report, you do want to double check with that federal agency to see what the fine print is in terms of what do they really want to know. So going back to conflict of commitment for the UCI faculty, they are required to disclose foreign and domestic outside professional activities annually, and they need to obtain prior approval before engaging in a Category 1 outside professional activity, which is the highest risk, and that includes co-founding a company or engaging a student in that outside professional activity, and then or exceeding the numbers of days that they're allowed. And so conflict of commitment is different than conflict of interest. Conflict of commitment is the concern that you're spending too much of your time doing other activities that it conflicts with your work and your responsibilities to UCI. So that's why they're looking at days and the types of activities. And then if you have any questions, you can contact academic personnel. For the federal grant applications and et cetera, like I mentioned before, these are the areas they're really looking closely at, and it's really important to check with each federal agency to see what their specific requirements are. And I'll show you an example in a little bit. And undue foreign influence is still evolving. So just coming up in the new year, on January 25th, 2022, NIH has changed their other support requirements. They're adding a signature block. So now PIs, program directors, senior key personnel, they all have to electronically sign the other support form, which is very different from how it was submitted before, where you just kind of provide the information and it gets submitted on your behalf. The other main change is that if your other support includes any foreign activities or resources, you are required to submit a copy of that contract, grant, or other agreement specific to that foreign appointment or employment. And then if it's not in English, it also has to be translated into English. So these are two major changes, but it's also an example of what we're talking about in terms of the federal government really is looking into these areas closely and reevaluating what type of information they feel they need before they would grant an award. And then there's also the requirement now that if you have, if UCI, so the institution, discovers a failure to disclose, we have to submit a form immediately. So it's also important to know that before it's kind of like at the annual, at the initial award, and then also with annual progress reports, you would submit this information. But now it's something where you have to if you fail to disclose it. In addition, the GAO published a recent article recommending that other agencies consider disclosures of non-financial conflicts. I don't even really know what that's going to look like at this point. But that's, like I said, these are just signs that this is going to be something that's a part of our lives that we're still learning about. And then also for University of California itself, we have completed a system-wide audit on this area, and the Office of President is currently developing guidance, new training, and other resources to promote understanding and compliance in this area. So we do anticipate, and I'm part of coordinating that work group, that there will be new training. It may or may not be required, but it is definitely going to be coming from the Office of the President. There will be new guidance that each campus is expected to analyze and implement. So there might be some procedural changes too in terms of what we need to do in this area. And then, so we do have a website, but our new website for undue foreign influence will actually be launching in November. And then I've also posted 2 of the FAQs for NIH and then also NSF's current and pending support. Does anyone have any questions on this area? Okay. So for conflict of interest in researchers, it does apply to researchers, right? So what we're talking about is a situation where your domestic or foreign outside financial interests or relationships could have the potential to bias a research project. Now, when I say outside financial interests, basically anything you receive through UCI is not considered an outside financial interest. So for like a clinical trial, you might have some of your salary paid through that clinical trial potentially, right? And it might be Pfizer, for example. You do not have an outside financial interest in Pfizer because that money is going to UCI and then UCI is paying you. So anything built into a UCI budget is not something we would consider an outside financial interest. What we would consider is if in your free time you were a consultant for Pfizer, and so they paid you directly for that work. That is what's considered an outside financial interest. And so, as I mentioned, we've already talked a little bit that there are 2 federal agency disclosure COI policies, National Science Foundation, Public Health Service. But in the state of California, we also have a requirement for any non-governmental sponsor, we have to disclose in that. And then UCI has its own IRB COI policy. As you've heard in that previous presentation, we view human subjects as very important. And so that's a higher risk area, so which is why our campus created its own policy to make sure we address conflict of interest concerns for human subject studies. Just so you know, the red text indicates the projects where you might be a graduate student or a postdoc might also have to disclose. For this state requirement, it only applies to PI and co-PI, so that's why it's typically going to be your faculty members. But for these 2, it's any individual responsible for the design, conduct, or reporting, and that comes directly from the federal government. And how do you know if you meet the definition of an investigator is we always defer to the PI. So we would ask the PI, okay, in your research team, which ones are the investigators? And so they're required to submit a list of all of those people. And then the system will it's an electronic disclosure process, the initial part. So we'll ask for that disclosure. And then for human subjects research, it's all research personnel listed on that IRB protocol would be required to disclose. And what you disclose is different. For the state, it's only financial interest in the actual sponsor. Whereas for National Science Foundation and human subjects research, it's financial interests that are related to your research, to that specific research project. And the researchers actually make that determination, but if there's ever any question or concern, they could always reach out to me and we can kind of talk through and figure it out. NIH is the broadest, and so it actually requires you to disclose anything related to your institutional responsibility. And we'll go into the definition in a little bit. And so basically it's your UCI field of study. So if you're a biologist, it's the field of biology, anything that relates to that. So it's super broad. And then how you disclose actually also depends too. So this is the area where I said there's a lot of details and I don't expect you to remember it all, but just to know that they exist, right? And so that later on, if you're like, oh yeah, I did get paid and do something, let me go back and double check. Just to hopefully not scare anyone. This is the really scary one. So this slide is talking about what to disclose. And because we have 4 different policies, they all are slightly different. And the thresholds are different. So for the state requirement, they establish their threshold at $500 for any income over the last 12 months. So for all of these, it's always the last 12 months from the date of disclosure. Whereas NSF, you can see it's over 10,000, or if you have equity over 5%. IRB is similar, so over 10,000. They do have the requirement that if there's equity in a privately held company, so it's not on the stock market, then it doesn't any equity in that. Even if it's 1 share and it's worth nothing, it still has to be disclosed. And then IRB also requires management type positions. And NIH has, I'm sorry, this is an error. I'm going to fix this. It's 5,000. This was a typo. It's $5,000. And it's also any equity in a privately held company too. So it's a lower threshold. And going back to institutional responsibilities. So UC defines it as investigators teaching, education, research, outreach, clinical service, university and public service on the behalf of the university, directly related to those credentials, experience, achievements on which your employment was based. So that's why it's really just your field. So most likely, if you're a consultant, if you're on a speakers bureau, it's going to be related. If you start a company, it's also most likely going to be related. I've seen very few cases where your outside financial interest isn't related, and it's usually been something very obvious where they have a wood shop business, and that doesn't relate at all to their field as a clinician. Related means that the financial interests appear to be, that the financial interest would reasonably appear to be affected by the research, or when the entity where the financial interests are held could be affected by the research. So in other words, the entity or the company might be interested or affected by the results of the research, right? They might want to patent anything coming out from this study. Those would all be examples of what we would consider related. Another example would be you're doing a clinical study for a drug, but your financial interest has a competitor drug, a competitor product, right? So even though your financial interest, their drug isn't involved in the study at all, the theory and the fear would be that your participation in this other study, if that study looked worse, it might make your company's interest look better. So those would be examples. And everything like that. Once it meets that disclosure threshold, it's considered a positive disclosure. We have to then determine if it's related. And depending on policy, and so, if for IRB and NSF, you as the researcher would determine whether or not it's related. For PHS, UCI has to, per regulations. So we would then review it and determine whether or not it's related. Anything that's considered actually related then gets reviewed by the committee. And then the committee's job is really to look and see whether or not it's a financial conflict of interest, which is a situation where we feel that the financial interest could significantly and directly affect the research. And it also requires a management plan. So the Conflict of Interest Oversight Committee is faculty voting members from across the various schools, and then a number of ex officio voting members. And please note, we really do support the development of these relationships and with outside interests, as long as there's appropriate measures. We work with the researchers to address those concerns and promote best practices. And then we also serve to review and document how these concerns have been addressed. So I really do view our committee's role as, carrying out the requirements of these regulations, but also protection for the researchers, the research, and UCI. So for example, if there was ever like the OC register comes and has concerns because Dr. So-and-so they found out has a financial interest in a company related to this study, if they've gone through this appropriate process, then we would be able to tell them, yes, we knew, we reviewed it, we documented, we wrote the 20 things that they did that made sure that conflict of interest concerns were addressed, and that's why we granted approval. And so I really do feel it's a collaborative process where we're here to also help you. We want to shut those all down. And the only way we can do that is by being working together and being really transparent, right? If I don't know the information, I can't help you. So when we're talking about conflict of interest, we really do look at it from a very proactive standpoint. So this is a resource, and I've included, this is an active link actually, where we've kind of gone through some of our main concerns of conflict of interest and try to give ideas on how other faculty members, other researchers have addressed those concerns. Some of them, like study design, it really depends on how that study, like some of the things you're doing to just have a rigorous study help conflict of interest, right? The whole purpose of that is to try to reduce bias. And so that's why those measures that you put in place, those safeguards you put in place, can also help conflict of interest. So all you would have to do potentially is highlight them if you are required to disclose. So I just highlighted the study design, research data and analysis, and then supervision are some key areas where COI would be looking into. And basically in our review, what the committee will do is they'll look at the financial interests and your obligations to that outside entity. So if there's a consulting agreement or any other documents, and then they'll look at the concerns, the COI concerns. And if you've addressed enough of the COI concerns, they're going to recommend it for approval. If you did not address you did not sufficiently address their concerns, They don't deny it, they table it. Like I said, it's a collaborative process. So what we'll do is we'll say, we'll provide all the reasons, all the remaining concerns that need to be addressed. And the committee will even either provide their recommendations or requirements, or even ask the researcher themselves, what do you think you can do to help address these concerns? What else do we need to know? And then hopefully it will get approved in the next meeting then. I've been doing this for 10 years. We've never denied anything outright. So it really is a collaborative process. So to not be afraid of having these outside financial interests, it's just realizing that with it, there will be additional disclosure requirements and additional steps you have to take, but that UCI has resources that are built to try to help you get through those procedures. UCI also has some standard COI best practices. So anytime we have, and this one has been in place for as long as I've been here and longer, anytime you are reviewed by our committee, there will be a requirement that you disclose your related financial interests in your publications, presentations, and if applicable in the consent for the human subjects research related to that project. A new one that we started in June 2021 is that you will also be required to disclose to your study team working on a project related to that financial interest, and then also identify a non-conflicted individual they can contact with any questions or concerns. And we call that the COI point person. And this is really it's not a punitive measure. It's really, we're trying to promote transparency. A lot of conflict of interest is just being aware that it exists and try to make sure and work together to try to manage it and mitigate any potential concerns from it. And then some COI resources, as I mentioned, the Addressing Potential Conflicts of Interest guidance has a number of other areas in terms of suggestions on how to deal with that, and also some case studies. And then we also, it's a little bit outdated, but we have the startup guide. We worked with BL Applied Innovation to create it. That really helps deal with any questions you have related to creating a company, especially if it relates to IP that's owned by UC. And then I've also included our website. And then if you have any questions, so you can always reach out to me. And then the other person, part of my team, is Christine Tai, and so she's the Research Compliance Senior Analyst. Does anyone have any questions about conflict of interest in research? Okay, so these are the other policies that kind of relate to conflict of interest that I wanted to briefly highlight. So conflict of commitment, like I mentioned, for students, it applies to faculty. And the main thing is faculty members have to obtain prior approval before involving a student. And the point of it is really just to make sure that people are aware of the situation and put in any measures if they think are necessary. So if you have any questions about that, you can contact your academic personnel representative. For grad division has its own COI policy, so it would apply to graduate students and faculty. The concerns the reasons why they created this policy is some of these scenarios. So your PI owns stock in the company and they tell you to delay your publication of your dissertation and graduation to maintain the value of the PI shares. These are obviously worst case scenario that we haven't actually experienced, luckily. Or a faculty member starts a company related to a student's research and they're pressuring the student to divert work away from their own project to do research that actually will benefit the company. And so the reason why grad division created these policies is they want to protect the graduate students, right? Making sure that they are able to make progress through their academic program. And so to address these concerns, the policy requires the appointment of a COI oversight member to protect the graduate student. What happens is someone would have to identify there's a potential conflict of interest. So part of it is through the form submitted in when they actually create the committees. Or it could sometimes even come from our committee reviews. So once that's been notified, then they would work with the designated resource person, usually the departmental grad advisor, to work with the faculty member and the student to determine if it really does require a COI oversight member. And then together they would nominate 3 faculty members as potential COI oversight member. And then the dean of grad division finally will select that person from the list of 3 nominations. The COI oversight member is, the purpose of that is that they're aware of the COI issues and the financial interests involved and the other relevant campus policies. And they are a non-voting ex officio member. And so they'll attend all the meetings, but their goal is really just to, in the end, report back and say whether or not they felt there was any harmful results from the COI. If none, they just sign a statement to that effect. Or if there are any concerns, that they would be the person that would help notify the Dean of Graduate Division, and then the Dean would then be responsible for trying to help find a resolution to any of those concerns. So once again, this person is basically there just to protect the graduate student. And so we're almost done for my section, at least. So how to be compliant. So like I mentioned before, it's, in my opinion, it's really about awareness and disclosure, right? So for both of these areas, it's for undue foreign influence, the challenge is it's changing. And some of those changes will affect conflict of interest, but some of those changes won't. And so it's really important to pay attention to the emails we're sending out, to pay attention to the information we're sending out, checking our website, checking the information from the actual federal agencies to see what they've done today. And then it's really to develop that general awareness of what the best practices are, what areas you should be concerned about, and then to know that there's resources and context around. For conflict of interest, awareness is knowing when to contact the COI team and knowing that there are these disclosure requirements. So I've highlighted a couple cases where it'd be great for you to reach out to me or my team directly. So if you're considering to develop a new outside financial interest, I regularly talk with faculty members, postdocs, graduate students, project scientists who are interested in creating their own company, or who are considering having a consulting agreement with a company. And they have questions. They want to know, how's that going to affect my work at UCI? How's that going to affect my research? Will that be a problem, right? So that would be a great time to reach out to me, right? Because at that point, nothing's been decided and we can talk through, okay, these are the different scenarios. These are the things you want to think about as you're deciding what type of relationship you want to actually engage in. Another good time to reach out to us would be if you're actually going to submit a research proposal related to your outside financial interest. As you know, a lot of what the committee does is because it's related to that research project. That's why you have to disclose. That's why you have to go through the committee review process. So why not plan ahead? So I also work with faculty members and researchers where they're going to submit an SBIR phase 1 study. And they might want to subcontract back to a person at UCI who is a co-founder of that company, right? And so then what we talk about is, okay, so what type of research, what type of equipment, who's going to be involved? And then I try to highlight, okay, these are the potential committee concerns I see. Let's talk about how we can address them now. And the whole goal of that is that way, the proposal they submit already has some COI provisions built into it, so that when the committee actually reviews it, which is always at award stage, right? So literally money is here or on the way, which means you want the money, right? So when we do our review, we want to move as quickly as possible. And so doing this prep work before you even submit that proposal is great, because hopefully by the time the committee sees it, all we had to do was highlight all the things we talked about that address conflict of interest. And if the committee has any remaining concerns, hopefully it's minor changes. Some of the changes the committee can require and has in the past is the addition of another faculty member researcher to your study. To find that out at award stage when the budget has already been approved by your sponsor and the check has been issued is a bad time. And that's why I really do encourage working with us as you're developing that project, because it just makes it easier. And with some of the faculty members I've been working with and researchers, we've gotten so used to it that later on the like third or fourth study, they don't even have to consult me, because we've already established kind of what they're doing and what works for them and what works for the committee. So it makes it an easier process for everyone. The last time that would be really important to notify us and check in basically is if you have a change to your outside financial interest. So for example, NIH and NSF both have requirements, and IRB, that if your financial interests change, you have to update your financial interest, and it might trigger a whole new disclosure and potential review. So for me, I always suggest, instead of worrying about it, just tell me. Let me know if you have a new financial interest or something significantly changed to your existing ones. And that way I can go through and we can double check really quickly. Hey, oh, don't worry about it. You're fine. It doesn't affect any of your research. Or, oh, these 3 projects, we're probably going to have to do some forms and just go through a review. So like I said, I really do think that working with us is the most convenient way for everyone to kind of get through these procedures. Like I mentioned before, disclosure is important, right? So for COI, it's following those above recommendations will help you disclose properly, but it's really reading all the forms, making sure you're paying attention to what all the different dollar thresholds are and the equity thresholds and things like that. Similarly, for undue foreign influence, because each federal agency has their own flavor, has their own version of things, you really do want to refer back to their documents and work closely with your CNG officers and your department administrators to make sure you're disclosing appropriately. And then also just to contact the appropriate office if you have any potential red flags or concerns. And something that applies to both is, given the fact that COI has been around in terms of these concerns for a while, there, it varies in terms of how much concern there is, but the key to COI has often been disclosure. With undue foreign influence, it is so important to maintain your records carefully. And so when I'm talking about records, we've been talking about mostly outside financial interests. For undue foreign influence, they're also talking about affiliations, collaborations, like international collaborations with other partners. If it's a lot broader than you think, especially under NIH. So I really do encourage you to look at under that. Under their resources, they are really trying hard to provide more FAQs, but we do have a master log that we'll be posting in the new website that basically is almost saying, tell us, write down everything you ever do that's not outside of UCI, because you really do want to keep track, because like I said, one of the reasons why there are investigations and findings from the federal government is they're looking at inconsistent information. So what they're literally doing is they're looking at someone's conflict of interest disclosure form for a project, comparing it to the university's conflict of commitment outside professional activities annual disclosure, and then also doing basically a Google search and looking at publications, right? And presentations to see co-authorships, to see, did they disclose they had these financial interests? Is it consistent? And that's what has been a major concern, is that all of these systems are siloed, unfortunately. So it really is up to the researcher to do that thorough check of, okay, I wrote 3 things on this form. I better make sure that if I might need to write 3 on this other form too, or not, right? So it's being really careful about that. So really to disclose accurately, properly, and consistently. And I highlighted this, the most important thing in my opinion is, now that hopefully you are aware, right? You have that awareness, you understand that there are disclosure requirements. Main thing is, if you're not sure, ask. Consult the appropriate office. If you're not sure who that is, feel free to use me as a starting point, right? So, because it makes my life easier, it makes everyone else's life easier if we just start off on the best foot. So that's, I think, if you don't get anything else from this presentation, it's ask, and make sure you're asking the right people. And then I think that ends my presentation. Does anyone have any questions?
Sure, I have a question.
Oh, go ahead, Naomi.
Hi, Nadia, I wanted to ask a question for the slides where you we're talking about the graduate student potential conflict of interest. Would that also include postdocs? Would they be under the same, or would
it literally is a grad division policy? So undergrads aren't covered, postdocs aren't covered. So it is different, yes. So it really is just graduate students, because it's all tied into their thesis advancement dissertation committee. So it's different.
Okay.
But the committee is also very concerned about undergrads and postdocs too. So that's why on one of the slides, it talked about like supervision. So if you had like a faculty member or like a PI, right, who was conflicted and there are postdocs, the committee is going to look and make sure that there is some sort of protection for those that research lab, right? Including the postdocs, making sure that, because they are very aware that, a postdoc's career depends on their PI. So it doesn't make them feel very comfortable if they have to then tell the PI who's conflicted, I don't think you're doing the right thing. Obviously, worst case scenario, right? So part of it is that requirement of having that COI point person is kind of in response of that too, right? Is first they have to tell you, you might not know that your PI has that financial interest. But they first have to tell you about that. And then they have to identify someone who's non-conflicted. So in the worst case scenario, if you really did have concerns or questions, or just, something didn't feel right to you, you know who you can contact. And we always stipulate that that non-conflicted person has to be independent and non-junior to that PI. So if they're a full professor, it's going to be another professor, or sometimes I've also seen it be the department chair. Right. So it's someone that has nothing to do with the company, is aware that there's this financial interest. And then that way you have some kind of almost a safe space to go to if you had any questions or concerns. The other thing is, once again, I'm a resource. So you could also reach out to me and oh, I just had a question about this, and then we could also discuss and see what happens. But the committee is also very, to them, it's really important to protect everyone's academic and professional careers, right? So students and they didn't forget about postdocs. It's just grad division created its own policy.
Okay, thank you.
Any other questions? Well, hearing none. Nadia, first of all, thank you very much. Number two, there's this kind of theme that I think is different at UCI versus other academic institutions, and that is that we have a number of key administrators who are absolutely helpful. They want to help all of us out and help us move forward with our research, and certainly that came across in your presentation, Nadia, so thank you very much for that.
Honestly, I think it's fun sometimes. It's like an outside financial interest is an opportunity, right? Whether or not it's consulting or a full-on company, it's an opportunity. And I really do enjoy working with the researchers and faculty because it's an exciting thing. It's a positive thing. We just have to figure out how to manage it. We just have to figure out how to document and make sure that all the different red flags are addressed, and then we just move on.
Yeah, and when you hear conflict of interest, especially as a student or a postdoc or a faculty member, all of a sudden you go, uh-oh, wait a minute, am I in trouble here? Am I gonna, somehow end up in, deep in trouble with these types of things? And the key point that you're raising is that get all this stuff out in the clear, and then it's going to be smooth sailing.
Yeah, pretty much. I mean, I will guarantee it's probably going to be extra paperwork, but hopefully it's worth it, right? Hopefully that opportunity is worth it. And that's why it's also nice to have these conversations before you even develop it. Like literally I had a conversation once with a faculty member. They were thinking of creating a company with one of their students, more as a courtesy for the student. When I described all the financial disclosure requirements, they were like, maybe I'll just be an advisor. Like, I don't need, I'm really just doing it to help the student out. It's not my thing. And that's what you want, is you want to have all that information so you can make the best decisions for you, right? Because it's not going to be a generic, okay, everyone should do this. It's going to be like, for you, given everything else going on in your life and what you want to do, maybe you should do A versus B.
Great point. Okay, let's move forward. So now we're on to Dr. Stewart's talk, and we're really fortunate. I mean, the stream of outstanding speakers continues with Dr. Stewart. We're really fortunate to have him. Just a little quick background about Oz. He was a senior associate dean for research in the School of Biological Sciences from, I think, 2012 on up to 17. Does that sound right, Oz?
Sounds about right.
He is a distinguished professor in the Department of Anatomy and Neurobiology. Phenomenal other accomplishment is he was recently elected to be the president of the Society of Neurosciences, which is an incredibly prestigious position. And congratulations on that.
Thank you.
Is the neuroscience meeting bigger than ever? Last time I was there, I think there were like 17,000 people that attended the meeting. It was huge.
Well, that's a long story. So actually, it is at the last meeting, it was closer to 29,000. However, sadly, this year there will not be an in-person meeting. So difficult times.
Yep. Also should mention that Oz is the founding director of the Reeve Irvine Research Center. If you don't know about that center, it's really, the primary motivation there was to help individuals with spinal cord injury and to find a cure for spinal cord injury. And Oz, you can correct me on this, but a lot of it was evolved from Christopher Reeves, who was the actor that played Superman, and he had a accident while riding, I believe, a horse.
Mm-hmm.
Yeah, is that correct?
That's correct. Yep.
So anyways, that's an outstanding institution or center. And then also with regards to the presentation today, Oz wrote a seminal article on rigor and reproducibility, and he really was at the forefront of this at the national level. So that provides our impetus to try to encourage and invite Oz to come back every 2 years to give this presentation. So with that, Oz, the floor is yours.
Okay, thank you, Vince, very much. I appreciate it. Am I showing up on your screen all right as far as, okay. I like others before me, I really would appreciate it if you could turn your cameras on. I don't care what you're doing, but it's just nice to know that there's somebody out there that, and you know, I'll just say, I once was giving a lecture to our medical student class, and about 20 minutes in, my phone rings and they say, I don't know what you're doing, but we're waiting for you to actually continue your lecture. Well, I had been lecturing to my screen for a while without my students actually being there. So anyway, if I see you, I know you're there. Let me just ask you a quick question here. I'm not gonna go long. You really desperately need a break. I need a break. Actually, I've been listening in, but the nice thing about Zoom is I've been doing other things. I'm actually, I've been routing for the hinges on a door. So I did try to remember to turn the microphone off. I think I succeeded. So just real quickly, how many of you are doing human subjects research? Can you do your, whatever, your hand thing? You know how to, you guys worked on that, or just wave or something? Okay, 4. Okay, only 4, 5, here we go. Any more? Just, if you can't figure out how to do your hand, I saw, thank you, Jackie. I saw the clap, that's nice. 7. Couple of thumbs, that's great. Okay, so it looks like maybe, I don't know, roughly half of you, maybe. I didn't count, and some of you actually lowered your hands. But anyway, so I'm going to be talking today about both human subjects and animal subjects. And now that I know at least some of you are doing human subjects research, I'll try to kind of go back and forth a little bit. So, all right, my talk is really about scientific rigor and not so much data, but you'll see that it is data because the element of rigor is how you collect your data. And as Dr. Grill said, you have to do, responsible science is rigorous science, and especially when you're dealing with human subjects. If you're not doing rigorous science, you're wasting everybody's time. You're putting people at risk. In the case of animals, you're wasting animals. And so it really is a key issue in responsible conduct. And it isn't something that is necessarily in the same vein as plagiarism or fudging data or things like that. Those are absolutely wrong and forbidden. There are elements here that are sometimes judgment calls, sometimes things that aren't written down as rules, And sometimes things you kind of get caught on, actually. You've done a 6-month project and you send it off to your favorite journal, and the journal comes back and they say, well, did you do the study blind? And they say, uh-oh, no, I didn't. And the editor says, well, go back and do it in a blinded fashion and resubmit with a new set of data. And there you go, 6 months of work is down the drain. Same kinds of things refer to randomness. You might think that you've done it randomly because you didn't kind of group things together deliberately, but random has a very specific meaning. And when I get a paper review and somebody says, oh yeah, these animals were randomly selected, I said, how were they randomly selected? And what you're looking for is that animals were assigned a number, and then with a random number generator, you decided which animals went in which group. If you just took a cage and put one over here and put one over there, that's not random. So understanding these things in advance actually is helpful to you going forward. So, all right, that's what we're going to talk about here. All right, so let's see here. Okay, so first of all, some of you may know about what is now called the reproducibility crisis. And this is sort of how I got involved in this whole thing. Basically, it came about roughly a decade ago when multiple reports from different labs started publishing reports that they tried to replicate something and they couldn't do it. What's going on? And then people actually set about to specifically, explicitly replicate studies, and again, trying to do it and failed. And some of these ended up being really quite dramatic. I'll show you a couple of articles in a second. And as a result of all this, NIH said, well, guess what, guys? We're going to change our rules, and you're going to have to get serious about this. You are going to need to do research in a rigorous way. And this is part of what we're talking about here. Actually, for scientific rigor, there is a requirement for scientific rigor training for training grants. And then at the end of the day, as I mentioned, I guess final common path of all of this is the journals. And this is where things really have gotten interesting, because any of you who might have been reading papers that are 10 or more years old, method sections were maybe 10 lines long, and everything was, oh yeah, it's the way I did it in this paper, or the way so-and-so did it. And part of the problem is that that's almost never the case. Really, you may think you did it the same way, but when you went back and actually kind of went through the whole deal, almost every time there are these subtle changes in procedures. And so journals have actually now come to the point where they are explicitly requiring quite detailed method sections. And I'll show you some of those at the end. For those of you who are looking forward to publication, you might want to think about what journals you want to submit to and check what their requirements are. Sometimes you'll be a little surprised at the things that they're going to ask for at the end of the day. It's about details, and just kind of going back to the whole record keeping thing from the first talk today. If you don't have the records about, for example, what time of day, how old the animals were that you did, when people came in, all these things about order of testing, those are the kinds of things that you actually end up needing when you come to the point of actually preparing a detail report for whatever journal. So journals have changed their requirements in a big way. And if you look at the papers from 10 years ago and try to model your method sections based on that, it's not going to work. Your papers are going to get rejected, and you're going to have to go back to the drawing board. Okay, so these are some of the things. I'll send some of these out to you if you want, but this is just some of the publications that have come out, and it's everything from psychology studies to cancer research, drug targets failing because non-rigorous techniques were used. It just goes on and on. And in one sense, it's a matter of, well, if I'm working on something that is just a scientific discovery, it'll get corrected at the end of the day, right? But if you're doing research that you think is maybe going to make it into the translational sphere, or for that matter, that's actually forming the basis for a whole bunch of research by somebody else, and it ends up not being replicable, that's a tremendous blow to the field. And it wastes everybody's time, but it even more importantly erodes trust. And as we have seen over the past few years, the public's trust in science has seriously eroded. And we need to, the field, all of you, all of us, need to do everything that we can to build back that trust. So that's one of the really important reasons. Okay, so this is a bunch of stuff. I'm not going to read through it all. Again, I'm going to send Marguerite the slides here, and some of these you can go back and look through if you're interested. But it's been something that has been widely recognized. Both NIH and the NSF and the national academies have begun to advance solutions. And at the end of the day, these are all going to involve universities and journals and pretty much all of us. So if you want, you can read some of these. It's appeared in the public press. Richard Morris published this book. Richard Harris, I'm sorry, published this book a couple of years ago. He was actually here maybe 3 years ago and gave a lecture on the other side of the campus. And he's actually a very interesting person. But you know, you can see what there's written: rigor mortis, sloppy science creates worthless cures, crushes hope, wastes billions. It's true. He's not our enemy. He goes a little overboard in some of the things that he suggests, but this is kind of where we are. And again, we have to kind of build back trust. Okay, let me just kind of back up from all that. I hope I've maybe gotten your attention. So just to go through some terminology, you know, we talk about replicability. That's the sort of the issue here. Reproducibility. But there are sort of different terms that apply to different aspects of this, and these are now pretty well accepted. These were terms sent out by the FASA a couple of years ago. These are basically the kinds of terms that most people use these days. So, you know, again, replicability means I tried the experiment, I tried to do it the same way, and you know, either it worked or it didn't. But it really means exact replication. And that turns out to be hard, by the way, and I'll come back to that in a second. Reproducibility means that I tried something pretty similar. You know, maybe it was different. Maybe I used rats instead of mouse. And either I get the same results or similar results or I don't. But it's comparable. It's not identical. Generalizability is another level. It means your finding or the finding is actually pretty robust. You can change conditions and still generally get the effect that is reported. That's pretty good. Translatability means something quite different. It means that whatever discovery has been derived from experimental models can actually, in a reasonable proximity, seem okay to apply to the human condition. There's a whole lot of issues there that go beyond whether or not it can be replicated. There's issues of how big is the effect, and that's a whole nother study. The word rigor means the use of unbiased, and I really emphasize that word. One of the earlier talks today talked about the word bias in a different way that I'm going to be using it here. If you have a financial interest in something, if you stand to gain from a particular result, that's one form of bias. I'm talking here about bias that actually is quite different. We all have biases, and that isn't necessarily a bad word. It just means that we have to control for those biases. And in the case of rigor, bias means, unbiased rather, means the use of stringent methodologies to analyze, interpret, and report experimental findings. I'm going to come back to that because this is really where the data part of all this comes in. How you gather the data is based on the degree to which you apply principles to minimize bias. And I'm talking here about unrecognized bias. So we'll come back to it. And then transparency means I'm going to report everything I did. And again, it's back to the method sections. And, you know, 10-line method sections these days is just not going to fly. And sometimes the details are really quite extensive. Okay, how did I get into this? Well, I never thought that I would be at this stage of my career, for that matter, any stage of my career, giving lectures on scientific rigor. It wasn't what was interesting to me at all. I want to be a scientist. I want to discover things. But when this whole thing started, when people began to realize that there was problem with reproducibility, NINDS, which is the neuro division of NIH, was really quite attentive to the fact. And they were looking at reports in the spinal cord injury field and the head injury field that came out, and they seemed really good. And then people would ask, well, what happened to them? You know, so-and-so reported this really amazing result. And we kind of knew in the field because, you know, chat in the halls at the meetings, oh yeah, I tried that, you know, that totally didn't work, you know, but that totally didn't work part never got reported. And so we were building, you know, on sand rather than bricks or rock or whatever. And NINDS really took the bit in their mouth and funded contracts that were going to test exactly how serious this problem was. And the contracts were to go out and replicate promising studies, not ones you thought were bad, ones we thought were good, and try to just see if the same results or similar results could be obtained. So they funded contracts, and we got one here. Miami project at the University of Miami got one. The first 5 years. We renewed ours. Miami decided not to because it turned out to be a real hassle to actually do these. And Ohio State got the second version. And over 10 years, we replicated 20 promising high-profile studies published in the very best journals. These were selected by a committee of leaders in our field. And again, they were selected because they were good, not because we thought there was anything wrong with them or that they seemed weak. And the bottom line is that of 18 fully executed studies, a couple kind of didn't work out for one reason or another. Only about 10% of the results could be replicated. And I'm not saying that that some of the results in a given paper weren't replicable, but if you take the aggregate results, only about 10%. And well, that was just astounding. We had no idea that that was going to be the outcome. And so we wrote a interim report on this whole thing. And the bottom line is, how did I get into it? Well, we started trying to understand what was going on here. We thought these were really good studies that we were trying to replicate. Where was the problem? And we were able to identify some of the issues that may have contributed to this lack of ability to replicate. And that's really what I want to talk about for the rest of the lecture. And it's not just us, other people have identified some of these as well. The point is that the identification enabled the formulation of best practices. And that's what I'd like to talk to you today about. As you're setting out to do your own research, what are the best practices that you can use to at least minimize the possibility that you're going to get results that just can't be replicated? That's the key. Okay, some issues. Again, I've talked about methods sections. Sparse is ridiculous. And sometimes there were just no methods at all, and sometimes the methods were misleading. I'll give you an example. You read a spinal cord injury or head injury paper. There are 3 groups, 10 animals each. So a total of 30 animals tested over 6 weeks. And okay, how'd you do that? You might think that everybody came in, 30 animals, you did spinal cord injuries, and then you tested them all. Well, in fact, you can't do that. At least unless you have a team. It's very hard to do a spinal cord injury or head injury, or other studies are similar, that involves a surgical intervention all at the same time. You might be able to get 5 animals a day. Actually, we do it with team surgery. We actually can get 30, but your average lab really can't, and certainly your average starting lab. So you'd go back and, okay, well, gee, how was it done? Well, it turns out that it was a few animals here, a few animals there, put the groups together at the end. Maybe the study went over many months. Okay, well, you have some animals that received this drug. How did that happen? Did they get interspersed with the controls? Well, no, because it's really hard to deliver the drug. So we gave the drug to a group of animals and did that on one day. And then the next day we did animals that didn't get the drug. Well, if you read the method section, you would never know that. And that's an important variable because it already tells you that they know who's getting the drug and who doesn't, right? So they've already effectively unblinded themselves because the animals who are getting an injury or whatever treatment on a given day are the ones that are getting that treatment, right? You know it. So without actually that detail of implicit randomization, already there's an element of potential bias creeping in. It's not deliberate bias, but you know which groups the animals are in already. Okay, so that's one issue that we discovered because we tried to replicate studies, and when you actually contacted the original authors, they would explain this, but sometimes those details were not even available by contacting the original authors, and this is really where record keeping comes in. Why weren't they available? Well, the studies were done by a postdoc or a student who had left the lab. It might have been a study that was done 5 years ago. You contact the PI who says, I don't know how they collected those data. I have no idea. I wasn't paying attention. Well, can you go back to your records and find out? Well, I don't really have the records of that. The student has it. You might contact the student. They said, no, I left them in the lab. Okay, there's an example of just a failure of good record keeping that ends up making it impossible to do the study in exactly the same way going forward. Maybe it matters that it's exactly the same, but the bottom line is that it was impossible. But even given all these issues, even when we did everything we could to make it absolutely identical, it turns out that key findings were not reproduced. And really that indicated that a lot of the things that were reported may have been statistically significant, but they were not robust across conditions. And then the question becomes why? Okay, so that's what I'm going to go into. And it's really sort of the issues of what are the best practices that can help ensure that optimize at least chances for replicability or reproducibility. Okay, the first thing is that the failures to replicate are mostly due to just biological variability or type 1 errors, but it's really a flawed experimental design that contributes in many cases. It is not scientific misconduct. Almost invariably, it's not deliberate misconduct. And so that makes this whole consideration very different than the things you guys have been hearing about for the rest of the day. I should say that there are differences of opinion on this, and you'll see a couple of references there. Stop ignoring scientific misconduct. And a surprising amount of papers that were actually withdrawn were not due to mistakes or errors or things that were not deliberate. They were in fact due to fraud or suspected fraud. So it's not that that doesn't occur, but I'm absolutely confident that none of the studies that we tried to replicate were in any way tainted by misconduct. They were just a matter of some of the details were hard to replicate, and some of the findings were simply not robust across conditions. Okay, you've heard this. I'm just going to put it out there again. It's just always worth remembering what scientific misconduct is, and it's hoaxing, foraging, trimming, and cooking, basically. And the one thing that I would say is that if non-rigorous practices are used deliberately to make your data look better and or really misrepresent, you have to kind of think about, all right, where does it become scientific misconduct? For example, to exclude an animal, an outlier, or whatever. There's good reason to exclude outliers. And we'll come to some of the best practices that might help you make that decision. Okay. One of the things I always suggest to people is that you pay attention when you read the literature to the things that might be indicative of a paper that was less than rigorous. And sort of in almost a decade ago, Begley, who was one of the leaders in this identification of some of the errors, published a paper on 6 red flags for suspect work. It's in Nature, and I think the reference is earlier on. Okay, first thing, were the experiments done blind? Were basic experiments repeated? Were all the results presented? That's a toughie, and you'll never know if you read a paper whether the author is actually presenting all the results, unless they tell you that, well, I did something that generates different outcomes, but I'm only going to tell you about one of the outcomes. And the problem is that depending on the statistics you use, if you only report 1 out of 20, say, outcomes, and that's at 0.05, then it's highly likely that that outcome is a type 1 statistical error. So you need to know how many different outcomes or measures or whatever were actually done before you can interpret the strength or significance or robustness of the one outcome that might be reported. Positive and negative controls, reagents validated, that's a big deal. NIH now requires a section on validation of reagents, and were the statistical tests appropriate. And here is one of the things that you might as well just start thinking about right now. And you know, when you read a paper, for example, and if you're looking at a bar graph and there are 4 bars on that graph, and people are comparing with t-tests between 2 bars, that's not an appropriate statistic, right? So a lot of these things kind of slipped through. I still find them in papers that I review. And if you go back 10 years ago, before journals started to be a little bit more careful, you'll see it there as well. By the way, one of the things that journals have done in terms of scientific rigor is insist on the publication of actual details on the statistics, meaning what statistic did you do? What are the numbers, not just, you know, bars and stars? And that is the way that you as a reader can go back and determine immediately whether the statistical tests were appropriate. Okay. So here are some things that I think we discovered might be elements that compromise scientific rigor. One of the things is failing to delineate starting and stopping points. So one of the reasons I asked how many of you were doing human subjects research is that all of you who are know that you have to file an IRB, and part of the IRB defines the number of subjects that you will have per group, right? And that's the experiment. You do the experiment until you acquire that number of subjects. A lot of biological, biomedical, whatever, non-human subjects research is done in a different way. And it really is a matter of, we go to the lab, we try something, we do a few studies, it looks promising, we do a few more studies, and suddenly somewhere down the road, we say, oh my gosh, I've actually got a paper here. And then we do the statistics on it, and oh gosh, it's P less than 0.06. Darn it. Okay, what do you do? Anybody? Just chime in. Come on, I know it's a Saturday afternoon, it's a beautiful day. Somebody say something.
Well, if it was,
oh, go ahead.
If it was, you do more experiments to hack your p-value.
That's what almost all of us would do. That's what almost all of us do. But that actually is called testing to a foregone conclusion, right? And it means that you're going to just keep generating animals until P hits 0.05. Now, you know, I have to say that, you know, just think about it for a second. That certainly distinguishes what we're just talking about here from what you're talking about with the human subjects. But you know, there are important reasons that might be the right thing to do. Suppose you're doing a study that you got to that point after 9 months of very hard work. Okay. Now, a statistician would probably tell you that what you should do is just throw those data into one stack and do the entire experiment again, but this time add enough animals to be sure that you've got sufficient statistical power. Okay, that's the proper way to do it. But the fact of the matter is you're not going to sit there and really do all that whole thing again. You can't. You've got to get your degree, you got to get a job, you got to get out of here. So the fact of the matter is that you probably are going to add animals, and that's, in my opinion, okay, as long as you report it, right? And this is where the issue of transparency comes in. To me, the most important thing when I read a paper is to, you know, really look at that again, and you know, if you have to add animals, make a plan, use the data that you have, calculate the number that you need based on adequate statistical power, and then do that number, right? And if at the end of that number, it's significant, fine. If it's not significant, well, there you are. And I see somebody actually said that. And so there are judgment calls here. And again, I would say there's no right answer here. There's good reason that one might do it one way or another. If it takes a week to rerun the experiment, I obviously would rerun it. If it takes 9 months to rerun the experiment, that's a different story. But the bottom line is, you know, have a plan. And most importantly, when you publish the paper, be transparent. I did an interim statistical analysis. We found this. We made a plan. We calculated the number of additional animals that we need. We completed the study. And now the result is either X or Y. Okay. That would be my recommendation for statistical rigor. Okay. Thank you guys for chatting. I appreciate that. So that's what the word means, testing to a foregone conclusion. Some of the other things here are lack of contemporaneous controls. I've already talked about that, which is that you do all the controls on one day, all the experimentals on another. Can anybody think of a reason why you might want or have to do that? You can either chat or just yell it out.
Drug preparation, perhaps?
Say again?
For the experimental, perhaps, you know, the drug preparation takes time. It's easier to separate that way.
Yeah, that's a good example. And thank you. The one that I use is, suppose that you are, that your treatment group involves the preparation of something that is, oh, I don't know, let's just throw out there, like a stem cell. And to actually generate the stem cells for that experimental group, it costs $10,000, right? Now, the way you'd like to do that experiment is that you'd like to do, you know, if you can't do everything at once, then you'd like to sort of spread out the treatment and control groups. And so you go to your advisor and say, okay, I want to do four preparations on one day, and for the next, and for the next, and for the next, for the total group of size of 12. Oh yeah, by the way, it's going to cost $10,000 each day. Your advisor is probably going to say, no, I don't have $40,000 to do that. But it's exactly the same thing as you said. You know, you can have a situation where it is legitimate and necessary to do it in a way that all the treatment groups receive treatment at the same time. But again, it's a matter of saying, okay, when I publish it, I'm going to say that, and then try very hard in your experimental design to control for it. Questions, comments? Anybody disagree? It's fine to disagree, by the way. It's Saturday. I'm just going to say, I think UCLA is going to lose today. Right, Vince? Fortunately, his sound is off. I love it. Okay.
Yeah, no, I said I hope UCLA loses so we can get rid of our crummy coach.
Okay. What about data exclusion? Is it never okay to exclude data? First of all, that's sort of a starting question. How many of you think that there are situations where it's okay or necessary to exclude data? You can just raise a hand or do whatever. Okay, good. Yeah. So numbers are still accumulating. Under what circumstances? Can somebody say what would be a circumstance? Yep, there's a chat. Sorry. You can just yell it out.
If there is an extreme outlier based on some criterion that you established beforehand.
Ah, I love it. What I love is the second part, which is based on some criterion you established beforehand, right? So there are good reasons to exclude data. You know, sometimes it's silly. Well, the assay obviously didn't work, or I have a human subject who went to sleep and didn't, you know, kind of complete the, there's 100 different reasons, right? But the important point is exactly what you said, that you want to define, to the extent that you can, exclusion criteria before you hit that point, right? If you kind of at the end of the day are looking at the data and there's one data point that is wacky, you know, that's really, unless there's some reason to exclude it a priori based on something you said in advance, to exclude it is I would say a questionable practice. Now, so what if you have that situation, right? What if one outlier or even two, whatever, is skewing your data so badly that you have no statistical significance and everybody else looks like it is? How would you handle that when you publish the work?
I was going to say, if there's sufficient data, could you just report, here's what it looks like if I include the data. If I did, leave out these outliers, this is the result I would get.
Exactly. Yeah. I mean, again, I think that's exactly the answer. And the probably, again, sort of these days, the journals would welcome that. Maybe 10 years ago, they wouldn't. So it's a really interesting, I think, pivot that the journals have made to admit those kinds of data, even though it might double the number of figures in some cases. But I agree. I think that's exactly the thing to do. And we do that. We actually, sometimes you'll have a situation in an experiment that you're doing where, again, we do surgical injuries on rats. And, sometimes we try to set things up in advance. So we will exclude cases based on a priori grounds. Sometimes the lesion's too big, the animal's completely paralyzed. Sometimes they're too small, whatever. We have sort of constraints identified in advance, but every once in a while you just get it and, who knows? So we'll report the data both ways. And I think that's a good solution. Let's see here. Could I speak about exclusionary criteria, report both results? Great. Okay. Could I speak about publication bias, null results? Yeah. I was going to talk about that later, actually, but that's a huge issue. So the publication bias means that basically, if you do a study, and I kind of talked about it, and maybe one set of experiments, just no differences at all, but you've done 5 other experiments and there are differences. What do you publish? It has been the tradition, and even sometimes this explicit request of journals, to eliminate data that are not particularly informative. Like, okay, there's no effect there. You don't need to talk about that. But that's a publication bias. There are whole studies that we do that just flat out, it's negative data. What do we do with those? It's called the file drawer problem. You put them in the file drawer, you never report them. And again, this has been a huge problem in the field. It's probably one of the reasons that there is a replication reproducibility crisis, because there are all these things out there that people have tried and they don't report them. Today, many journals explicitly say they will report negative results. May not be your highest profile journals, although I must say I've reported 2 negative results in Neuron, which is not bad. But again, journals are beginning to accept it. So just because it comes out in a way that is different than what you might have hoped or expected doesn't mean it's not publishable. And the other thing I would say is that a very interesting development, again, over this last decade, has been the bioarchive development, where papers are preprints are published. That's actually encouraged by many journals. In fact, in some journals are actually requiring pre-publication in bioarchives. And that's a good place to put things that are essentially negative results. But again, I mean, I totally think it's a very important thing, and it's fundamentally something that at least our field, and I think a lot of other fields are not only accepting, but actually welcoming. Good. Any other questions, comments? Again, you can either chat it out or just say it. Well, let me just talk about a couple of other things here. There's some other words here that I want to teach you. So we talked about improper statistics. That's something that, yeah, it's complicated. And, my strong encouragement to you is talk to a statistician early, rather than going to them with a bunch of data late. And actually, I will say that ICTS has some excellent consultation services. And Marguerite can tell you more about those, I think, than I can. The other one is actually something called p-hacking, and I'll talk about that just kind of in a minute. Insufficient statistical power is obvious. Partial reporting, we actually already talked about. Self-replication, transparency, publication bias. I'll come back to perverse incentives. And again, I say at the bottom that those of you who are doing human subjects, you kind of have a better control situation with human subjects because you're required to do it in advance. So, all right, let me tell you a little bit about, let's see, a couple of these terms. By the way, I'm giving you all these terms right now because one of the requirements that NIH has is that you must consider scientific rigor in your grant proposal. It has to be a consideration when you're reporting on previous literature. They want you to actually review the literature and say, how strong are these data? Has it ever been replicated? What was the statistical power of this study? They want a section that says, that really evaluates the rigor of the foundation that you're using for your own work. And then they want rigor in what you're doing. And actually, I'll tell you the way I've done it for several years since it started. I have a section that says scientific rigor in my grant. And I will use exactly the terms that I use here. Randomization is achieved by, blinding is achieved by, p-hacking is avoided by, and so forth. And you can write this in about a paragraph and a half. And even if the reviewers don't like what you say, they can't say that you don't have a section on scientific rigor because it's highlighted right there. It's a little trick in grant writing. If the section is there, the reviewer can't say you didn't consider it. Okay, so let me just talk a little bit about some of these terms that you can use. What about, okay, I kind of talked about all this. Some of these things I'm not going to say. I'm going to, again, Marguerite will have these slides so you guys can read it later on if you want. P-hacking, okay, P-hacking. It is P-hacking, not facking. It was, I forget where it actually, what year it actually came out, but it was first coined by Simmons at the University of Pennsylvania. Tom Insel, who is the director of the National Institutes of Mental Health, had this little blurb on it. And so basically p-hacking is sort of the sister of testing to a foregone conclusion, which is you have all these data and you do your statistic, your planned statistic, and it's p less than 0.06. And you say, well, what if I use the test instead of this test? Well, that didn't quite work either. So you kind of go through a whole bunch of statistical tests. Maybe you transform your data. That's p-hacking. You're basically in search of a statistical significance. Again, if there's a legitimate reason that data should be transformed, that's fine. But if you're just doing it to try to get to that magic number of p less than 0.05, is p-hacking. Again, in a grant, you can say, we don't do that, right? And if you say you're not going to do it, then it's best not to do it, right? But it is a practice that sometimes happens. And of course, if people are doing it, there's no way to catch it. I would say that if you ended up with a legitimate purpose, reason, whatever in mind, having to use a different statistic, then just again, transparency is the biggest thing. When you write it up, say, okay, we tried the statistic, it gave that result. We tried another statistic, it gave the following result. That's okay, at least as far as I'm concerned when I'm reviewing a paper. Okay, there they go. Outliers and again, the transparency thing. Okay. So there's a couple of things you can do to kind of avoid it in advance. And again, pre-plan, talk to your biostatistician, pre-identified primary and secondary measures, right? Decide on what and again, you have to do this in a human subjects experiment. It is a requirement in a clinical trial. You have to have a primary outcome. Talked about testing to a foregone conclusion, outliers and everything. So again, the bottom line here is that transparency is the key. And I think we've talked about all that, so I'm not going to go through all the details in this slide. But again, if you want to come back and read some of these things, they're going to be there. Partial reporting, I think I've talked about those. Okay, one last thing I do want to talk about, which is, if I can go backwards, perverse incentives. So anybody, what would be a perverse incentive? You can either just call it out or chat or whichever. I'll give you a hint. It's mostly timing.
Oh, so I was going to ask, do you mean like something that's so motivating, so good that it's difficult to say no? Or
yeah, right. Paying their rent, vaccine access. Yeah, I like those. I mean, so the perverse incentives I'm thinking about are for you guys. Oh, I've got to graduate. Oh, I've got to get my data ready for my next presentation. For once you kind of get beyond the training stage, it's well, even during the training stage, I have to get the paper published so I can get a postdoc. I have to get the paper in a high-profile journal in order to get a job. By the way, that's not true. Well, it's kind of true, but yeah, not entirely true. Once you kind of get out in the world, there are 3 critical days a year that all of us active researchers kind of both look forward to and dread. That being the deadlines for NIH grants. Okay, I've got to have these results ready to put in my NIH grant proposal. That's kind of a perverse incentive. Promotion and tenure. I've got to have this paper out before I can put my file together for my promotion. These are, it's all about time, and these are perverse incentives that are important to recognize. You can't avoid them, but they are important to recognize. And the one thing that I would say is that one of the things that I personally think is very important is in just keeping those in mind and keeping the scientific rigor in mind as you come to those, because you all know when those kinds of things come up, the pressures increase, and you just have to kind of keep focused on the things that are important, which scientific rigor certainly is. But that's an example. Here's another one that I just love. So suppose you submit a paper to Nature, okay? And this is really common, by the way. So you get the reviews back and they say, well, this is a really interesting paper. And we would be able to publish this if you do the following experiment and got the following results. Ooh, that's kind of a perverse incentive. I actually think that it would be good for journals to require that people actually indicate results that were, or studies that were done for that reason. This study was done because the reviewer asked for it, right? The rest of the work was done because that was my work. It just is one of those little things that kind of, I think, puts an asterisk on it for the reader to pay a little bit more attention to it. But I don't think any journal is going to do that. That would be my suggestion. Okay, so I'm going to just briefly go through some of the solutions. And this sort of started, as I said, about a decade ago, and NIH has been working hard on it. Kind of one of the first things was this paper that was published in Nature in 2012. It's a meeting that NINDS organized that I attended. It was a workshop. Everything that I've talked about today was discussed in that meeting in terms of blinding and random assignment to groups and everything. But the bottom line is really this whole word transparent, which means reporting everything that you did. Whether and how animals were randomized, sample size estimation, data handling, data exclusion. These are the things that represent transparency. And nowadays, the journals are actually not only allowing, but requiring you to put that in. So again, good record keeping from the start allows you to do that. This is just, blatant, whatever, self-advertisement, try to get my H index up a little higher, right? So if you want to refer to a paper, we wrote a paper on some of the best practices, and well, yeah, it never hurts to have another citation. Never mind. It'll be in the PowerPoint. But some of the things that are sort of laid out in there are a set of standards. And again, if you want to read the paper, you can, or if you want to read this, you can. But several of these things are just sort of maybe helpful things to think about. We wrote this based on preclinical studies using animals, but a lot of the principles apply. So, again, blinding, sample size determination, data handling, stopping rules, we've already talked. What is it that constitutes an experiment? When are you done? Inclusion, exclusion criteria, outliers, identification of outcome. These are all really the things that define what an experiment is. What are the data that you're going to generate? I want to spend just a couple of minutes talking about bias, because it's not the same thing that you guys were talking about earlier on. I love Ransohoff's definition. Bias is not something that we do deliberately. It's not even it's not even conscious. It's completely unintentional, but it happens every day. So let me just give you an example. Suppose you're going to measure the size of cells in culture, in a tissue culture dish. How do you select the ones that you're going to measure? Any chats? Got a chat? Visibility of the measuring instrument. Yeah, that's certainly important. Yeah. Let me ask it more specifically. How would you randomize? And I'm asking because a lot of times you get a paper and they say, well, we randomly selected cells to measure dendritic length, right? Or something like that. And then my thing is to, as a reviewer, I say, okay, how'd you randomize? And a lot of times the answer is, well, we just, kind of went in and chose cells. What do you mean? That's not random. Here's the reason. If I guarantee you, we're all human. We see things that catch our attention, right? I guarantee you, you're going to go in and select cells on the basis of something because we're human. It may be because it's a pretty cell. It may be because it's not a dead cell. It may be for 100 reasons that you don't even recognize. But I guarantee you, your selection is not going to be random. So the way to do it is with something called systematic random sampling. And this is something you just have to think about. It's not immediately intuitive that you would do it in the first place, but how to do it. So this is where you have to kind of stop and think, how would I do it? Well, in the case of cells and culture, what you might want to do is define a grid. You have a microscope a stage, you define coordinates, and you say, all right, I'm going to measure the closest cell to this crosshair on this grid. And then I'm going to choose the crosshairs based on a random number generator. And in 5 minutes, you can spit out a sampling grid that will tell you which cells you're going to measure and which cells you aren't. It just takes about, your data depend on 100 different ways of data analysis, but that's just the kind of thing that we need to think about. And this is what we mean by bias. It's this issue of minimizing things that might creep in that influence the data in ways we don't understand, anticipate, or have any conscious knowledge of. So that's really, from the experimental standpoint, what bias is all about. So basically, you need to always think about techniques to minimize unintentional bias. Okay, I've already talked about this. I'm not going to talk about that. This is one of the terms that Harris uses, is harking, which is hypothesizing after results are known. By the way, that's not a problem if you actually have multiple hypotheses that you're testing, which I would just end by recommending that you guys read something called strong inference. It's a wonderful way to design experiments, which is basically never have an hypothesis, which will have a set of hypotheses that you're testing, and that your outcomes will distinguish between those hypotheses. This is a quick read. There's a couple of really nice papers. I'm going to quit because it's 3:30 and you guys really need a break. I think there's a couple of more slides here, but it's Saturday afternoon. It's a gorgeous day. I'm sitting here looking at my window and it's just too nice. But I'm happy to take any questions. And as I say, I'll send this to Marguerite, and she can send it to any of you who are interested in looking at it.
Great job, Oz. Anybody have any questions for him? Don't be bashful.
Yeah, and let me just say, this is a lot to think about if you're just starting your research. And I've given this talk now in a variety of different ways in kind of the same context of people who are sort of just coming into something or starting out. And what I find is that it's almost too much to think about. I would encourage you, any of you who just want to contact me and say, hey, I would really like to ask you a question about this, feel free. I'm really happy to do that. I love to think about data. I said I can't imagine myself actually getting into this issue of reproducibility and talking about scientific rigor, but it really is intellectually interesting to me, it turns out. So I'm happy to talk to you. Registered reports and pre-registration. That was a question in the chat. Yeah, I mean, that's something that is becoming much more common. So basically, a registered report is one where you say, I'm going to do this before you ever do it. And journals, actually, some journals, including eLife, which is a pretty good journal, are accepting pre-registration or registered reports. They will basically, you send them the proposal, this is the study I'm going to do, and they will agree in advance to publish that study, whatever the outcome. No. It's an interesting and I think important thing going forward. I don't think that it's something that very many people are doing, but it certainly has aspects of it that are, I would say, more impactful for rigor than a lot of other things that you might do. So yeah, I think it's a very interesting and important strategy. Thanks for the question.
Also, has there been much discussion about genetic drift? You know, we buy our animals from these vendors. We're assuming that forget Jackson, let's just say we're dealing with a rat. We buy a set of rats from one vendor for a variety of different reasons. We try to buy the same strain from another vendor. And clearly, genetic drift is something that just really isn't discussed much, but it certainly happens.
Yeah, that's really important. And that's, we think, one of the reasons why some of the studies that we did didn't replicate, and likely some of the studies that others have done haven't replicated. Genetic drift is certainly one problem. The other one is the amazing, actually, influence of diet. And by that, I mean the chow you're feeding your animals. If any of you actually want to experience something, walk down into the vivarium during the day, right? You might think that, okay, the mice are living this way and that, but if you walk through the vivarium, you realize that they're running these very loud floor machines and crashing around. And that is happening during the light cycle of the day. By the way, if the light cycle is reversed, the animals who are in the dark are experiencing this noise. They're getting a totally different experience. There's just a huge number of variables like this. But the mouse chow actually has been shown recently to completely change the way an animal responds to certain drugs, certain behavioral paradigms, seizure susceptibility, 100 different things. And how many times do you read a paper where they tell you what chow the mouse is eating? So it's an, again, it's an important kind of thing, and it is something that is worth it for you. It's another one of these details that probably is worth putting in your experiment book. Because you might go to another university and do the same studies, and all of a sudden it doesn't give you the same, some things just don't work, right? Who knows, right? But the more details you have, you can at least compare. And there have been some very interesting studies about just total changes in outcome, depending on things that you never would have imagined. One of the ones that I found fascinating is pain susceptibility, or measures of pain in rodents depend on whether the tester is male or female. Okay, guys, I'm sorry, rodents just aren't as comfortable around us as they are around female testers. And we just confirmed this again a couple of days ago. One of the students in my lab is female, has been testing mice, and mice love her, go to sleep on her shoulder, and she gets one set of results. And we had somebody come in, we were doing iterative reliability, which is always a good thing to do, by the way. And the mice were tested by a male member of our lab. Mice were just going crazy, did not perform in the task at all, and kind of replicating the old thing that number one, your tester matters, and male versus female testers actually are a very well-known variable. So yeah, Vince, it's a huge problem and goes well beyond genetic drift for sure.
Yeah. Okay, we got to stop here. Oz, thank you so much for taking time out of your weekend and doing this. Great job.
Sure, thank you. And guys, get outside. It's a beautiful day. I'm sorry you have to be inside. I'm going right back out, but
Thank you, Dr. Stewart.
Thank you.
Okay, let's take a 10-minute break, and let's see, that'll bring us back at what
3:42.
3:42.
Mhm.
Yep. All right. See you then. I'm gonna get a quick drink.
Thanks. Can I do your introduction, Vince?
Nope, I'm ready to go.
Okay.
I'm gonna go go ahead and share my screen.
Okay.
Okay, how are we doing? Can everybody see my screen?
Yep.
Great. So obviously I'm going to talk about mentoring relationships today, and a large part of the perspective that I bring revolves around several things. Number one, when I first started my educational career at college, really I was basically geared towards a career in high school as a biology teacher and a coach. I wanted to do what my football coach and my track coaches had done and kind of emulate them. And in terms of trying to figure out how to make my athletes perform better, I really got hung up on the biology underlying muscle, how to make muscles larger, how to make them faster. And that took me down a road that I wasn't expecting, which was a road towards UCLA, which I've already mentioned, the greatest university in the world. And there I was fortunate enough to have fantastic mentors who were absolutely at the top of their game with respect to the field of muscle biology and muscle plasticity. And so that then took me away from that career that I envisioned as a high school teacher and coach into the collegiate realm, and really the environment that we have here. And I found it incredibly stimulating from being both a mentee and a mentor. And in reflecting back, when you sit there and think about, I think not only my career, but your careers, obviously each and every one of you have been a mentee all along, but also you've probably have served as a mentor in one form or another. You may have family members, young family members who look up to you and sit there and want to emulate what you've done. You may have moved beyond your undergraduate level, or you have moved beyond your undergraduate level. Now you have undergraduate students that you work with who want to emulate what you do. They want to be like you. And of course, all throughout this trajectory, you've been undergoing different forms of mentoring. And the point that I'm getting at is that being a mentee, being a mentor, it doesn't just all of a sudden come to a crashing halt. There's a blend of the relationship of being a mentee or a mentor. We're all learning throughout the course of our lives. Just today, in listening to the speakers, as I said earlier, you know, I'm so stimulated by the talks that I hear. I wish I could have multiple lives and, you know, kind of put my toe into each of these arenas because they're all fascinating. They're all stimulating. But the point that I want to make to you today is that ultimately, at the end of the day, you all have or will serve as mentors. And that relationship, the ability to serve as a mentor, number one, is really a gift. And number two, it's something that we all have to take seriously because we've got individuals who are entrusting their careers, their guidance in your hands. And so we want to try to develop certain rules that will guide us as mentors as we go along. But today I'm going to be speaking about the mentee-mentor relationship, and you should be able to sit there and take a look at these concepts I'm going to present and sit there and think about how you can effectively use them as a mentee and how you can effectively use them as a mentor. So coming back to UCLA, when I was at UCLA, it was an amazing time up there. As I said, I had world-class instructors in muscle biology, people who are really on the cutting edge of figuring out the biochemistry of how muscles work and the thermodynamics of muscles contracting. But also at that time, there were phenomenal coaches up at UCLA. Specifically, there was John Wooden. John Wooden was probably the greatest college basketball coach of all time. And you can rank that or use a metric of sitting there and thinking about how productive he was as a coach. And let me just say that he won 7 national championships back to back. Nobody's going to ever do that again. Ultimately end up winning, I think, something like 10 national championships. At one time, his team had won 100 consecutive games. Believe me, that was a terrible day when they lost in the 101st game. For all of us UCLA fans, we cried all day long for that one. But there was something much deeper and more important about John Wooden. He actually started out as an English teacher in high school, and he coached high school basketball. And he had this deep appreciation for being a teacher, a very deep appreciation of being, as I said, a teacher. That came from his coaching, but it extended on over into his English classes, and that's what he taught. And he was an amazing poet way up until his 90th year of age. So an incredible career. This passion, though, that he had for his students spilled over into what he called the pyramid of success. And this was simply a set of beliefs, of approaches, of ethics, moral behavior that he wanted his athletes to adhere to. And this is, I believe, his book, The Pyramid of Success, has sold something like 22 million copies. So a highly successful publication, and used many, many times over by successful businesses that wanted to instill a basic management approach in their employees. And here you can see some of the different attributes that made up his pyramid of success. And as you're going forward and thinking about being a mentor, I would encourage you to try to develop your own pyramid of success, or a pyramid of the attributes that you'd like to instill in your trainees. And don't treat that lightly. I honestly believe that teaching and being a mentor is certainly one of the most important things you can do in your life. That applies in relationships that aren't within the family itself. But sit there and think about having children. Basically, you're a lifelong teacher of your kids. That teaching becomes important up till about the age of 12, and then your kids transition to the point where they know more than you do, and they start telling you, Mom, Dad, you don't know anything. I'm joking about that, but there is some truth behind that as well, as many of you will learn. Now, John Wooden not only cared about being a mentor, but there are many other organizations, associations throughout the world that care about these. For instance, we've just had the Olympics this past summer. The International Olympic Committee has put together a set of documents related to the key characteristics of mentoring. There is the University of California, and believe it or not, they have within their personnel manuals some policy related to mentoring. Now, I'm just highlighting for you what it says about mentoring postdoctoral scholars. And there's a whole set of guidelines that are related to this. And you can find these in the academic personnel manual, and you can look under policy 390. But you can see that the faculty, in fact, are evaluated based upon their mentoring. And it states here, faculty mentors are responsible for guiding and mentoring the advanced training of postdoctoral scholars. In that role, faculty mentors should make clear the goals, the objectives, and the expectations of the training program and the responsibilities of the postdoctoral scholar. They should regularly and frequently communicate with postdoctoral scholars, provide regular and timely assessments of the postdoctoral scholar's performance, and provide career advice and job placement assistance. The things that I'm going to describe for you basically involve some of the key principles described here. And there's been a lot of thought and consideration given to the responsibility of mentoring, as you'll see. So here, in terms of thinking about the learning objectives, what we're really trying to do today is to try to basically introduce you to key concepts. Certainly, there's no way that we can go into the type of depth that we would like, but that's basically what you're being exposed to, the key concepts, principles. So with respect to mentoring relationships, I've written here for you to think about 8 fundamental principles related to good mentorship. But most importantly, and you heard that today in several of the talks, especially Nadia's talk on conflict of interest, everything boils down to communication. And as long as you're communicating with people, you're at least trying to establish lines in which things are being made clear, or you're trying to avoid areas of conflict. So what are these 8 fundamental areas to address? Well, there's the appointment process. There's orientation to the laboratory and to the mindset of the laboratory. There are different types of mentoring models to think about. We can think about the classic model, which I'd refer to as a dyadic model, where there's you as the mentee or you as the mentor, and then there's the complementary aspect of that, either the mentor or the mentee. There can be tiered models. Tiered model might be where you've got a primary mentor who's really got the content expertise. They're the one who's really driving the bus. That then is complemented by having a secondary mentor who could be, to balance things out, could really have a role as providing guidance in terms of professional development. And then you could in fact have a individual that we would call a peer, where you'd have the involvement of peer-to-peer mentoring. And so that would be referred to as a tiered model. There's this issue of trust, and trust is at it serves the foundation for all relationships, and especially in the type of field that we're in. You have to have trust between yourself and your mentor, or between yourself and your mentees. There's the delineation of the education/training program. There's the evaluation component, where it's clearly delineated in terms of how you will be evaluated as a mentee, or how you as a mentor will go about evaluating your mentees. Career preparation is really important, and that, from my perspective, involves issues where the mentor is trying to promote you, or as a mentee, you're having serious discussions with your mentor in terms of what you should be doing to help move your career forward. And then there are these areas of sensitivity. So we're going to kind of go through each of these. Don't hesitate interrupting me as I'm going along. Certainly want to encourage you to do that. So in terms of the appointment process, you want to become familiar with the individuals that make up the lab. You want to know what the mindset of the lab is. And also you want to know something about how the lab is supported. Let me just give you an example. If you walk into a lab and you're interested in studying, let's just say muscle biology, and you walk in there blindly, unbeknownst to you, there's no real funding source that's supporting that lab, then more than likely your opportunities are going to be severely constrained. You're not going to have a lot of opportunities in a lab like that. On the other hand, if you're in a laboratory where there may be two R01s that are in play, then more than likely there's going to be lots of resources available to you, and you probably will have a really productive time in that laboratory. There'll be lots of opportunities that will open up to you. So it certainly is reasonable for you as a mentee to have a good understanding of how the lab is supported. And I think you want to be very transparent as a mentor and let it supported. You need to be very honest, because seriously, you've got an individual who's involved into believing that you can make good decisions in terms of how they're going to proceed. What are the expectations? This is a really important part. So oftentimes we talked about alignment between between the mentee and the mentor. So as a mentee, of course, you want to be able to voice your expectations in terms of what you're getting out. And you should be, one of your expectations should be that you're working in a world-class laboratory. If you see yourself as moving forward and being a scientist at a tier 1 research institution, you see yourself as an academician, then you should basically be targeting laboratories that are doing world-class science. That's where you need to be. As many of you have heard me say before, we are in one of the most competitive careers that you could possibly choose. Really, really competitive. When you submit a grant to NIH, you're going up against the smartest of the smart and the best of the best. So as a mentee, as a pre-doctoral scholar or postdoctoral scholar, make sure you let your expectations be known to the mentor. And of course, if you're serving in the role of a mentor, then you need to make sure your expectations are very clear to the mentee. And one of the things that you need to make clear in terms of expectations is the type of work ethic that you have, or the expectations of the work ethic. Personally, I will say that I never entered this field thinking that it was going to be a 40-hour-a-week job. As I said just a few moments ago, we are competing against the best of the best. Each and every one of you should be striving to be the best that you possibly can become. And with that comes a lot of hard work and many weeks, for the hours that we're putting in are more than 40. And for me, I'll just say personally, I was so darn excited about my science. I might have had gels running all day long, and I was coming in at 1 o'clock or 2 o'clock in the morning and staining the gels just to see what the results were, because I was so darn excited about the science that I was doing. And hopefully you have that same excitement about the science that you're doing. Our motivation should be about this internal drive that we have to learn something new every day, with the hope that we're going to make an impact in terms of treatments for improving people's lives, making their health better. Coming back to what I mentioned in terms of the funding, this impacts the types of resources that are available. For me, just a quick short story. For some of the stuff that I did as a doctoral student, I needed very sophisticated servo motors that ran in the range of $10,000 to $20,000 for just a motor. And luckily, I had a mentor, and not only that, but I had a doctoral committee that was very helpful. And so they provided those monies to help me get this particular system up and running and allow me to really do state-of-the-art mechanical measurements. You can see here that I've written, become an active member of the lab. You have to do that to have a successful experience in the lab. Obviously, you got to be an active member of that lab. And as I mentioned, in terms of these mentoring models, there's the traditional dyadic model, which certainly can work for many individuals. There's the group models, and there's these so-called tiered models. Nowadays, I'll say that for those of you who might be contemplating some type of a K award or a K application to NIH, they're looking for more of a group model where you've got your scientific content mentor, that would be your primary mentor, but then you may have a couple of other mentors who provide more of a professional career guidance role rather than a scientific or a content expertise. And then there can be these other models that involve not only your primary and secondary mentors, but also this tiered model where you have peer-to-peer mentoring, where you may have somebody who recently has become a junior faculty member, and so they have a lot of insight about that ramping up phase where you're transitioning from your postdoc into that new faculty position. And the same can be applied at the postdoctoral level or the pre-doctoral level. Basically, the way I view it is you want to be a learner of all facets of doing research in science in a laboratory. Came back and talked about this issue, come back to talk about this issue of trust. And as you can see over to the right, there was this individual, Stephen Covey. Unfortunately, he's no longer with us, but he had a book that was incredibly popular. And I'm going to say again, I think that book sold over 20 million copies. And the title of that book was The 7 Habits of Highly Effective People. And you can see the 7 habits that he outlined there. But one of the issues that he addressed in that book was this issue of trust. And as I stated, trust is this foundational component behind any relationship. And clearly, that goes both directions in terms of being a mentor or being a mentee. If we're thinking about our mentors, certainly you want to be picking mentors who have a good reputation as a mentor. You don't want to be picking somebody who has a variable reputation, and you're going to just roll the dice and hope that your relationship is very strong there, very good. Again, making sure that you make your goals, whether it be as a mentee or as a mentor, very visible. One of the things that I'll say that I think is really important from a mentor's point of view is that the metric of how we're doing, the single most important metric of how we're doing, is probably publications. And as a mentor, I think it's really incumbent upon the mentor to ensure that their mentees have a good, strong publication record. And it's not, I don't believe, a good reflection when you have a situation where the mentee comes away with 0 publications from their doctoral program. That's a failure in my mind. The mentor has failed, assuming that there were no issues with the mentee. And so that's where clearly expressing goals becomes important. As a mentor, I think you want to sit there and let your mentees know what the publication plan looks like and how many publications they'll come away with. And the same thing is applicable for the mentee's perspective. As the mentee, you want to know what's the main research project, but from that, what are the sub-projects that potentially are going to result in publications? Providing a discussion about the degree of oversight is also important. As a mentee, I think it's reasonable to expect that you'll have a lot of oversight. In other words, the mentor should be keeping close track of how you're progressing. If they're not, then I would encourage you as a mentee to go talk to them and try to basically accelerate the discussion to ensure that you have good, strong oversight and that it's going to lead to a highly productive doctoral program. Now, I'll mention that there are postdocs who think that they should have a lot of leeway. And I believe that's absolutely true as long as you demonstrate that you're worthy of that leeway. And so that postdoctoral phase where you're trying to develop your independence, I think it has to be kind of a graded experience where initially there's a fair amount of oversight, and that as you continue to be successful, that oversight is relaxed and you become more independent. Some of you have heard me tell this story, but this is a true story. I had a postdoctoral fellow, and we were doing work on looking at calcineurin and the importance of phosphorylation. And the results that we kept getting were different than what had been published. And so I was trying to identify everything that potentially was wrong with the way we were doing our assays and our analyses. And one was I kept asking him, you know, what types of inhibitors are we using for these experiments? And so we were supposed to be using phosphatase inhibitors. And we spent literally probably 6 months, $100,000 on doing these experiments to try to get them right. And as I said, I had many discussions trying to ensure that every aspect of our assays was absolutely correct, including talking about these phosphatase inhibitors. And after 6 months, he comes to me and he says, I have a confession to make. And he tells me that, in fact, we weren't using phosphatase inhibitors. He wasn't running phosphatase inhibitors for the assays, but he was using protease inhibitors. And you can just imagine at that point, you're just like shaking your head, thinking how were all the discussions that we had neglected? And now all of a sudden I find out that he's using protease inhibitors, which for those of you who know the biochemistry, you know that that's a long way away from a phosphatase inhibitor. So, you know, in that case, I was trying to really be very judicious in terms of my oversight. But I think the point I'm getting at is that as a postdoc, yes, we want you to have independence, but you got to really demonstrate that you're worthy of that. And if you can't do that, then obviously there's a problem there. And of course, as we're doing science, we all know that the goals are constantly changing as the science evolves, that we're always trying to basically evaluate what we're finding and what we're doing and how that's going to impact on where we're going. So that should be a common occurrence of these mentee-mentor relationships. In terms of education and training, you know, there should be lots of discussion going on in terms of experimental design, analysis of data, problem-solving strategies, which apparently I did not do well with this one individual I'm mentioning, and critical interpretation of the data. And this should be happening typically at your lab meetings. Now, one of the things that I do want to mention, and we heard this earlier today, is that labs can get into trouble if they're not careful with what they're doing and how things are being done. We had Melanie Fabian on earlier today talking about working with animals. And for 6 years, I was the chair of IACUC. What was the common issue we faced in terms of adverse events where we had to intervene? It boiled down to this. It was either the investigator or their postdoc or pre-docs doing things that were not approved in their IACUC protocols. And there's a simple way to avoid these things. And I want to encourage each and every one of you as a mentor and as a mentee to impart this practice in your lab. And that is every 3 months or every 6 months, just go through your protocols and remind everybody what the key approaches and techniques are. And all of you will hopefully relate to this, is that in laboratories, labs are not static. We have people coming in and leaving the lab, new faces, new members of the lab. And you want to make sure that everybody's up to speed in terms of the practices and what's spelled out in these IACUC protocols. And certainly the same thing applies to the IRB applications, the human subjects applications. Just make that part of your laboratory practice, whether it's as a mentee or a mentor. And you'll avoid a lot of heartache in doing this. I believe Melanie mentioned that there was a situation that we had where an investigator at UCI basically got into an argument with a program officer at NIH because this PI was doing things. He wanted to evolve his research in line with what he was finding. The program officer said that was not spelled out in their funded R01 program. And at that point, the program officer contacted the Rio, the individual at UCI who's in charge of compliance, and they had a timeout. That timeout lasted a year. It costed that individual's laboratory. All of his staff left. You don't want to run into these compliance issues. You want to stay as far away from them as possible. So be smart and just review the IACUC protocols, the IRB protocols on some type of a regular basis. Everything should be good. So that relates to up here in terms of discussing these types of things. Always try to lay out a timeline for the progress of a research program. Again, this is as a mentee and as a mentor. It's just going to help it make things transparent. And of course, we know that these things are going to evolve again as the individual evolves. I would say that a good mentor will always encourage input from outside. So it could be that there's some new type of technique that the PI or the mentee wants to bring in-house. And as long as that's consistent with what the research is requiring, then there shouldn't be any issue there whatsoever. There are some mentors who don't like to have any outside input, and you know, that then becomes an issue where the mentee and the mentor are going to have a discussion. Coming back to the lab meetings are an important place for discussion and sharing and exchanging data and thoughts and interpretation, and that should all be good. If you're in a lab that's a very stimulating lab, you should be having great discussions in terms of what your data or other individuals in the lab, what their data may mean or how they might go about evolving the research. I want to come back to the issue of writing manuscripts. So again, if you're serving as a mentor, you should lay out for the individual, the mentee, if it's a pre-doc, post-doc, basically a schedule where you sit there and say, all right, I want you to begin to develop the introduction, and I would like that to be on my desk in a week or 2 weeks. Clearly, what you want to do is you want to do those probably after you've collected the data and you sat down and talked about it. But what I would say is that you want to help your trainees out by giving them a schedule, giving them a deadline by which they should have a certain section of a manuscript to you. And of course, as a mentee, what I would encourage you to do is to sit down with your mentor and have them basically lay out a timeline, or you more proactively lay out a timeline and sit there and say, I want to try to have the introduction to you in the next week or two. Set expectations for yourself. If you're in the position of the mentee and the mentor, excuse me, the mentee as a pre-doc or postdoc, there's nothing wrong with that. It's helpful, and a good mentor is going to embrace that. And if you're the mentor and you find that your mentee is struggling, then intervene and begin to impose timelines. Nothing wrong with that. The whole goal is to ensure that the trainees are having a successful experience. Okay, in terms of education, training is kind of leading or following up on what I just stated. A good mentor should provide constructive feedback on any written document. Now, another thing I do want to mention is that there are some PIs who will turn over writing an IACUC application or an IRB application, and then they will just come in and give it a cursory overview. I don't like that approach. That creates a bad situation, and here's the perspective I'm speaking from, and that is, so as a member of IACUC or a member of IRB, if I get a application that has been written by a pre-doc who really doesn't have much experience, that probably, unless that pre-doc is a remarkable individual, is probably not going to be a really well-written IACUC or IRB document. And I would say that if you're the mentor in this situation, you've got to avoid situations like that, because that's going to create a negative overtone within those committees regarding you as the mentor, as the PI. You need to basically be very compulsive, very obsessive about these IACUC and IRB documents. There is no harm in having a pre-doc or a postdoc develop those applications, but you should really make sure that once it leaves your lab, it's got your stamp of approval on it, and that stamp of approval has got a very high bar associated with it. I can tell you there are investigators at UCI who have these phenomenal reputations within the IRB and the IACUC because they've got all their T's crossed and their I's dotted, so to speak. Clearly, as a good mentor, you want to be encouraging creativity and independence, but that has to be warranted. And also at the laboratory meetings, there should be issues discussed related to scientific conduct. These things may not seem important to you, but once you get your hand slapped once or twice, they become very important. And by the way, I also want to follow up on what Dr. Stewart talked about in terms of this exercise that he went through where they were trying to replicate the findings in other labs. The last thing you want is for IACUC, IRB, NIH to come knocking on your door and sit there and say, can you show us your data and show us your notebook that has all the protocols and all the data related to such and such experiment. So what I'm telling you is be very meticulous in collecting the data and creating a library or a set of notebooks that contains that data and the methods by which that data was collected. That should be absolutely essential. And that should be part of the discussion that occurs at the lab meetings, whether it be you as a mentee or you as a mentor. evaluation process. Now, some of you in the meeting today, you have a understanding of how it is that the ICTS conducts our evaluations, where we meet with you every 6 months. But as a mentee or as a mentor, you should be involved in some type of regular periodic review. Could be every 3 months, could be every 6 months. I don't think once a year is frequently enough. And I'm hoping that as a mentee, that you have such a great relationship with your mentor that you're sharing science almost on a daily, hourly, several times a week basis. That's how the scientific environment, from my perspective, should be. It should be incredibly exciting and stimulating, where you want to share information with your mentor. And of course, as a mentor, you want to be providing your mentees the opportunity to become involved in really science that really stimulates the mentee. You should always have these IDPs, these individual development plans that are going to spell out on paper what the path is going to be in terms the path for the mentee, or how the mentor is going to evaluate the mentee. And these should basically address key aspects of the duties and responsibilities. And nowadays, it used to be where IDPs were actually pretty rare. Nowadays, with all the focus on trying to help make the training environment as successful as possible, IDPs are pretty well, they're pretty ubiquitous is a better way of stating it. But if you would like IDP and you don't currently use one, please don't be hesitant to contact Marguerite, myself, or Brooke. These assessments, they should be frank and candid discussions. They shouldn't be discussions that where there's this underlying tone that's never brought to the surface until there's so much dissatisfaction on either the part of the mentee or the part of the mentor that now you've got this explosive event that takes place. And this is kind of what Maritza was talking about a bit today, is that in these relationships that we have, you want to be proactive, and we all want to have successful relationships. But the way to go about doing it is to have these frank discussions and to be proactive rather than allowing things to kind of build up this steam and this animosity, so that now you get into events where you know, it's just not going to turn out very nice. And if you're currently a mentee, I think you want to be in a situation where you can provide honest feedback to the mentor in terms of whether they're doing a great job or whether there's just one aspect that you would like to see them do a little bit better. But you want to be very honest about these relationships. Career preparation. As a mentor, we all want our trainees to be successful. And so there's many things you can do as a mentor. You can take these individuals, your mentees, to professional society meetings and introduce them to individuals who are well-renowned individuals in that particular area of science. You can try to get them engaged in different activities in professional societies, for instance, as a reviewer. There's so many different things you can do to help the mentees. And so as a mentee, certainly if becomes an opportunity to say review a manuscript, you might sit down with your mentor and just sit and say, you know, I see you reviewing manuscripts for such and such journal. If there's ever an opportunity for me to help, please let me know. That's a good process because it really helps you become better acquainted with the review process at the journal level. Here, coming back to stepping stones, a good mentor should always be looking out for stepping stones. For instance, if you, as a mentor, if a mentor's got a really good pre-doc, then they should be looking out for the next stepping stone, which more than likely would be a postdoctoral position. So they could be contacting individuals within the profession with regards to postdoctoral positions. Many different ways you can help out there. As a mentee, I would encourage you to be proactive and try to network at professional societies on your own. And so many professional societies have a postdoctoral subgroup. And so you want to become acquainted with those and find out what types of activities they have ongoing. And that may help you out as well. And then there's this area of sensitivity where, you know, certainly we want to respect everybody's opinion. And so there has to be an environment where basically you're embracing everybody's input. And here I'm really talking about as it applies to science. Again, there could be dissatisfaction with the mentor themselves. And so there should be opportunities to in a very safe way, express that. And there can be many, many other issues that apply in terms of family issues and personal issues, where as a mentor, you really have to honor and value what can go on. A very simple one that I've dealt with in the past is having trainees where there's a pregnancy that occurs. And so now you've got issues related to, you know, maternal, paternal leave. That's just part of life. And so nobody should ever be faulted for that or basically suffer negatively as a result of that. So here's where I'm at, is that there's no science tomorrow, there's no medicine tomorrow without training today. And so for each and every one of you, obviously we want you to have great mentee experiences. The quality of the science that you do, the quality of the training depends upon you having good mentoring. And as you go out there and become mentors, hopefully you will remember this statement. This highlights the value and the importance of mentoring. And then the last thought I want to leave you with comes back to John Wooden. And this is the way I try to think about my life on a day-to-day basis. I'm not successful every day, but this is what I strive to do, and that is to make every day a masterpiece in terms of how I interact with my family, my wife, with each and every one of you, with my colleagues. That's the goal, is to make every experience I have as positive as possible. Some days it's just not going to happen, but that's my goal. And hopefully there's some days where I do it, I get there. So with that, I'm done. And thank you for listening. If you have any questions, please speak up. Don't be bashful. Okay. So hearing none, actually, go ahead, Roz.
Yeah, so I'm here. So whenever you're ready to do the transition, we can.
I'm coming right to you because as part of my talk, I actually mentioned that having no publications from a doctoral program, I don't believe is a good result. That's a disservice to the doctoral student if they do not end up with any publications, at least at our level. So that kind of feeds into your discussion on authorship. And let me just say a little bit about Roz. First, and very impressively, number one, she's a chancellor's professor, which is a very high level of honor. She has served as the chair of the Department of Microbiology and Molecular Genetics for quite a while, which also is very impressive, and kudos to you, because being a chair sometimes is not the most rewarding experience. He has been the president of the American Society of Virology, and becoming a president of any of the professional societies is really a high degree of honor and respect. And she's also a fellow of the American Association for the Advancement of Science. So with that, Roz, I'm going to turn it over to you.
Okay. Thank you, Vince. So if you stop sharing your screen, I'll start sharing mine.
Yep. Yeah, here we go.
Okay.
You should be good.
Okay, can everyone see that? Okay, excellent. Okay, so as Vince has just told you, I'm going to talk about the responsibilities of authors and reviewers in both journal submissions and also grant submissions. You may not be submitting grants yet, but you will probably be submitting fellowships. And eventually, we hope you will go into academia and submit grants. Okay, so with that, what constitutes authorship? That's a very basic principle. So the authors should have made an experimental, technical, or intellectual contribution to the work. It should be restricted to those who thought of the study, performed key experiments, or interpreted the results. If you have provided reagents such as antibodies, purified proteins, cell lines, clones, or analytical software programs, that should not result in authorship. That should be acknowledged in the acknowledgement section of a manuscript. Journal requirements for authorship are that all of the authors must take responsibility for the contents of the manuscript. They must consent to the submission of the manuscript, and they must have read the manuscript. Now, I know that seems absurd, but you will see in a few minutes that we have journal articles that have 15 to 25 authors. And so it is very important that all of the authors must be fully aware of what's in the manuscript. This is a point that many individuals are not quite aware of, but all journals and NIH requires that authors must be willing to provide any reagent that's described in the manuscript, such as a cell line, a mutant, an antibody, to the scientific community if requested once the paper is published. So once you've published the paper, even though you've worked on making this cell line for 3 years and you want to do many more experiments on it, and you don't want your competitor to have the cell line, I'm sorry, but once you publish it, you got to send it if the competitor asks. I mean, don't volunteer it, obviously, but if asked, you do have to send it. Okay, and there are new NIH requirements for authors. So all primary data sets from genomic, proteomic, structural, and metabolomic studies must be deposited in public databases, and the acquisition numbers must be reported in the paper before it can be published. This is so that others can access the primary data and can also analyze it. It's part of the effort of NIH to increase reproducibility and rigor, and I think that you had discussions on that earlier today. So all primary data must be made available to the scientific community. There are at least 2 publications, Proceedings of the National Academy of Sciences and the Public Library of Science journals, PLOS, such as PLOS Biology, PLOS One, PLOS Genetics, etc., require that the role of each author be stated in the acknowledgements under author contributions. So as an example, for this paper in PLOS Pathogens, there are 23 authors on this paper. And the contributions are described as conceived and designed the experiments, and then the initials of all of those authors who conceived and designed the experiments, performed the experiments, analyzed the data, wrote the paper. So everyone who had an active role has to have their role defined. Now we'll talk about peer review. So manuscripts get reviewed unless you send them to the new bioarchives or medarchives, in which case those are not peer reviewed. So be aware of that. But journals that require peer review, there are responsibilities of the authors, responsibilities of the reviewers, and this is also true of grants, which are of course reviewed, responsibilities of applicants and responsibilities of reviewers, and we'll go over these responsibilities. So first of all, the journal articles. Reviewers should be fair and objective in reviewing manuscripts. Comments should be focused on the quality of the scientific work and not be personal in nature. They must keep the contents of unpublished manuscripts confidential. They should not discuss manuscripts they're reviewing with colleagues or members of the laboratory unless they receive permission from the editor for a scientific consultation. So very frequently in my role as editor-in-chief of Journal of Virology, I will have one of the editorial board members contact me and say, I would like to have my graduate student or my postdoc also review this, work on this manuscript review with me. Is that okay? And yes, that's perfectly fine. As Vince pointed out, that's an excellent way to mentor your student, to learn about these principles. So I don't discourage it at all, but you should ask first. Reviewers must not use information, quite obviously, in unpublished manuscripts for the benefits of their own research program. That should be stated. Authors, okay. All results and data presented must be accurate to the best of knowledge of all of the authors, because if any part of the manuscript is fraudulent, all the authors are held responsible. So this is from an article in the New York Times. Recent disclosures of fraudulent or flawed studies in medical and scientific journals have called into questions the merit of the peer review system, because findings published in peer-reviewed journals affect patient care, public policy, the author's academic promotions. Journal editors contend that new scientific information should be published in peer-reviewed journals. That message, however, has created a widespread misimpression that passing peer review is the scientific equivalent of the Good Housekeeping seal of approval. And virtually every major scientific and medical journal has been humbled by publishing findings that are later discredited. So what are the consequences of falsifying or manipulating data? I'm going to talk about a very famous case because my 8-month-old puppy has decided to join me in the presentation. Okay, I'm going to talk about a very famous case which has caused an anti-vax movement that preceded the SARS-CoV-2 COVID anti-vax movement, and that is the MMR vaccine, measles, mumps, and rubella. It's a live the vaccine consists of live attenuated viruses. The vaccine schedule at 12 to 15 months, and again, 4 to 6 years. The efficacy, 95% lifelong immunization with a single dose and greater than 99% with 2 doses. Measles is not innocuous. So for the first 10 to 14 days, the virus incubates, no signs or symptoms. Then there are non-specific signs, a mild to moderate fever, persistent cough, runny nose, conjunctivitis, sore throat. That lasts a few days. Then acute illness and rash, red spots that are slightly raised in clusters. The skin is blotchy and splotchy. The face breaks out first, etc. Over the next few days, virus spreads down the arm and trunk, over the lower thighs and legs. At the same time, the fever rises sharply, often as high as 104 to 105.8 Fahrenheit, which is very, very alarming. And the communicable period, the measles virus can be spread for about 8 days. It's a respiratory infection similar to SARS-CoV-2, and therefore it has a very high R0. So starting 4 days before the rash appears and the ending when the rash has been present for 4 days. So there are also complications. It's not just, oh, you get a rash and then you get better. Most people survive, but there can be serious long-term effects, especially in children under 5, such as ear infections that can cause permanent hearing loss. There's a form of brain swelling called subacute sclerosing panencephalitis that develops 7 to 10 years after infection and is often fatal. And a 2012 study found that measles may alter your immune system so it forgets how to fight diseases with which you had immunity before the infection with measles. And the introduction of the measles vaccine saw an increase in childhood immunity to many other diseases in the US population as well. So why is there a controversy? The controversy centers on a 1998 publication of a fraudulent research paper in the medical journal Lancet, a very highly respected journal. And the media has been criticized for its very naive reporting of this because the discredited claim was that autism spectrum disorders are linked to the MMR vaccine. And the perpetrator of this was Andrew Wakefield. He had manipulated evidence and fabricated the data and broken other ethical codes. The Lancet paper was partially retracted in 2004 and fully retracted in 2010. And Wakefield was found guilty by the General Medical Council of professional misconduct in May 2010. And he was struck off the medical register, meaning that he could no longer practice as a doctor in the United Kingdom. The scientific consensus is that there is no evidence that links the MMR vaccine to the development of autism, and that this vaccine's benefits greatly outweigh its risks. So, what are the 5 journals with the highest number of retractions? Nature, Science, Cell, New England Journal of Medicine, and Lancet. And why do you think those 5 journals have the highest number of retractions? What else do those 5 journals have? Very, very high impact factors. And individuals who are desperate to have their work published in journals that have very high impact factors sometimes make mistakes. And unfortunately, it can be just one person out of 15 authors, but that would result in the entire paper being retracted, and that has the effect on all of the authors. So there are more subtle examples of data manipulation, unlike Andrew Wakefield's example. So I will give you an example from Journal of Virology. So a reader contacted me that a paper published in February 2013 had what appeared to be duplicated bands that were spliced into gels. So we had our image analysts use a program called ORI Level and Color Overlay. It's done in Adobe Photoshop. And basically these were the 2 panels in question. And when they were overlaid, doing a pixel by pixel comparison, the identical digital images show up as completely yellow, indicating that yes, indeed, this was a duplication. Furthermore, this is an example of the splice, which can be seen quite clearly here. And here is another example where this entire band was spliced into the gel. So the result, panels in 3 out of 3 multi-panel figures had been altered by band duplication, splicing of bands into gels, or duplication of loading controls. So the paper had to be retracted. And this is what a retraction notice looks like. It was described in detail in figure 1B, lower left panel. Bands in lanes 1 and 2 were duplicated in lanes 3 and 4. In figure 1B, lower right panel, the band in lane 2 was spliced into the image. Middle panel, the band in lane 4 was spliced into the image, and so on. Okay, this is an example of another retraction notice from Molecular Cell. This article has been retracted at the request of the editors. Molecular Cell is retracting this article in response to concerns raised by a reader. We contacted the corresponding author for original data and investigated the issues. We determined that the data in 2 figures had been inappropriately manipulated. In figure 4A, a section from one part was duplicated and placed over another part of the image. And in this instance, the authors could not locate the original data. Thus, we cannot determine whether the alteration obscured any relevant underlying data. The authors do not agree to this retraction. Here's another retraction from Cell. In this case, the article has been retracted at the request of the authors. They reported shortly after publication, the lab with whom we had shared reagents noticed that cell lines that were supposed to be stably expressing the GFP FMN2 were not. We subsequently found that a Western blot in the paper had been inappropriately manipulated, and multiple cell lines were not as reported. When we reconstructed and validated the new cell lines, and attempts to reproduce the results were unsuccessful. Based on this assessment, and the postdoc admitted that she engaged in research misconduct by fabrication and falsification of results reported in figures 2, 3, 5, 6, 7, supplementary 2, supplementary 4, supplementary 5, 6, and 7. We are therefore retracting the paper and apologize for the inconvenience that we have caused. And this is what a retracted paper looks like if you look it up on PubMed. And this will be on every single page. So there is no expiration date also on when a paper can be retracted. So there's not a 5-year plan or something like that. It can be retracted at any time if it has been discovered that there was data manipulation or falsification. So this is from an article that was published in the Journal of Cell Biology. What's in a picture? The temptation of image manipulation. So no specific feature within an image may be enhanced, moved, removed, obscured, or introduced. The grouping of images from different parts of the same gel or from different gels, fields, or exposures must be made explicit by using dividing lines in the figure and explaining it in the legends. Adjustments of brightness and contrast or color balance are acceptable, but only if they're applied to the whole image, as long as they do not obscure or eliminate any information. So here are some examples. This is the original image. This is the manipulated image. Adobe Photoshop conveniently removed that band. Here's another example. This is the original image, and this is the manipulated image where a band was spliced in. Now, this one is a little subtle at first, but look at it carefully. This is experiment A. This is loading control A. This is experiment B. This is loading control B. What's wrong with it? The loading controls are the same, even though they're two different experiments. So why is it fraudulent to reuse loading controls? Without a reliable loading control, it's impossible to conclude anything from the assay. If the loading controls have been tampered with, then one has every reason to question the entire figure. So more questions get raised about duplication or misuse of loading controls in figures with Western blots or RT-PCR data than any other issue. And I can attest to that because I frequently have readers contacting me to let me know that they have suspected that there was a loading control duplication in a particular publication, and we have to investigate it. The whole point of a loading control is to be able to see how consistently samples were loaded onto and run, transferred through the same gel. It's against this control that changes in the level of the band of interest are calibrated. So it's important that the loading control be run through the gel from the same loading as the experimental sample. Running two separate gels won't yield a good loading control, even if you use the same pool or lysate, the same pipette men, the same setting for loading. So it is rarely appropriate for the same loading control bands to appear in more than one figure or panel. Here is another selective adjustment of brightness and contrast. So this is the original figure, and you can see that it didn't quite produce the result that the individual wanted. And so they adjusted the contrast so that it did follow the result. So this is manipulation of just one of the lanes. Here's another one. In this case, there was a tool called the Photoshop rubber stamp that removed these bands. Now, the thing is, there could be something important, some information that was obscured by removing these bands. And finally, this is another manipulated image. Here you see a field of many cells. However, using contrast adjustment, you can see that they were not, in fact, all in the same field. They were in different fields. And therefore, they have been juxtaposed in a single image, giving the impression that they were present in the same microscopic field. So that is, again, manipulation of data. So the conclusion is that data must be reported directly, not through a filter based on what you think they should illustrate. So data beautification comes from an article in Nature that says it's a term that comes that is defined as data manipulation of properly acquired data for the purpose of making a figure clearer, more perfect, more consistent with the best images in such experiments. Removing dust from digitized photo with the erasure tool, cropping bands from gels, playing with fluorescence micrographs to enhance a particular effect are all attempts to show better results than were actually achieved. In all of these cases, the data were legitimately acquired, but then processed to yield an idealized, manipulated image. So the journal Molecular and Cellular Biology conducted a pilot study in 2015, and they did a figure check of accepted manuscripts. So this was the final manuscript, and it was accepted. And so from January 14th, 2015 to April 23rd, 2015, they looked at a total of 108 accepted manuscripts. And they had all of the figures, which have to be high resolution once the manuscript, the final form is there. That is, they're no longer PDFs, which are relatively low resolution, but are either TIFF files or EPS files. And they were all analyzed by the image analysts. And manuscripts that had figure manipulation of these accepted manuscripts were 16 or 15%. So original data was required to be sent for those. If it wasn't produced, the manuscript was rejected. As a consequence now, the American Society for Microbiology publishes 12 journals, and all accepted manuscripts have the high resolution TIFF or EPS images submitted with the final version. And the analysts use Adobe software to detect gel splicing, addition or deletion of bands, regions of images, uneven brightness, contrast adjustment, duplication of bands, especially for loading controls. If there's any figure manipulation found, the authors must provide the original unprocessed images along with an explanation for the image processing. The paper is rejected if this isn't satisfactory. PubPeer is a website that allows academics to engage in post-publication peer review. It served as a whistleblowing platform that highlights shortcomings in several high-profile papers. Now, the thing about it is it's anonymous. So therefore, anyone can post on PubPeer anything about a manuscript that you have published, whether it's true or not. They can sort of do their own adjustment of images or their own review. So consequently, there have been accusations of libel that have been leveled at some of its users, and corresponding PubPeer comments are required to use only facts that can be publicly verified. So this has actually not been particularly, it's not a very good site in that sometimes it involves individuals who have in fact not manipulated any data, and they end up having to put original data onto this PubPeer site to prove that they haven't done anything that was wrong. There's another website called Retraction Watch, and this is a blog that reports on retractions of scientific papers. The blog was launched in August 2010. It's produced by 2 science writers, and its parent organization is the Center for Scientific Integrity. So, publication of source data. Some journals, such as EMBO Journal, now require that the original source data be published with the article as supplementary material. So we encourage the publication of source data, particularly for electrophoretic gels and blots, with the aim of making primary data more accessible and transparent to the reader. So please provide a PDF file per figure that contains the original uncropped, unprocessed scans of all key gels used in the figure. The PDF should be labeled with appropriate figure panel number and should have molecular weight markers. Further annotation could be useful, but is not essential. The PDF files will be published online with the article as supplementary source data files. So the take-home messages: do not alter or adjust images in any way. present the data as it was acquired, repeat experiments in which gels, fluorescence images are not of publication quality. Remember to always run loading controls in the same gel. Now we're going to talk a little bit about grant review. So the most important thing about grant review is confidentiality. This is for the reviewers. They are not supposed to discuss any aspect of the proposal. The outcome is confidential. The proposals may not be discussed with colleagues without the permission of the scientific review officer. No aspect of the review process can be discussed with the applicant before or after the study section meeting. What are the responsibilities of the applicant? The results discussed in the preliminary data or progress report in the proposal must be authentic. That is, data cannot be manipulated, overinterpreted, tweaked, or fabricated just because the proposal will not be published. Reviewers base their assessments on the data presented in the proposal, and data manipulation or fabrication is fraudulent. So these are case summaries. These are case summaries from the Office of Research Integrity, which is part of NIH. And what they do is if it has been reported to them, and they're usually through an institution, but sometimes through other mechanisms, that there was something fraudulent that was put in a grant application, they investigate. And if they find that it is true, then you have a publicly, you have a case summary, which is put on a public website. So in this case, we have the case of a former postdoctoral fellow engaged in research misconduct in research supported by NIAID, NIH grants, an R01 and an R21. ORI found that the respondent engaged in research misconduct by falsifying or fabricating data that were included in one publication and 2 unfunded grant applications and 1 unpublished manuscript. So this is all of the data that were manipulated. Now notice, unfunded grant applications and unpublished manuscripts, but it doesn't matter. This was still picked up and investigated. She was found guilty. She's no longer a postdoctoral fellow. And the consequences of a case that does come to ORI and where misconduct has been found is that the individual is banned from funding by the Public Health Service for a period of anywhere from 3 to 5 years. And so this individual's career is basically over. Here's another case summary. Bing Kang, Oklahoma Research Foundation, a former postdoctoral fellow, reportedly falsified data in a manuscript submitted to Molecular Cell, the revised version of the manuscript submitted to Molecular Cell, a grant application to NCI. ORI found the respondent knowingly falsified or fabricated Western blot gel images by duplication, reuse and relabeling, and or alteration through contrast, rotation, or scale of the images. And this included falsified images in the submitted manuscripts as well as in the grant application. And again, the consequences were that this individual is no longer a postdoc and is banned from public health funding for a period of 5 years. Now we're going to change and go to a completely different topic, but it also has to do with publishing and is also very important. So let me pause right there and just ask if anyone has any questions or comments before I move on.
I think there was a question in the chat.
Okay, I don't see the chat on my screen.
That's okay, I can read it to you.
Okay, that would be fine.
Yeah, could you discuss the differences between retractions, corrections, updates, and rejoinders, and the impact that each might have on scientific careers?
Okay, a retraction means that the paper had to be completely retracted, and that's because the results that were reported in the paper cannot be corroborated. That is, that there was something wrong. It's not always that something was, it's not always that there was scientific misconduct. It could be that there was a genuine problem An individual thought or the laboratory showed that a particular cell line did X, Y, or Z. And on further examination after the paper was published, they discovered that in fact there was some contamination of that cell line that they hadn't realized. And in fact, once they purified it, that no longer those conclusions were valid. The paper is retracted. However, the explanation would most probably not hurt the careers of the individuals who had to retract the paper because it was an honest mistake. On the other hand, if a paper is retracted because of data manipulation or falsification, then it not only affects the individual who committed the data falsification or the manipulation, but it affects all of the other authors as well, because you have to put on your CV that you have a paper that was retracted. And therefore that's not a good thing. Now, the other ones were, I forgot the other.
It was corrections.
Oh yeah, authors corrections. Those happen all the time. That's really simple. It doesn't mean that there has been any manipulation. Sometimes, so for example, when you're putting together a multi-panel figure, sometimes there's a mistake and you mix up a panel or something like that. It's brought to your attention by a reader or by an editor. You go back to the original and say, oh yeah, I did make a mistake there. So then you publish a correction and you just explain, and it doesn't change anything in the paper. The results are still fine, and that won't have any effect on anybody's career. Also, erratum is another category, and that is, again, when there's some sort of simple mistake that doesn't affect the results, it doesn't affect the conclusions, and again, that won't affect anybody's career. Okay, I'll move on then. So what is plagiarism? It's a general, it includes the theft or misappropriation of intellectual property and unattributed textual copying of another's work. So in other words, copy and paste of somebody else's work. So in verbatim plagiarism cases, subjects have inappropriately used text that originally appeared in textbooks, journal articles, conference proceedings, scientific proposals, electronic media, or other sources. If you use text that's authored by others, if it's put in quotation marks, indented or otherwise highlighted and attributed to the original author, that's okay, although most people don't quote in journal articles from other people's work. But if a writer fails to properly attribute the original author's text, then that's a violation of a basic tenet of the research community by passing off words or composition as his or her own. Also, the direct copying of phrases or sentences from others' published work violates copyrights agreements. Okay, so once you publish, you have to sign a copyright. Self-plagiarism, I know that sounds like an oxymoron, but it actually describes the practice of publishing the same article in more than one journal, and believe it or not, that happens, or recycling sections of text in more than one article. So this is most frequently found in the introduction section of a paper and sometimes in the discussion section of a paper, where you are working on the same protein or the same process, and therefore you simply use the same paragraphs that you used in your last 4 publications to begin the introduction. That, unfortunately, is self-plagiarism and violates copyrights and is a no-no. So these are allegations by the Office of Inspector General at NSF. And in that case, they reviewed a number of allegations, and intellectual theft and verbatim plagiarism were at the top. So 61% of their findings of misconduct were plagiarism, while only 17% were fabrication of data. So here is an example of an investigator at the University of Texas Health Science Center. This was, again, a case that was studied by ORI, the Office of Research Integrity at NIH. They found that Dr. Jiang engaged in scientific misconduct by plagiarizing and fabricating data in an NIGMS grant application R01 genetics of human pigmentation, etc. He plagiarized text from another researcher's grant application that he had obtained during the NIH confidential review process and used it without appropriate citation. So first of all, it was a confidential review process, but even worse, he copied text and then wrote a grant application on it based on the grant application that he was reviewing. Okay, so there's a computer program that was developed at NIH and it's now used by almost all journals, and it's called Crosscheck. And it evaluates the extent of plagiarism and looks for patterns by attempting to quantify the extent of common use of phrases between two or more question documents. So Crosscheck is run on every single manuscript that is submitted to an ASM journal before it is sent for review. And if it is found that the Crosscheck shows more than 40% similarity or identical phrasing in certain sections. Now, obviously, the materials and methods are not included in the Crosscheck because there are only so many ways that you can say how you performed a particular experiment. Also, the results are not included in the Crosscheck because presumably you're reporting new results and not results that you've copied and pasted. But what is put in almost always is the introduction and also the discussion. And then if it is found that you have copied and pasted too much, then the manuscript is sent back to you and you are told to fix it before you resubmit. So this has been very useful, and it's unfortunate that we have to do all of these things to check papers. That's why it takes a while for your papers once you can submit them before you find out the results, because they have to go through all these processes to make sure that you've done everything above board. But that's the way it is. So the take-home lesson is don't copy phrases, sentences, or paragraphs from any source, even unpublished. Better yet, don't copy. And that's basically it. All I have to tell you about today. So I'm more than happy to answer any other questions. As I said, I can't see the chat box, so.
I don't see any other questions in chat, but feel free to chime in if you have a question.
Yeah, just unmute if you have a question.
I have a question.
Okay.
So is it considered plagiarism, for example, if you're reusing phrases from one of your publications in an R01 application, for example?
No, that is not considered plagiarism because you have to back up and support the data in the preliminary results or the progress report. So that is an example where it's not plagiarism. Also, in your PhD thesis, you're not plagiarizing if you're using the same language that you did in the publications that resulted in your PhD thesis. So that's okay.
Thank you. Oh, another question. Is that software, the Crosschecker, available for public use for us to use to check our own work?
Yes, it's available, but it's extremely expensive. So I know a couple of labs that have actually resorted to buying it. The reason being that they have a very large number of postdoctoral fellows who are not native English speakers. And as a consequence, sometimes find it easier to cut and paste from someone else's well-polished English. And so they run it, but as I said, it's expensive. So it's not something that the average investigator will have.
Thank you.
Okay.
You're
Vince,
muted, Vince.
All right. So if
Vince, did you have a question? There you go.
No, I was just going to ask if there are any other questions for Roz, but Roz, thank you so much for taking time out of your day. Really appreciate that, especially so late in the day. The information you shared with the group is stuff that when you're in this business long enough, you've come across it, where people are cutting and pasting from gels and things of that sort. And it's sad to say, but it happens, and it continues to happen. So anyways, thank you for that. I think we're done with the meeting.
Okay.
I just wanted to chime in. I totally forgot to mention this earlier when we started. You guys will be receiving an email with a red cap link for evaluation. Please take a minute to fill that out for us. You don't have to do it tonight. You can do it tomorrow or Monday, but that's really helpful for us.
Okay.
Thank you all for participating. Really appreciate it.
Bye-bye, everyone.
Thanks to all the
Take care.
speakers.
Bye-bye.
Everyone.
Thank you. Thank you guys for spending your
Thank you.
Saturday with us. Have a great evening.
Bye. You too.
Thanks, everyone.